In Kraków, a remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city centre. Besides monuments entered on UNESCO Heritage List, Kraków has something else to offer. People. In Kraków every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Kraków. Kraków has become the center for modern services in Europe. Kraków is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Kraków is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Kraków, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Kraków is increasingly associated with excellent cuisine. Its restaurants, offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków.
Welcome. My name is Kazimierz Murzyn, and I'm the Managing Director of LifeScience Klaster Kraków. I am honored to say welcome at this event, LifeScience Open Space, for 14th time. It is the third time we are meeting on online instead of face-to-face, as it used to be before the COVID pandemics. The idea of getting together on one open space and letting people engage in partnership that would eventually bring innovations for health and quality of life was raised in 2008. The rationale behind that was pretty simple. Suppose we are the community of scientists, businessmen, policymakers, doctors, innovators, students. So what is the best way to exploit this capability behind such a variety? And the answer was pretty simple. Why don't let those people talk face to face about the ideas, projects, other issues they really care about? And that was the beginning of LifeScience Open Space. And this is the key value proposition of LifeScience Open Space since the beginning, because the event is precisely about what you, partners and participants of this event, the members of innovation community, need to success in delivering innovative solutions for health and quality of life. May it be the piece of technology, the other partners, may it be the solution to the problem, or just a little inspiration or funds, whatever. It's not about us organizers. It's about you. What you should listen. About you. What you want to achieve through collaboration. So it's about you pitching the collaboration offerings. A collaboration offering is the short talk about conditions, assumptions, and needs presented in a way that makes it easy to learn about the nature of the proposal and assess whether it is worth discussing the details and engaging in partnership. That's the basic idea. Why do we expect to have an impact? By inviting a diversity of expertise and different perspectives, because we know that innovations happens thanks to collaboration, and we know that this need for partnering will only increase over the time. This year, we decided to focus on cancer, on the fight against the cancer. For the first time, we decided to take a focused approach. We did that to highlight the importance for collaboration, of interdisciplinary collaboration. If we want to have an impact, we need to connect technologies and approaches. And if you want to fight cancer within 25 years, health tech, food tech, and environs must not remain the separate domains of research and innovation. We know that all three domains are important, but we must do more to build a synergistic approach between them. So we need more collaboration in fighting the cancer. That's the key word. That's the slogan for this event. Having said that, let me introduce our new approach to organizing this event. Our approach, which we decided to introduce since this year. We are, as you probably noticed, we are now on the new collaboration platform, which has the same name, LifeScience Open Space. This way, we aim to integrate the life science communities during an annual meeting and throughout the year. So we'll not meet only today and tomorrow and after tomorrow, this week. We want you to be engaged in collaboration all over the year. The opportunities and challenges come and go before conferences and events. So why not to have this type of tool, this type of platform, whenever there is a need or there is an opportunity. So please explore the LifeScience Open Space collaboration platform to your advantage. And do it free till the end of January next year. Before that, we will ask you to stay longer and stay forever. We'll see. Among others, you should pay you should pay special attention to the LifeScience Open Space marketplace on the platform. This is a functionality which allows you to present your offers, your requests, your problems on permanent way, and they are not limited only to the session talks. So you will find there both the sessions, the needs, the project collaboration offerings from the sessions, and also from the other fields, and not only from our community, but also from all over the world. Regarding the program, we have divided, as usual, the event into the thematic tracks, business development tracks, and life science startup scene. Regarding thematic tracks, those events, those sessions feature discussions and cooperation offering opportunities in 3 categories: open innovation, project results, and challenges. Those sessions are devoted to scientists, innovators, entrepreneurs, doctors, brokers, investors, and officials. Those people who share a commitment to and drive for cooperation and solving problems, facing challenges, and developing interdisciplinary innovations for health and quality of life. So day number 1 today is devoted to health technologies and solutions for cancer partners. Here we have 2 partners. Here we have 1 partner, the SANO, the Center for Computational Medicine, and here we try to answer the basic questions: does progress depend on a single technology or on our capacity to combine many technologies? That's the day for number 1. Day number 2, food tomorrow, food technologies. This will be the solutions for cancer patients, and here we have 2 partners: EIT Food and Intermac, the company. And tomorrow we will talk about what to eat to keep cancer away. That's a very important thing because it's happening every day. And third day of the event is devoted to healthy environments, which is connected to avoidable causes of cancer. Here we partner with the Mineral and Energy Economy Research Institute of Polish Academy of Science, and here we will address the answer. Kind of difficult answer. Are we so stupid to deliberately create an environment that we don't want to live in? These are three thematic tracks. Then every day, starting today, we will have the life science startup scene devoted to the brave ones. From early detection to more efficient treatments, food ingredients, or environmental screening, startups can make the difference in fighting the cancer. And every day after the thematic sessions, we will open the scene for the startuppers. Every day we partner with organizations that offer different perspectives. The first day today it will be Cobin Angels, the investors organizations. Tomorrow it will be EIT Health Hub, which is actually us here in Kraków. And on the Wednesday we will partner with Berliner Hochschule für Technik. All 3 are very interesting and focus again on the needs and collaboration and for startups or those beginners. Then on Thursday we will have strategy and management track, and in that track we change a little bit perspective to explore the challenges and paths of career in life science and business development in life sciences. Both managing people and process require different set of skills to lead the fight against the cancer. Told from the perspective of managers, we aim to complement this session with the collaboration part of the event. The business we stay at the position that business environment is no less important than innovation capabilities. So here in this session, in this day, we partner with the Exec Minds and Bioforum. And finally, inspirations in the program. We meet in person during the inspiration sessions on Thursday, November 24th, late afternoon on Kazimierz in Kraków. And This session is totally different. This session is organized because we all need inspiration, and what better? And actually, is that the question is, what is the better way than to talk face to face with other people and engage in disputes? What is better than meeting like-minded people with passion, vision, and purpose who shape the reality and impact our environment? And again, what is the better than listening to stories told by people who have already achieved success or strive for it, persistently becoming examples for others? And I'm still determining what is the best answer for it. So we decided to provide you with not only the food for the minds, but also for the body and for the soul. You will be inspired by emotions and excellent food and drinks. Our special guest will be Dr. Maciej Kawecki, whose motto is, I bet on a man who understands that technology is just a tool in his hands, with which he should positively change the world. Very interesting beginning of the discussion. Okay, so I mentioned few partners, but the list of partners is long enough to excuse not mentioning all of them. Let me highlight the strategic partnership of the city Kraków, which has traditionally partnered with LifeScience Open Space. So thank you, Kraków. I was looking at I was watching the movie. For the first time, I've seen this movie, and I was pretty much impressed about what was presented in this nice movie. That's the everything I wanted to say at the beginning. May I introduce now our guest and the first leader of the sessions? As mentioned before, we are partnering with we are not realizing this event alone. So we are partnering with organizations which lead the sessions, which give the name, give the face to the sessions. And our first leader today is SANO, the Center for Computational Medicine, and the leader and our guest is Professor Marian Bubak, the scientific director of SANO. So, Marian, in a few words, before you start, how do you think your session will go, or you want to skip this and save this for your introduction?
Well, I can. My idea for this session was to organize this in such a way that at the very beginning we'll have talks of keynotes who have done something very important in the area of fight with cancer. So, and I think that it will be a good, with these keynote talks, it will be a good introduction to the whole area. And then we will have a series of presentation coming from different teams with different expertise, and it will somehow will be a kind of offer for collaboration. So I hope that after these two sessions, there will be a new network between different group of researchers, engineers, and of course medical doctors. And well, we hope that besides the presentation, there will be also a space for and time for discussion. So we hope that it will be not just something which is similar to conference, but it will be just a first step towards something which will be more productive.
I know the sessions is pretty loaded, which means that there will be little time for questions and answer sessions during the program.
Yes, so probably I will repeat this at the beginning of the session, but the idea is to have something like 10-minute slots after 4 or 5 talks in order to, let's say, to have discussion, to get detailed explanation, and maybe also for our for people who will attend in the session, just to take notes about, let's say, the most important for the partners for future collaboration.
Yes, the sessions will be recorded and will be presented, will be made available on the platform again after the conference. And also I advise you to go to the partnering part of the event on the platform, and there find your partners, connect with the speakers, connect with other participants, and make appointments. That's something which is very useful during this type of conferences, and something which will help you to gain as much as possible from being here with us now. Of course, the partnering platform allows you to connect with others not only during the event, it's also possible after. It will be possible after the event, so you may decide when to connect and how to explore this. Again, I advise you to go to explore the platform to find out many other possibilities, opportunities for collaboration, not only those which are presented here. Because we have still 10 minutes time to start the session, so I propose that we, for the moment, go off the line, play again the commercials, if I may say, and we'll be back after the commercials. Thank you.
In Kraków, a remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city center. Besides monuments entered on UNESCO Heritage List, Kraków has something else to offer. People. In Kraków every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Kraków. Kraków has become the center for modern services in Europe. Kraków is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Kraków is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Kraków, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Kraków is increasingly associated with excellent cuisine. Its restaurants offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków.
SANO – Centrum Zindywidualizowanej Medycyny Obliczeniowej. Projekt realizowany jest przez AGH Cyfronet, Klaster LifeScience Kraków oraz partnerów zagranicznych Uniwersytet w Sheffield z Anglii oraz Fraunhofer Gesellschaft i Juli z Niemiec.
Główne wartości, jakie przyświecają SANO, to pasja, to innowacja, to wielokulturowość i zrównoważony rozwój. SANO w języku esperanto oznacza zdrowie.
W ostatnich latach jesteśmy świadkiem olbrzymiego rozwoju metod pozyskania danych o pacjencie, jego chorobie w ujęciu indywidualnym, jak i w ujęciu populacyjnym. Jeśli nie wykorzystamy takich metod, to bogactwo danych, jakie gromadzimy na temat pacjentów i ich chorób, zostanie zaprzepaszczone.
SANO jest instytucją badawczą, która prowadzi badania z zakresu medycyny obliczeniowej, gdzie próbujemy wdrażać rozwiązania bazujące właśnie na metodach obliczeniowych oraz sztucznej inteligencji, które będą mogły znaleźć zastosowanie w praktyce.
Staramy się tworzyć coś takiego jak awatar pacjenta, na podstawie którego możemy właśnie symulować różne procesy i podejmować decyzje bez konieczności ingerencji w tego żywego bliźniaka.
Takie działania mogą skutkować tym, że lekarze będą mieć troszeczkę więcej czasu, w związku z czym będą w stanie zaopiekować się większą liczbą pacjentów niż aktualnie.
Przykłady takich obliczeń, które wykonujemy, są to chociażby trenowanie modeli sztucznej inteligencji, takich jak sieci neuronowe. Wymaga to często wielu godzin pracy takiego superkomputera. Często uruchamiane są zadania, które wymagają faktycznie kilkuset czy nawet tysięcy procesorów działających równocześnie, równolegle.
Kiedy zrodził się pomysł wśród członków naszego zespołu, uznaliśmy, że tym naturalnym kolejnym krokiem jest, że się tak wyrażę, instytucjonalizacja tej współpracy.
Teaming for Excellence pozwolił na powstanie Centrum Doskonałości, jakim jest SANO. Współpraca z NCBIR-em pozwoliła nam na złożenie projektu finansowanego ze środków unijnych w ramach Horyzont 2020 Teaming for Excellence. Dzięki NCBIR-owi możemy tworzyć Centrum Doskonałości wraz z innymi partnerami.
W przeciągu 7 lat realizacji projektu Teaming for Excellence planujemy zbudować centrum samowystarczalne, którego jakość wyników naukowych pozwoli zdobyć kolejne finansowania na trwanie i rozwój.
Mamy dostęp do najlepszych specjalistów, takich jak eksperci od symulacji z Sheffield, czy też eksperci od superkomputerów z Niemiec.
Jest to taki miks kulturowy, ale też miks różnych doświadczeń akademickich i badawczych, co napędza właśnie taką kulturę innowacyjności czy kreatywności w SANO.
SANO jest takim centrum, które staje się ważnym punktem do współpracy naukowców, którzy mogą wymyślać nowe tematy badawcze, także spotykać się. No, przykładem tego są chociażby seminaria organizowane, zbudować taką masę krytyczną, umożliwiającą prowadzenie badań na rzeczywiście światowym poziomie.
In Kraków, A remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city center. Besides monuments entered on UNESCO Heritage List, Kraków has something else to offer. People. In Kraków every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Kraków. Kraków has become the center for modern services in Europe. Kraków is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Kraków is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Kraków, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Kraków is increasingly associated with excellent cuisine. Its restaurants, offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków.
Good morning. Welcome to the first part of a health tech session of Life Science Open Space. I'm Marian Bubak, I'm Scientific Director of SANO. And I would like to introduce a keynote speaker of this first session in this series. The keynote speaker is Leonor Cerkerda-Alberich, and Leonor is one of the main researchers in our PRIMASH project. PRIMASH project is probably one of the largest and ambitious European research projects in application of medical imaging and artificial intelligence in order to fight with childhood cancer. Leonor has started his scientific career as a physicist For almost 5 years, she was engaged in particle physics. She spent some time at CERN, and finally in 2018, she obtained a PhD degree in physics cum laude. And at that time, being involved in analysis of data from particle physics, she got acquainted a quite large portion of knowledge how to deal with this data. And then it was very natural that she moved to application of this knowledge into analysis of medical data. At that moment, she's working, leading a group at LifeScience Health Research Institute in Valencia. And she's still somehow continuing what she started in physics, however, in application to health. So, welcome, Leonor, floor is yours.
Thank you very much, Marian, and thank you for the invitation to this important session. So first of all, I'm going to share my screen. Okay. Okay, so you should be able to see my presentation now. So first of all, I just wanted to give a brief introduction of what I would like to speak. So as Marian was saying, I'm working in a European project. This is called Pre-Match. And basically it's a project that well, there's 16 European partners and was financed by the European Commission at the end of 2018. And now it's really close to completion. So I think it would be very interesting to tell those achievements that we have accomplished during these years, the things that we have learned, lessons learned, and also some some small recommendations for projects in AI, medical imaging, radiology for the future. So yeah, when we are speaking about the Pre-Match project, this project proposes an open cloud-based platform to support decision-making in clinical management of 2 pediatric cancers. They are neuroblastoma and DIPG. I will tell briefly about them now. But what Pre-Match wants to do is to implement the latest advancements in of in silico imaging biomarkers and also modeling of tumor growth towards a personalized diagnosis, prognosis, and therapies follow-up. So in order to do this, basically, I'm going to focus a lot in this talk on imaging, because of course it's my main task in the LifeScience Health Research Institute and as a scientist there. So what we do is to use the clinical practice images like MR, CT, PET images that are used to diagnose and to do the follow-ups of these children, to actually extract information that can be useful to have an impact on the decision on treatment on these patients. In particular, in these 2 types of cancer, neuroblastoma on one side, this is a rare disease in children, but it's still the most frequent solid cancer of early childhood. So, and then also we have this DIPG, diffuse intrinsic pontine glioma, that is the leading cause of brain tumor-related death in children. It's also a very rare disease. So one of the bigger challenges in this project is to have and to collect enough data to develop models that are robust and reproducible and that can be useful for the oncologists and the radiologists in their day-to-day practice. So here in this slide, I just wanted to show what we would call now the virtual biopsy in oncology. So this is applied in this project, but can be applied to any other projects related to cancer and medical imaging. So what we are trying to do is to use the medical images that we have from clinical practice to actually extract those information from them that cannot be seen by our eyes. So by using artificial intelligence to try and predict and diagnose these children in a more accurate way that can actually have an impact on the treatment. So therefore, we could extract information about where the tumor is, what the physiology of this tumor consists, and related to that have correlations between phenotype and the genotype and the aggressiveness of this tumor, or the prediction of survival for the patient, cellularity, angiogenesis. So this is all information that can be extracted in a surrogate way from the images. But at the end, the most important is to have an impact on the decision on treatment. So providing probabilities of treatment response, confidence levels on the results, be able to affect and modify treatment in type and way, and also probably have an impact in radiotherapy. So in order to do this, I'm going to show you the image processing pipeline that we are using at the moment in the project. So for this, we have different input images that actually relate to the morphology, the perfusion or the diffusion processes on the tumor. So for this particular case, we actually analyze and prepare all these images as they are part of the real world data where all the images have a high variability. So we need to actually apply different types of filters and corrections and apply harmonization algorithms for bringing them to the same common space, like a same harmonized framework where all these images can be then compared and analyzed, and the results are somehow robust and can be trusted. So for this, we apply different sorts of processing algorithms. So everyone who is here, like more from a technical background, probably has been preparing and processing their data before actually extracting information and developing models with it. Some of it is, for example, registration of images to have them in the same spatial common space, and also perform tissue segmentation. In this case, we perform tumor segmentation. Then we actually perform image processing, extracting quantitative data like radiomics or deep features. And we also are able to extract dynamic information from these dynamic sequences that come from the magnetic resonance, for instance. And we can have like these different biomarkers like the apparent diffusion coefficient that will give us information about how the movement and the mobility of the water molecules in the tissue, in particular within the tumor. And this is known to be somehow a biomarker that relates to tumor aggressiveness. Also, we can integrate all this information coming from images with other types of data, clinical, genomics, pathology, to actually end up producing these predictive models. We will see the models that we have developed so far in the project in the next slides. So in particular, I wanted to start with a very medical imaging hot topic. So it's the automatic segmentation of in this case, tumors. In this particular case is for the neuroblastoma. We have been using this NNUNet framework that has been shown to produce very robust results in the field of automatic segmentation and deep learning. And we wanted to compare this to what is the variability that we would observe if different radiologists would actually segment the tumor manually, and if both sets of results would be comparable and compatible. So here you can see after we trained this model with our data, how we actually see the on the left, the inter-observer manual segmentation variability, on the right, the one comparing the manual and the automatic tool variability. And we can see that both dice coefficient and the area under the curve of the rho curve is really, really compatible and very similar. So not only we were looking at these two metrics, but we wanted to check when we were looking at the direction of the metrics, well, what is the direction of the errors we're committing? So basically, is it that we are actually segmenting part of organs that are not the tumor, or we are missing maybe a few of the voxels that form the tumor? So in this case, what we would like ideally is to try and have a better performance regarding the false positive rates. That means that what we wouldn't want is to actually identify or select voxels that belong to other structures, for example, the liver or for example, the kidneys, right? So what we would like is, if we need to commit a tiny error, probably is best to have it in the other direction, to try to be more basically a bit more aggressive on the segmentation and only segment those boxes that actually belong to the tumor. And what we saw is that the automatic segmentation model actually achieves a better performance in this case, and this could lead to a better and more robust analysis for example, for radiomics, or for other type of extraction of imaging features afterwards. This would be a couple of examples of this segmentation. So we would have two cases here on the two different rows. Here we would have in the first column the segmentation produced by the model. The second column is the segmentation produced by the radiologists, and on the third column we would have this comparison between both. After we have segmented our tumor, we can extract information from these images. We call this radiomics in the field of medical imaging, and radiomics is basically the extraction of quantitative imaging features that have a physical meaning and that actually give you information based on mathematical expressions that are known beforehand and are related to different types of features, such as shape or intensity of the voxels, or the relation between different voxels that are in neighbors. This is produced by these different gray level matrices. So within all this information, we can look at different type of like filters and wavelets, or basically giving you sorts of new quantitative variables that could be actually potential biomarkers for predicting the clinical outcomes. We can do this in a more traditional way, as basically as using these radiomics, or we can do this with artificial intelligence as well. We call these deep features, as we can use neural networks to actually extract this information. But in this case, as you know, in the field of medical imaging, we don't have like large data sets like with millions of images that are already labeled to be able to train. So what we can do is to use these models that have been trained on the ImageNet data sets, for instance, and to try and extract this quantitative information from the medical images without having to train the models. So we just use the model that has been trained on this other data set, extract the information using the weights that come from this other model, and instead of predicting the different classes that the original model is made for, we just extract a vector with quantitative information that actually can be used as independent variables, where each one of them is representing something different from the original image. With all this information extracted from the images, this is a screenshot of the current platform. We can see that we have a visual analytics framework where we can play with these results and extract groups from them. So for instance, we can see different patient clusters where the different data that we are using, like we can actually integrate clinical data with like patient age or like the risk group for the patient with radiomics, for instance, and create these different clusters that can be useful to actually identify or correlate new patients to other existing patients that we have in the database. I'm going to show now a couple of models that we have built. In the first one in particular is this model that we wanted to predict the overall survival of the patients. For this, I will go a bit fast on all the details, but as you know, in data science, so we have to do a lot of data cleaning before we start developing a model and actually transforming the features depending on if they are categorical, they are numerical features, and then combine the different sources of data, so clinical, molecular, radiomics, imaging. So what we saw, first of all, is to try and explore what this data contains and what the correlations are. So in our case, our target feature, as you can see here, was basically the survival of the patient. If the patient has had an event of death or is still alive. And then we wanted to correlate the different features that we had, being categorical or being numerical features, to the target, to basically knowing if the patient is alive or if it's dead. So in this case, we use different statistical tests and different algorithms to see the correlation of these individual variables with the survival of the patient. We saw already that some of them could be potentially more important than others. And then we developed this training methodology where we were performing a nested cross-validation, where all the faults were stratified to represent the target class imbalance. And we used for this analysis the core concordant index of the IPCW. So basically it's very similar to the area under the curve of the ROC curve for this sort of survival analysis. And you can see here, in this case, the different survival analysis that we have been exploring, different types of architectures and models, different types of data curation and processing and data selection algorithms, very well known, like principal component analysis, removing outliers, new methods like Poruta, for instance. And then here we would have on the right the different results. We could see them for the different metrics for the train and for the test set. And then we could see in this case how this random survival forest model or the survival model with additional trees was working quite well for both train and test, so basically giving a good generalizability for the results. Here we would have some nice plots at the moment of this area under the curve as a function of time. So as it's a survival analysis, we can actually analyze this over time. So we have different accuracies depending on the survival of the patient. And on the right, we can see as well the Kaplan-Meier plots, where we can see the different survival Kaplan-Meier curves for different patients in particular that could come into the platform, and then the clinician would have this information available. We not only just look at this from a point of view with like basically like a supervised analysis, but we also perform unsupervised analysis, where we actually perform different filters and correlations to actually end up extracting image-based signatures that when we are applying different unsupervised algorithms, it actually gives us different groups of patients that actually correlate to survival. This in particular is for DAPG patients, where we have actually extracted radiomics information. We have performed some transformations based on some sort of Varimax rotation is very similar to the process of a PCA, basically. And after this, we have used a K-means algorithm for extracting different clusters. And we can see that actually these two clusters of patients we have extracted correlate very well to the overall survival of the DAPG patients. In particular, it's very relevant for the clinicians, and as 9 months in particular is a very critical time for these patients, and we could help to actually deliver and select a treatment for a specific patient if we know beforehand that the patient is expected to survive more or less than these 9 months. So finally, to finish this talk, I just wanted to add a couple more things. One is that in the platform itself, we don't only give models and provide models, but we also provide visualization for these models so the clinical users can understand the results that we are providing. So in particular, this is a visual analytics for outcome predictions where we can actually see the results from this. In the top, we can see the results of this survival model that we just talked about. So we would have the survival on the x-axis, and we would have the uncertainty per survival time. So we would know if these survivals that we are predicting have actually a high or a lower uncertainty, and clinicians can trust this result more or less depending on these results. We could also have different types of visualization to compare patients or to compare different cohorts. And in this case, we would use different explainability resources at the moment that are being used to understand how much each particular imaging or clinical variable impacts in the result. And then if that makes sense for a clinician to understand this result. Other types of visualizations relate to measurements correlation. We can see here an interactive matrix where we can actually see the correlation between the different variables, and also between the different sources of data, and we can actually filter by different variables like age or stage or presence of metastases, etc. Finally, we have added these very nice features, which is to include the provenance history. And I think it's very important because it needs to provide trust, accountability, and explainability when we are actually providing and delivering this sort of platform for clinical decision making. And this can actually account for both data and algorithm traceability. So basically, we can replicate all the results based on knowing which data set with which filters and variables, and actually which algorithms with which parameters and hyperparameters have been used to develop a particular solution. So yeah, finally, I just wanted to say that the most important at the end of the project now will be the implementation. So we need to implement all this information in practical, in clinical practice, and for this we will need to continuously iterate over these results and improve accuracy in the treatment decision with the feedback of clinicians and interaction with the technical and engineers experts. So thank you very much. I just wanted to thank you again to my research group in Valencia and everyone, and I'm happy to take any questions.
Well, Leonor, many thanks for presenting well in this way what is pretty much about, and it is, as you have said, it is a quite complex project with 16 partners over Europe, and analysis of images is a very important part of this project. However, we have also teams which are interested in modeling of growth of tumors, and with different approaches. Yes, so we have in Primash we have a team from Bologna, a team from Sheffield. Can you maybe we have still 2-3 minutes? Can you tell something about these other aspects?
Yes. So basically, of course, I focus a lot of imaging as it's the core of my research. But in the pre-match project, one of the nicest things is that there's 4 more partners that are also working on this development of modeling of tumor growth. So basically, for this, they just use in silico methods to basically model how the tumor should behave based on very, very basic inputs. Actually, the models are very complex and require a lot of computational demand. And so far, the results that we are having in the project are showing how well it actually only from very little information as input, as for instance, some of the epidemiological data from the patient, and also a little bit of data about the cellularity of the tumor that can be extracted from the images, or the information from the data related to the angiogenesis that also can be extracted from the images as surrogate biomarker. With all these little ingredients, they are actually being able to produce models that can actually simulate how the tumor is going to grow and how it's going to behave after like certain amount of time. So yeah, like in this particular case, there's I think it's University of Sheffield are working on this, Bologna as well, also University of Zaragoza in Spain, and also chemotargets. So there's different partners who are actually working together on integrating this big model where each one of them uses different input information to actually provide a very nice tumor growth model that could help and add more information to this to the project. I have here at the beginning of my slides a nice view of what the project would integrate. And as you can see here, all this first part that I have been mentioning is about the image acquisition, processing, radiomics. And then we have here this nice block about multi-scale models, about how we can actually inference how the tumor is going to look in 1 year time or 2 years time. And this input can be also very useful to actually predict what would be the best treatment for a specific patient, what would be the infiltrations that this tumor is expected to have, how it's going to react to this particular treatment, or have a better prognosis for the patient. So it's all part of the project, and it also needs a lot of computational demands. And so, for instance, there's also a big collaboration with with computational and cloud and systems and partners who are also that you, Marian, and your team are part of. So to provide the computational infrastructure to actually be able to develop these models. Yeah.
Many thanks. I think that for, let's say, for technical reason, we have not too much, not more time for questions. But I think that first of all, there is a website of a project. The results of the project, because it is funded from public money, the results are available and to everybody who would like to profit from this. It's also to a contact on the website of projects. There is also a way presented how to contact different teams. And I think that if somebody would like to discuss something special issue related to imaging with you, it will be also possible to use LifeScience open space platform. So many thanks for your inspiring for the whole session talk. Thank you very much.
Thank you.
Well, after this keynote lecture, we will go to a kind of, let's say, collaboration offer part of this session. And it will be split into two parts. In the first part, we will have 4 10-minute talks. And after these 4 10-minute talks, we will have a 10 minutes time slot for discussion. And what was presented during these 4-minute talks. And because of, let's say, this time constraints, I would like to ask all participants of this session to keep this 10 minutes limit. So it's very important. I think that, you know, it is these talks will be just opening ways to future collaboration. So the platform of Life Science Open Space will help us. So it's just we think that this 10 minutes should be enough. And so let's start. The first speaker of this session will be Professor Witold Zwinner from Institute of Computer Science of AGH University of Science and Technology. Well, Witold, floor is yours.
Okay. First of all, thank you, Marian, for your invitation and the short introduction. Because we are short in time, so we have only 10 minutes, so let me go to the merit now, okay? First of all, I'll share my screen and my presentation. Okay. Okay. Can you see it? Hello?
Yes, we can see it.
Okay, good. So I would like to speak about efficient computational frameworks for data assimilation in planning anti-cancer therapy. So the main motivation of using mathematical models in computational oncology is the precision of predicting cancer progression, remission, and recurrence. So on this base, we can plan personalized therapy, and we can plan anti-cancer treatment. Okay, so the motivations are rather strong because when we go down deep, so preparing, for example, multi-scale models of three-dimensional cancer. So such the model is very computational demanding, and especially what is very difficult to skip is that all these models are over-parameterized. So when we see on the schemes on cancer treatment methodology, cancer treatment workflow, all the time you can remark that the three principal factors should be somehow connected. I mean, data, computational model, formal model, and data assimilation scheme. So data assimilation is a procedure, very important procedure from the boundary between computational science and machine learning, which tries to train our model to given set of observations, set of data. So during assimilation, so one big problem in assimilation, for example, is the parameters matching of a model. So how we do it, in classical way. So we have a baseline model, and this model is complicated. So it has 30 or more parameters. So we have also data, and using well-known methods of data assimilation like Bayesian computing, Kalman filters, 3D-var, 4D-var, we are trying to assimilate, to match the data to the model and much to measurements. Yeah. So this task for so many parameters is huge. I mean, it's impossible to make it during the reasonable computational time. So what we have to focus on? First, we have to focus on selecting a sufficient mathematical model of tumor. Sufficient, I mean, say the type of tumor we simulate, the stage of tumor development, and also our computational resources and time. So the second, and let me concentrate on this, is define efficient data assimilation scheme for fast estimation of model parameters. So in our experiments, we use a 3D single-phase melanoma model. This is a model of moderate complexity. It consists of 5 diffusion reaction PDEs, main phenomena which is responsible for cancer growth and shrinking during anti-cancer treatment. So our model has about 33 parameters, and in fact it is hybrid model because it consists in continuous part when we calculate from a question the concentration of, for example, oxygen field, tumor cell field, and so on. And we have also discrete part, I mean, this is vascularization. So you can see the layout we are working on is pretty complicated because as I've told, the model is hybrid. We realized this model using 2 different computational engines, and we realize it on many GPU cards. So we think that our model is very efficient computationally. Anyway, it took several hours to make a single simulation. So it's pretty complicated. In our experiment, we assume a very idealized treatment. We assume that we have a tumor of a given size, and we administrate drugs. In this moment, after tumor shrinking, after remission, we observe recurrence. So we can select the second moment of drug administration and so on. We would like to optimize this procedure. So optimizing the time, the number of drug administration, and the dose of the drugs we implement. Yeah. Okay, we have also the training interval. In this training interval, we have some data, and we are trying to find the model to follow the data and is able to predict the further treatment. Okay, in general, I've told this is an idealized plot because in general, as you can see, we have data like that. So if you follow this red line, this is for one patient. This is a change of tumor during treatment after using PCV chemotherapy for many patients. So what we propose, what data assimilation schemes we propose. The first, we propose so-called, well-known in machine learning, knowledge distillation scheme. It means that we have a teacher model, a very complicated model, and due to, knowledge transfer, you are trying to teach more, a simple so-called student model. So we can do this using, our computational framework. So we have a teacher model, like a model which consists of PDEs, which describe the process of tumor growing, shrinking, and so on. This model can generate data And on the base of this data, we can train a neural network, and we try to modify the results produced by this network using real data. What does it mean modify? For example, we can train using some data, because there's not too many data. Usually, we can train the last layer of this network. However, the problem is that when we have a neural network, when we train this neural network in the given interval, you see that there's a growth, cancer growth, drug administration, and remission and the recurrence. So every neural network learn on that part of data, so give a very bad prediction. So much better is using, instead of neural network, a simplified tumor model like this. So we have our complicated model. This model is generating data. On the base of this data, we made data simulation to very simple. For example, here is ODE student model. So when we have also the real data, we have to regularize in some sort this model. How to do that? Details I would like to dive in that. Okay. In our case, we made some experiments. You see above on the left part of that. The melanoma model, which is simulated by our code. After drug administration, we obtain the following snapshots. We see that melanoma is shrinking. Below, we see the plot. The black curve is our complicated 3D model. The red curve is very simple. 2 ODEs only, simple student model. So we see that approximation of the 3D model by the 0D model is quite good in this case. However, when we have a more complicated case, when we have a cancer in a closed box, so we can see the part of the cancer which is not well oxygenated. And on the other side, there is difficult to supply drugs in this part of tumor. So many cells survive after treatment and regrowth. So in this case, of course, our simple model will not work too good. The second approach for data simulation is models assembling and so-called supermodeling. How supermodeling looks like. So to produce a supermodel, we produce 3 submodels. These submodels represent the same model but for different parameterization. Then we can connect these models using springs. There are additional expressions in the model which interact. Okay, so supermodeling. Hello.
Excuse me. You are, let's say, reaching this 10 minutes time slot. So please
I
come
see
to
that I have
conclusion.
1 minute, so I would like to explain on the supermodeling. Okay, it's 10:14. I have 1 minute. So instead of using this data simulation, we can do something different. We can have 3 simple models. These simple models can be connected via springs. Then the decision is just making on the base of data simulation of only 3 parameters instead of 30. So let me finish it. And this is the last slide of my conclusion. Thank you. Thank you very much. And I'm waiting for questions on the webpage. Thank you.
Well, many thanks for this overview of
Just now
your
it's 10:50.
many thanks for this overview of your approach to modeling, and we hope that you will stay with us to this discussion part at the quarter which will start at 10:45. Now, thank you very much. And now we have the next speaker of this session. It's Kenneth Wertheim from University of Sheffield, and Kenneth will give, let's say, overview of another other approach to modeling of tumors and all these terrible diseases. Kenneth, floor is yours.
Can you see my slides?
Not yet.
No?
Oh, yes. Yes, it's okay.
You can see it.
Thank you.
Okay, so should I start? Should I start? Hello?
Yes, you can start.
Yeah, so good morning. My name is Kenneth, and today I'll talk about my neuroblastoma research. I would like to thank my colleagues in Sheffield, my collaborators from Primage, and the European Commission for funding this project. I also want to thank the Polish organizers for letting me give this talk in English. I'm British. English is my strongest language. And the fact that English is the dominant language of science is the result of a historical injustice. It shouldn't be taken for granted, and it should be acknowledged. So let's begin. So first, something about the Primage project. So I'm working with 16 partners from 8 European countries to build a decision support system for the clinical management of malignant solid tumors. And to this course, I contributed the first multicellular model of neuroblastoma. And this talk is actually not about Primage. I want to talk about what I did with the model outside the project. Neuroblastoma is not in the brain. The primary tumor is in the adrenomaxilla, and it is the most common extracranial solid tumor in children. It's responsible for 15% of cancer-related mortality in this population. Where does it come from? Neuroblastoma arises from the neural crest, a transient structure in the embryo. It comprises stem cells and progenitor cells, which go on to differentiate into different cell types, including the neurons making up the sympathetic nervous system. And when myosin, a gene, is amplified, or the other gene, ALK, is activated, the progenitor cells will go on to become cancer cells. Neuroblastoma is famous for being heterogeneous. The low-risk cases regress spontaneously without intervention, but the high-risk cases relapse despite multimodal therapy. And when the myosin gene is amplified, it's usually a malignant aggressive tumor, high risk. This is important. Bear this in mind. So now let's move on to the model. I built a multicellular model with 3 components. First, there's a continuous automaton which voxelates the microenvironment. It represents the spatial distributions of cells and matrix and the concentration dynamics of nutrients. a bit like the concentration fields the previous speaker talked about. Populating the automaton are discrete agents representing two cell populations, neuroblasts and Schwann cells. At the highest level, they can do two things. They grow by cycling and they die. But under the hood, it's much more complex. Those two high-level functions depend on agent attributes, such as the mutations, whether the DNA is impaired, and the gene expression levels. And there are 20 gene products in each neuroblastogen, and they are linked together in an elaborate regulatory network. And the two cell populations can influence each other. For example, Schwann cells induce apoptosis in neuroblasts, while neuroblastic cells promote cell cycling in Schwann cells. Obviously, cells are physical objects. They occupy space, and when they overlap, they cannot grow. And I have a center-based mechanical model to resolve contact inhibition. I put the three parts together in a stochastic simulation algorithm. Think of it as a Monte Carlo Markov chain, and specifically that simply is a buzzword for carrying out a series of Bernoulli trials. For example, is the MAPK RAS pathway active? And if so, does the cell cycle? A model is pointless without calibration. After finding literature values for most parameters, I was still left with 20 fitting parameters. So I aggregated experimental and clinical data from the literature. I used a technique called latent hypercube sampling to sample the parametric space. For each sample, I ran simulations, calculated the differences between my simulation results and the literature data. And then I picked out of 3,000 parametric combinations, the combination that gave me the closest results to the literature. The simulations were very expensive. I was looking at millions of agents evolving over months, and they're stochastic. So we had to use GPUs to do it. And we were aided by a software called Flame GPU. So armed with this calibrated model, I looked at clonal competition. Within a neuroblastoma, there can be up to 4 clones, each defined by a mutation: myosin amplification, TERK rearrangement, ATRX inactivation, or none of the 3. Within each clone, each population, there are subclones defined by other mutations. In total, there are 24 subclones. And each population is characterized by different rates of cell cycling and cell death. And the tumor at the macroscopic level is defined by the split between Schwann cells and neuroblasts, as well as the level of oxygen and other nutrients. So I created 1,200 virtual tumors with arbitrary clonal compositions and macroscopic features. I ran some simulations, and I looked at the data. I don't want to dwell on the detail. The take-home message is that in the 1,200 tumors, the myosin amplified clone shrank in all the cases. But this is nonsense. The myosin amplified clone should have performed better because that's the dangerous mutation. So I looked at the detail of the 24 subclones. It turned out the expanding subclones had their p53 intact. And that is the answer. For the myosin amplified clone to expand, it requires other species to cooperate. So I carried out a sensitivity analysis considering 1,000 combinations of gene expression levels, varying the levels of myosin, MAPK, P53, and so on. And out of the 1,000 cases, I found around 300 expanding cases for the myosin clone. And I looked at the distributions of the gene expression levels. And I learned that don't worry about the detail. The message is that for the myosin amplified clone to expand, P73 must be active. Yes.
I'm sorry, you are, let's say, reaching 10 minutes time slot. Please come to conclusion.
Okay, let's go on. Yeah, I was there. And so I finished with the in silico and drug trial. I tested 1,000 drug combination against the myosin amplified clone. And I learned that inhibiting CHK1, P53, and P73 will shrink the myosin amplified clone. And this is consistent with the previous sensitivity analysis. So maybe I can talk about it in detail later. So here are my conclusions. Thank you.
Thank you very much. And please stay with us for the discussion at the end of this part of the session. Now, I would like to invite Marcin Krzykowski, who is from Real Research. And Marcin, please go on. At the end of your talk, a minute before end, you will hear a kind of a gong. So
yes, I've heard that before. Can you tell me if you see the presentation and you can hear me?
We can hear you and we can see your slide.
Okay, perfect. So I start my stopper. Yes. Hi, thank you very much for the invitation. I'm very happy to be here, and I will try to give other perspective on tumor modeling, because what we're doing is more wet lab tumor modeling, and what I heard so far was like computer simulations. Like we all know how huge the problem is with cancer, and I see that everybody seems to be very involved in solving the problem, and we do it in the wet lab, in really growing the cells. But the real problem all of us are facing is that a cost per newly developed drug is multiplied by 2.5 every 10 years. So I'm sure you heard that the costs are just like a few $1 billion. When I was studying, it was like, when I was doing my master, it was like $1 billion, and that seemed to be so huge. Now it's 2.5 billion. And it looks like it's going to grow to 6 billion by 2030, and that's a huge problem. Basically, our company is trying to approach this problem. This part of this problem is that in the very early stages of clinical development, let me just jump to the computer just broke. So in the very early stages of drug development process, companies or research groups are eliminating most of the potential drugs based on very simple cell culture models. And we deeply believe that's one of the main problems, because then you're left with very, very few compounds that they seem to work in two-dimensional cell culture models, but they will not work in vivo. And I will try to convince you that that's the case. So just to make this background for everybody, just to make it equal, we as human beings, we animals, we are made basically of two things. One is cells. So you have the same cells, the same genetic background of cells in your liver, in your skin, in your eye, but they all have different gene expression profiles. That's why they are different cells. And those cells live on something called ECM, so extracellular matrix. It's a kind of a scaffold that allows for those cells to basically live and grow in three-dimensional cell cultures that we are ourselves. And what our company is doing is we are basically recreating the scaffold, and we can source the cells and we can seed them and grow as at home, let's put it this way. So the question is very simple. Why should we grow cells in three-dimensional cell culture, and why the system that people are using right now is actually very, very broken? And it has been shown quite a few times already, but I will start with one simple explanation, and then I will go to some more details. So what you can see here in those 4 columns, this is, just bear with me. If you have any concentration, please stay with me for the next 1 minute and you will get it all. You can see the full gene expression profiles here. And what is extremely, extremely important, understanding gene expression profile is basically that whatever these cells express, whichever genes are turned on, that's how the cells will behave. And on the right-hand side, you can see 2-dimensional cell cultures. This means that cells grow on flat plastic, very stiff, totally not natural. We are not made of plastics ourselves. And you can see that out of 30,000 genes, so this column is a gene expression profile, out of 30,000 genes, these green ones are active. So let's say 20%. And about 80% of these genes are not active. And this is actually for one type of lung cancer. And if you then look in vivo, so the same cancer, the same tumor grown in mice, there is a very small cluster of genes that is not expressed. Let's be like 5-7% maybe, and the rest, like 90%, is expressed. So this model, translation of research from 2-dimensional to in vivo, has to be very low because these genes are different, very, very different. And then if you grow cells in 3-dimensional cell cultures, as you can see, 2 simple types of 3D on the left-hand side, they are not exactly the same as in vivo, but they are much closer, especially if you compare to the 2-dimensional cell culture. So this whole cluster here is expressed. This is the same, and this is much closer to what you can see in vivo. And you don't have to be a biologist to understand it. If you just look at the cells, 2-dimensional cell culture looks like a flat, like scrambled eggs. If you take the same cells and grow them in 3D, you can actually observe small tumors growing. So now going to more complex and real life data. Here you can see published data of gene expression profile of glioblastoma. And this needs a little bit more explanation. Here you can see on the 3 columns on the right-hand side are 2-dimensional cell cultures, and 3 columns on the left-hand side are 3-dimensional cell cultures. And what is very important, so they started with very young, 4 days old cell culture, and then 7 days old and 14 days old. And the same goes for 3D. So it's 4, 7, and 14 days. Keep in mind that any patient that comes to a doctor with a cancer has a cancer for at least a few months, sometimes many years. So the age of cancer is actually extremely, extremely important. So what is very important, and keep referring to what you have heard so far. If you take this very young 2-dimensional cell culture in 4 days, this is the one that everybody uses for drug screening. And you let it grow for a few days, the gene expression profile is changing slightly. Even day 14 in 2-dimensional cell culture, yes, it is changing, but it's not drastically changing. What is important is that if you see exactly the same cells, the 4D cell cultures, 2D cell cultures at day 4, if you see that in 3D, you already in 4 days going to see some changes in the gene expression profiles. A few days later, they're going to be more significant, but still not groundbreaking. But about day 14, you can see a huge and massive shift. So like 80%, again, maybe 80, maybe 60 in this case, % of the genes are heavily down-regulated. So they are all turned off. And then there is this cluster here of genes that is being turned on. And by the way, the data you can see here are not consistent with the first slide because these are different tumors and different cancers. What is consistent is that there is this massive change if you grow cells in 2D versus in 3D and young versus old. What is important here is that these data actually translate to response to drugs. So a 2D cell culture is this green one here. You can see IC50 of about 0.1 micromole. Then a young 4 days old 3D cell culture would have like 1 micromole. But if you grow those days to, actually we did it in 12 days, but you can grow 14, it's going to be very similar. The IC50, so how much drug you have to add to kill this cancer, is actually going to grow 100 times or 1,000 times, which is extremely, extremely important if you look at response to drugs. And this massive change occurs on the genetic level, then it occurs on protein level, like you can see on this picture. And these proteins can be clusters, like metabolic pathways, have different DNA replications, different, everything is basically very, very different. It is even changing the whole lipidome of those cells, which is basically massive change. What we do, by the way, I started a minute later, so please add me that 1 minute. Once you add the proper 3D cell culture systems at the very early stages of drug development, so in hit to lead or lead optimization, companies can not only save a lot of money in preclinical development, but they actually select the right drugs that can increase the chances of finding the right drug at the end. So we estimate that we can reduce the number of animals like 100 times, save 35% of preclinical drug development costs, and increase the chances of finding the right drug like 10 times. And the last slide is that, like, we are preaching this to the audience for quite a while, and we see that there is huge adoption of 3D cell culture, and this is really exponential. So that you can see a number of publications with 3D cell cultures for the last basically 20, 30 years. Thank you very much for your attention, and I'm very happy to answering questions.
Martin, many thanks for this concise and let's say presentation about the approach to the analysis of cancer, and thank you very much. Stay with us for discussion, and now we have our speaker is Leszek Grzanka from Institute of Computer Science, AGH University of Science and Technology. Leszek, floor is yours.
Thank you, Marian, for invitation. I'm just starting to share the screen. Can you see my screen now?
Yes, go on, please.
Okay, great.
No hej, ale co się dzieje? Przecież ja ci dałem dostęp.
Yeah, sorry?
No, it's okay.
Okay. Now I will go into a bit more different topic, because all the previous speakers were mostly concerned about the imaging or modeling of the cancer growth. I will go towards radiotherapy, which is a method, one of the various methods in fighting the cancer. And then I'm especially into so-called particle therapy, which is a bit different modality than the X-rays. So in most cases, when we apply radiotherapy, we use X-rays to deliver some radiation dose to the tumor, sparing as much of surrounding tissue as possible. In practical terms, this is being done by irradiating patient or the tumor from various direction to maximize the dose in the tumor and to kind of spare as much as possible around the tumor. In case of the particle therapy, instead of X-rays, we use beams of particles, for example, protons, which have very different features in terms of delivering dose. The dose delivered by the protons is increasing as penetrating the depth and stop at some point. In this way, we can irradiate the tumor with less fields, and the dose behind the tumor is almost negligible. Just to give you the example, when we irradiate the tumor located close to the brain, for example, in the distal part of the eye, using protons, we can save the brain. It is kind of virtually impossible to use X-rays in such way that you could penetrate the eye, because from whatever direction you take, there will always some dose delivered to the eye. This type of therapy is available in Poland, and then I was fortunate to observe its transition from the research to the routine treatment. Right now, we have a cyclotron center in Kraków, located in the Institute of Nuclear Physics, where the patients are being treated with proton beams starting from the 2011, where we had patients with eye tumors, and now we have patients with almost virtually all locations in the body, most frequently hard locations or difficult locations like the base of the skull. What are the difficulties in proton therapy is that in order to get the beams of the protons, you need to have a cyclotron, which is a very large device. It is contrary to what you see in conventional X-rays, where you have the treatment machine and the patient located in the same room. For example, in Gliwice, in the Oncology Institute, you have, let's say, more than 10 such devices. In our case, we have full building dedicated to the cyclotron and several robotic gantries which rotate around the patient. So the technology is kind of bulky, but still we are able to treat the tumors with sub-millimeter precision and promising results. So this was the transition from the research to the treatment, and now let's go the other way around, as we are now in the routine operation, but still we can make some advances. One of the fields which gives us promising results are the advances, as I say, by the physics and radiotherapy. By better understanding of what happens at the cellular level, by better exploiting of the physics, we can still improve the treatment outcome. I will give you one of the examples, which is so-called proton spatially fractionated radiotherapy. This is still in the phase of the research. We are not using that in the routine treatment, but it is making a progress. The idea is that you can put a collimator or a slab of material with very tiny holes, pass the beam via this collimator, and in this way, the beam will get a very particular pattern, and it's like the brush. And these brushes are very small, order of millimeters, and the radiobiological experiments give us the results that the tissues located close to the skin at few centimeter depth, they are not suffering to the dose damage as when compared to the conventional proton or X-ray radiotherapy. And now we have ongoing research in optimizing the properties of such collimation and testing effectiveness of this approach on various stages, starting from in vivo, in vitro, and on the modeling level. We are also making some experimental work in Kraków and then modeling of the physics behind. And then another direction is the computing. In proton therapy, we use some factors or to compare it to the conventionally used X-ray therapy. One of these factors is so-called RBE, which is like the measure of the proton therapy effectiveness. In a very general terms, we can say that the same effect with proton therapy can be achieved with the dose, let's say 10% less than with X-rays. And this factor is critical because this is being used for the treatment. In a clinical settings, we use constant factor of 10%, but the experimental results from in vitro and in vivo, and also some of the data with patients suggest that this factor may be different in this way that the protons may be more effective at very low energies. And then there is a long debate right now in the treatment community whether this should be included in the treatment or not, and if yes, then how this should be included, because in some cases we could decrease the treatment dose, or if we don't include that factor, we can have some necrosis or some bad side effects in the part close to the end of the range of the beam. I was part of many activities in that area. As one of the highlights, I would like to present one of the results where we've been studying the different quantities that characterize the beam and trying to check which one correlates the best with this effectiveness, with this RBE. As I mentioned at the beginning, the effectiveness is larger when the energy is low, but usually in the research discussion, one of the parameters, so-called LET, it's the linear energy transfer, is being used as the correlation way. And then we are trying to suggest that maybe some other parameters might be better. Yeah, I'm just 6 minutes into my talk. Why there is a gong? And then for that purpose, to evaluate which parameters are the best, we are using computer simulations. In our case, this is the particle interaction with matter codes, which track interaction of every single particle with matter, with human body. This is a very time-consuming task. And It offers a lot of insight into what happens with radiotherapy. We get from that codes the precise dose distributions, but not only that, this is the basics for the treatment therapy, but also the beam quality parameters, which then later can be correlated with what happens with the effectiveness of the therapy. And it can be also used to study the interaction of radiation with matter at, for example, cellular level to understand what happens with the DNA damage and so on. Not only that, but also this type of codes can be used for predicting the electronic radiation damage or cancer risk in the space mission. We are also applying that codes in this area. The whole idea of the LifeScience Open Forum was about the collaboration, so I wanted to present one of the tools which we are creating together with Cyfronet Computing Center. Is the platform which enables researchers to run such simulation and then to interact with these codes using web browsers. I think it's an important step to put a bridge between the medical physics and the modeling researchers. I've just realized that many people in this area of radiotherapy, they are not fluent in programming, and then providing a bridge by web interface connected to the supercomputer may improve the results. And finally, the collaboration offer. I was asked by the organizers to say something about that. Here I have 3 points. One's the scientific collaboration in this very interdisciplinary area, medical physics, computing, and mathematical modeling. The second point is development of the tools. In our case, like basically all the tools are being developed as the open source project hosted on the GitHub. And this area is open for contribution and for the feedback from the users from many domains. So feel free to code with us, feel free to use these tools. And finally, we have Beamline and we have patients, we have Accelerator. Therefore, we are open for any experiments in that area: particle therapy, dosimetry, detector development, irradiation of 3D cell cultures, and any others. Thank you very much. I hope I was in time.
Well, many thanks for your presentation, and special thanks for these 3 points for collaboration, because one of the main purposes of this session was just to start the collaboration. And in this part of a session which is devoted to discussion, it would be great if all participants of the session would, let's say, try to formulate what could be the common, where you see the possibility of collaboration. In this session, we have put 4 talks which were somehow concentrated on modeling, and maybe you can find something common, and you can find some, let's say, some points which where your approach to modeling can be somehow enhanced with ideas of which were presented in this session. So could you please try to answer this question? What could be the area of collaboration?
So I will just since you didn't point anybody, I will just allow myself to do that. I was actually doing back when I was doing my PhD, I was also working on one project where we were doing quite a lot of modeling, and the idea was basically that we had the full 3D structures of tumors, and we wanted actually to find an algorithm to model them and to see how the drugs is being distributed in the tumor. And one of the reasons why I'm not doing that was that I realized that these models, although they may look very nice, they have so you can put many parameters, but then computationally it's going to be impossible to do that. But then you have to put very few parameters, which they give you, like I would say, nice pictures that look like tumors, but then you lose a lot of the complexity. That's why I think in terms of any collaboration, I would be very interested in like being able to work with a computational model that would be constantly faced with reality. So we can actually make quite a big 3D structures and grow them in 3D in quite repeatable way. And if there would, I don't know about any algorithms that could actually learn from what we do, but I know there are a few techniques that allow us to actually to visualize quite well the whole 3D structures. And if you would have a learning algorithm that would basically learn how they really grow, that would be very interesting. Like from our, because then we are based on reality, not just on an idea.
Well, I think that the final step to this reality will be, let's say, some advices about radiotherapy, which was presented by Leszek. But I think that about these parameters, I think that what Witold presented at the very beginning, it was a kind of attempt to deal with many parameters. So maybe Witold, if you could.
The method that I presented came from the SUMO project, this OpenFed project, which was started by people from Bergen, and they try to use supermodeling and climate modeling. So climate models are very, very, very big. The number of parameters is huge. So they come to the conclusion that the best models are models which consist of many sub-models, yeah? For example, the model of atmosphere, the model of land, the model of ocean, and so on, yeah? So having so many models, there's a idea to make a weight ensemble model. So supermodeling is such a weighted ensemble model. So what are the results? So they observe that when they use the supermodeling approach, not just assimilating all the parameters, a huge number of parameters of every atmospheric model, and they match only the coupling coefficients between the models, so they obtain much better results than every model produce on itself. So I think that supermodeling plus knowledge distillation, there's a right way to obtain the meta platform for data assimilation. Thank you. I would like to not steal your time. Okay.
Thank you very much. We have Kenneth. Kenneth, you have your approach is modeling from, let's say, I think that what is going on in a cell. Kenneth, what do you think about, let's say, putting your results together with what was presented, for example, by Witold and Marcin?
Hello. Yeah, so I'm back. So you want to integrate what I built with what Vector built. Am I correct?
Yes. Well, the question is to which extent you think that you can profit somehow from approaches to modeling which were presented in this session.
Yes, so I guess one thing that can help is surrogate modeling. And actually, I've tried that internally too. So my multi-scale models, they're quite expensive to solve. And it will be useful if I can map the input to the key outputs and use that as a basis to eliminate regions of the parametric space.
Mm-hmm. Well, and probably I would like to to ask Leszek, what do you think about usage of models which were presented in this session for this experimental, let's say, approach for this radiotherapy?
I would say that I don't see a lot of intersection here because, let's say, modeling of the tumor growth and radiotherapy doesn't happen on the same time scale, let's say. So this is the first reason. We are more concerned about the movement of the organs inside the patient body rather than the growth of the tumor. What I find more interesting are the 3D cell cultures. Why? Because there is a lot of interest from the radiotherapy community in studying what happens with cells, living organisms, when you kind of expose them to different radiation types. Also in Kraków, we had experiments in gene expression for X-rays and for protons done on 2D cell layers. I think it would be great if you could manufacture, okay, I'm dreaming, few by few centimeters 3D cell culture, then we put it in the proton beam, X-rays, and then we check, I don't know, clonogenic cell survival or gene progression. Yeah. Am I dreaming or is it feasible? You said big. How big?
So big.
Well, you know, I think that it was just I hope that it was just the first step. This discussion was the first step to a possible collaboration. So I hope that you will stay in contact somehow, and maybe the platform will be somehow useful. Nowadays, it is very easy to organize a meeting. So, well, maybe you will continue after this session. Unfortunately, we need to stop the discussion, this short discussion here. Thank you very much for taking part in this session. And now we will move to the next speaker of first part of our HealthMed session. So I would like to invite Alessandro Crimi from Sano. Alex, floor is yours, and 10 minutes are yours.
Can you hear me?
Yes, we can hear you, we can see you. And
I share my screen, so I hope you can see it.
We can see you.
And
yes, now it's much better. Yes, thank you. Go on.
So okay, thank you. Good morning. I'm one of the group leaders of Sano. In particular, we work on neuroimaging, and we are like kind of mostly focused on brain connectivity from magnetic resonance, but also on other modalities related to from microscopy to other kind of wearables. And actually, brain tumor, and specifically glioma, glioblastoma, is of relevance for our lab. So because we mostly work on Alzheimer and glioblastoma, and I'm not going to give one specific describe one specific work, but more an overview and also discussing how we can collaborate or what we're looking for. So before joining Sano, actually not specifically related to the group, I make some advertisements so that within MICAID, so the Medical Imaging and Computing Assisted Society, we have that is the largest conference for medical imaging. We have two events. One that is related more in general about brain lesions, so there's glioma, stroke, traumatic brain injuries, and also we have used to have a challenge for segmenting different parts of the brain tumors from magnetic resonance imaging, and it's called the BRATS challenge that we also published like in a book and in some other stuff. But now going back to what all these people that I put together like in just 1 year. So as I was telling you, some of them are working on magnetic resonance imaging related to glioma, glioblastoma, and so on, more on the histopathological side. And like I was mentioned just briefly, because also some of them are just still under review work. We are doing something related to the prediction how the brain tumor will look like after surgery. Or another thing we noticed that is happening in that is been neglected so far in many studies within the edema, and then more other works more in the histological point of view. So generally, I oversimplified the procedure for resection of the brain tumor. I was telling you we work on glioma or glioblastoma, which is the most common brain tumor, and has a very poor prognosis. So generally, people die within 14 or 30 months, or there are some genetic variation. People survive after 10 years, and the most when you reach the point of glioblastoma, the only thing you have to do is surgery. So chemotherapy or immunotherapy are still not so effective, or at least you have to combine them with surgery. So what people do, like normally the doctors do, they do some MRI and then maybe some more advanced MRI. This thing is not moving, was supposed to be moving. So this one that you see in the corner on the top right is like a result of a tractography from like a diffusion tensor imaging that we can also, since it's too complicated even for a doctor, sometimes we simplify this spaghetti representation with a network representation, because we have like some anatomical atlas that are let's say representing all the fibers going from one region to another region, instead of this spaghetti neuron to like just one edge of a graph. And this is helpful because then we can capitalize in all the things we know about graph theory. Usually what the doctor they know the medical history of the patient, they know where from some other MRI where the tumor is, and they like have to resect to try to avoid to make some damages. Unfortunately, this is not so effective sometimes, because very often it's touching like the language area. So even if the surgeon is of course well experienced, sometimes the patient experience problem. He cannot speak afterwards, substantially after the surgery. So what we did is something that we can, given some input of how the tumor looks like, and we train a model how the tumor was looking like after the surgery, and to give a further impression, a further possibility instruction to the surgeons how the tumors will look like after, so that they can have better idea how what they should resect or not, trying to avoid further damages. Of course, you are not gonna add more lives to the patient, but at least, you know, if he's surviving 30 months, at least he will be able to speak. So this was the goal. And I don't go into details of what this thing's doing, but substantially we did many things relate with some graph neural networks, so with some AI modeling tool, and also some regressions. Another thing that we noticed also was that very often when many studies people were simply, when they were seeing the edema, were completely ignoring it. So they make like a mask and they make the analysis outside. And we found this using some functional magnetic resonance. We noticed actually that there is a signal. So we kind of are challenging the entire community that this has been so far not so good idea. And this is still submitted through, all this stuff is still submitted, but we have a preprint if you want to see more. And of course, it's not more like something you can translate in. But I am at 5 minutes. I don't know why this. With more like fundamental ideas related. So the other group of works that we did was more into analyzing this histology data. So one that we had several slices in 2D, first in 2D from different grades of glioma, and we tried to see if we can classify this. And The reason was because already from glioblastoma, already some pathologists were telling us that were even difficult for them sometimes. Okay, not in this case, but some cases to discriminate grade 2 and grade 3. And actually, unfortunately, because the model was trained from humans, also our model was not working, but we have an idea afterwards. And another thing we were working with Monica Pitlas was to find like a uniforming the staining, because there is the problem that the stain done in one lab was not the same as the stain done in another lab, and this might create a lot of complication, even if you consider things like federated learning. So she's like working in something that will be able to make uniform, like transferring the style from one lab to the style of the other lab. And now on the problem that we think we might address with the story of discriminating second grade and third grade. Okay, if there are some pathologists here that they think they can distinguish better second grade and third grade, we will welcome you as a collaborator, but so far, all the pathologists we involved, they have a lot of problems with this. What we are thinking now is to move from 2D to 3D, in the sense that we, instead of using these normal 2D slices, we will use clearing data. So clearing system is what you see here on the top left. So we have, you take some samples or biopsies and you remove all the lipids or all the structure, and the tissues start being like transparent in a way that you can scan it with a microscope and still keep like a 3D structure without cutting in small slice. I cannot show you yet the videos for the brain tumor, but I have a video we did in a previous work for Alzheimer's. So what you see here is the slice of brain mouse with some amyloid plaques, and this is how it looks like with clearing. So you can see we can go through the entire tissue without cutting it in pieces. And why we are doing it is because we believe it's possible to have further information and discriminate grade 2 and grade 3. Also because the vessels is often not very visible when you do 2D slice. When you have an entire structure, it's more, we believe will be more possible to see more things. But this is still ongoing, so we only have it for Alzheimer, not for glioblastoma yet. And now, oh, sorry, it stopped. Summarizing, we have, okay. Summarizing, we have many things and related to MRI or with diffusion data and also histology. So I'm looking for if there is anyone that will be interested, any hospital or who wants to have, collaborate with us with some other similar projects, I will be open-minded, or even maybe, I don't know, doing a clearing of organoids will also be something interesting, so that we can start looking at the individual necrotic cells and how do they look in the vessels in a more deep analysis with medical imaging.
Well, many thanks. Please stay with us for discussion, okay? And now we have our speaker will be Dominik Czaplicki. Dominik is from Jagiellonian Center for Experimental Therapeutics. Dominik, please, floor is yours.
Hello, everybody.
Hello.
Can you hear me?
We can hear you, and we even can see your slide.
Great. Glad to hear that. Thanks a lot. Yes, I work at the Jagiellonian Center for Experimental Therapeutics, which is a unit of the Jagiellonian University focused exclusively on experimental pharmacology and preclinical studies. And today I would like to introduce a couple of pieces of our work that is focused on drug profiling and safety studies, specifically for the oncology Sorry for that. Oh, okay, yes. To start, to begin with, I need to tell a few things about endothelium, which is our major topic in our research interest. This is one of the largest tissue in the body. Apparently, it's for an average person, it's a football pitch-sized tissue that overlies entire cardiovascular and lymphatic system. So this is the tiny, thin layer of cells inside the vessels. And this is the largest interface for any drug that is administered systemically. While endothelium has so much is in such a close touch with the drugs, the importance of the endothelium for drug efficacy and drug safety is widely neglected. So far has been little interest in studying how the endothelial cells behave when affected by the drugs. On the other hand, several cases of adverse effects led to clinical failures of some notable drugs so far, and those could be attributed to endothelial cell dysfunction, while we could study this well before clinic to predict toxicity. Why prediction is important? Because risk is the major factor in drug development, as you may all know, and the cost of failure might be huge. One of the examples of such a costly failure is torcetrapib that has been withdrawn during clinical trials just because adverse effects related to endothelial dysfunction, as it was elucidated later. In oncology, this is even more important because most cancer drugs and most therapies affect the cardiovascular system, including the endothelium, and those toxicities limit the clinical use of the drugs and also reduce the quality of life and the survival of cancer patients. In some cases, the cardiovascular adverse effects are actually more deadly than the neoplastic disease itself. And while cancer patients live longer and the cancer treatments are more and more effective, those adverse effects on the cardiovascular system remain to be even more important clinical issue. Today, I would like to focus on one drug family called protein kinase inhibitors that are widely used in cancer treatment nowadays. And this area is the hotspot of pharma. There are many kinase inhibitors developed in development now, with already 50 plus approved for clinical use. And also new indications for those drugs emerge. So their effect on the endothelium is more and more important, also beyond oncology. In our studies recently, we focused on 3 generations of tyrosine kinase inhibitors. And those drugs are called imatinib, nilotinib, and ponatinib, all FDA approved, all used in the clinic, but they have a very different safety profile. And for some of them, the FDA issued warnings that limit their use and the prescription. And those warnings are related to the toxicity that is detected in the patients. And the question is, could we predict those liabilities well before clinic? In other words, are we able to see the toxic picture of a drug in patients well before the drug is administered to the first patient itself? To study this, we use a pretty sophisticated machine. When we perform those studies in collaboration with the Institute of Nuclear Physics that has been mentioned this morning already, for proton therapies, but we use a machine that is kind of next door in this facility, and this is an MRI scanner, not quite fit for a patient, but sufficient for our patients, which are mice. So we perform in vivo studies in living animals to see the cardiovascular system and study the effects of drugs on endothelium. This is just a sample of our results, where using our methodology, we could profile those 3 drugs I've mentioned in terms of the endothelial dysfunction induced by the drug. And we study here different doses of those drugs to check where the adverse effect on the endothelium that is measured by a physiological reaction of acetylcholine-induced vasodilation, where at which dose this effect occurs. And the smaller the dose is, the more toxic the drug can be, to simplify this. So those three drugs, again, show a very diverse picture in adverse reactions in the patients. And we can summarize this as an overall cardiovascular risk, which is low for imatinib, medium for nilotinib, and high for ponatinib. And this is directly related to our preclinical endothelial profiling results, where for imatinib, the endothelial dysfunction is detected at high daily dose, for nilotinib at medium daily dose, and for ponatinib at a low dose that is related to the high toxicity of this drug, related to the other 2. What are the use cases for this approach? We can study and assess risk for new compounds in oncology and beyond. We could also understand the mechanism of toxicity on the cardiovascular system, the vascular wall, and the endothelial cells themselves. This can be used for lead selection and nomination of clinical candidates. We can also use those results to manage clinical development risk and to monitor patients, for example, in clinical trials. This can be a part of out-licensing data package for drug discovery companies to improve the data quality, and also for in-licensing partners. We could use this as part of the due diligence of novel drug candidates. We could also detect positive effects of drugs on the endothelium, not only negative, and this can be used to detect vasoprotective profile and also understand the mechanisms beyond and explore into new therapeutic areas. This is important for drug repurposing, repositioning, revisiting of all drugs that may have new indications. Thank you for your attention, and those are the 2 key people to contact if you would like to join our projects and perhaps study your own drug candidates on your own treatments. Thank you.
Many thanks, Dominic, for your talk, and stay with us for discussion. And thank you very much. And now we have Piotr Nowakowski from Academic Computer Center, Cyfronet AGH, University of Science and Technology.
Greetings. I hope you can hear me well. Let me just quickly share my...
We cannot see you. We can hear you. We can see you. And what about your slides?
Perfect. Let me quickly take care of the final item on the agenda, that is sharing my slides. Hold on. There we go. Hopefully you can also see my slide deck right now. So greetings everyone. My name is indeed Piotr Nowakowski. Some of you may know me from the SANO Center for Excellence, but here today I'm on behalf of the Academic Computing Center CypherNet, of which I am also an employee and a member of the Distributed Computing Environments team that is led by Marian. I'm here to tell you a little bit about what CypherNet brings to the table in terms of supporting scientific research and the computational infrastructures that are used to perform this research. Now, I suppose many of our participants will already be familiar with the goings-on at CypherNet, but for those who aren't, we have been in the business of provisioning computational resources for Polish and indeed international scientific endeavors for over 40 years. And we currently operate as a supercomputing center here, located here in Kraków. We operate a number of HPC infrastructures, of HPC units. One of which you can see here in the photo, that is the Prometheus, which at launch was I believe in the top 100 on the top 500 list. Now, a couple of years have passed since then, so we have also upgraded to new infrastructures and deployed new computational units, including Ares and also Athena, which is a GPU cluster. And generally, this creates a considerably potent set of computational resources, which obviously need to be operated and deployed, but we also need a good way of applying those resources for the benefit of science. And this is where actually my team comes into play, the Distributed Computing Environments team. We are a team of IT specialists and researchers at CypherNet who have for, well, over 20 years now, been involved in developing and deploying customized computational solutions for various types of scientific projects, with particular focus on projects that deal with various types of medical applications. And you can see here just a very brief list of some of the projects that we have been involved in through the years. We started with grid computing, which was sort of in vogue back in the early 2000s. And then we've progressed to more modern computational infrastructures, and which are obviously currently HPC and cloud platforms. So our task is to enable the domain researchers, the scientists who actually carry on some of the research projects that you have been hearing about in my other colleagues' presentations here today, and enable them to take advantage of the computing resources that are provided by CypherNet and also by other participating institutions, other HPC centers. Now, this culminated in a couple of years ago in the formation of the SANO Center for Excellence, which is like a brainchild of some of the people at CypherNet, and which has by now been spun off into an entirely independent entity that concerns itself with carrying out this cutting-edge science with the use of the computational resources which we provide. Now, recently, our sort of recent area of interest has been to provision HPC resources, particularly the resources that are available on our computing clusters, to various types of research undertakings, of which Primash, which has already been discussed here today. I'm not going to sort of go again into the details of what the project deals with, but suffice it to say that some of the research work that is carried out in the context of Primash and also other research projects does require a large-scale computational resources. So we develop environments which are able to organize and provide those resources, provision those resources in a coherent manner, also in a secure manner, to the scientists who carry out this domain research. And in doing so, we take advantage of the mechanisms provided by the Polish computational federation called PL-Grid, which is a sort of a federation of computational resources provisioned by various Polish institutions, of which CypherNet is one. But also, it also implements a coherent security, a sort of authentication and authorization system. and it provides a large array of computational software packages, including proprietary software, which normally would cost a significant amount of resources to procure for the purposes of research. So all this is provided free of charge to our participating scientists, under the condition, of course, that any publications which result from that have the appropriate acknowledgements, which is, I think, a good deal for all concerned in this context. So our platform, the Model Execution Environment, can deploy computational models on the HPC infrastructure, including the resources provided by CipherNet, in an organized manner. Now here we have this abstraction where we have several levels that are sort of quickly visualized here on this slide. We are able to process a large-scale parameter sweeps and generally case studies which rely on performing computations for upon a set of representative cases, patient cases in most situations. And this fits in, like I've already said, with the goals of the Primash project, but also with a large number of other research initiatives where we have a patient cohort that we want to analyze in some particular context to discover regularities, patterns, and work towards building decision support systems for medical practitioners on the basis of the outcomes of this processing and these algorithms that use or exploit our HPC resources. Specifically in Primash, we are able to run this multi-scale model that has already been discussed. And in the morning session, you saw this sort of a pipeline of actions that are involved in processing data and performing the simulations. And we take care of deploying the computationally intensive part of this pipeline upon our resources and organizing computations with the use of our model execution environment to exploit the potential offered by our HPC infrastructures. So essentially, since the primary purpose of this session is to highlight the opportunities for collaboration and synergies, I would like to briefly summarize what we bring to the table. So we, like I said, we have a fairly significant amount of HPC resources, also data storage and networking facilities and such, which we are capable of provisioning, with free of charge, in the sense that no payment is necessary and if scientific research is being conducted. And moreover, we also provide a large array of proprietary software packages, scientific packages, for which we have procured licenses and which can be used in the course of research projects, just as long as you acknowledge us in your publications. And furthermore, we also have specialists on site who can work on deploying your computational models, the stuff that you as a domain researcher may be working on the HPC resources. So we provide consultancy, we sort of offer suggestions of how to adapt computational models to take advantage of the HPC resources, and we also actually get our hands dirty, so to speak, in the sense that we work on deploying those models and process them with the use of our computational infrastructure. And it probably goes without saying, but we also have a large community built around our center, and we have a lot of contacts with institutions, both domestic and foreign. We are involved in a number of international research consortia, which offers visibility for your research and potentially additional collaboration opportunities as a sort of a trickle-down effect. Just a few publications, to go along with our slides. You can learn a little bit more about what we do and how we do it. But that is essentially, I would say, the gist of it. So thank you very much.
Especially thanks for this slide about collaboration opportunities. And stay with us for discussion. And now I would like to invite Mariusz Monsior from Consonance. Well, now we will go towards, in this talk, towards medical devices.
Yes,
hello,
everybody.
We can see you, we can hear you.
Great.
Welcome. And now probably we need to see your slides. Oh, yes.
I think you should sit.
Okay,
So thank you for invitation. I will show you my presentation and presentation of our company. I'm CEO at Consonance. So this whole presentation is mostly about cooperation. So I want to introduce you Consonance and what we do, how we work. Basically, Consonance is an engineering team that helps with every project in the medical area. I believe it might be interesting for you because a lot of other presentation in this panel shows specific techniques, technologies, and medical techniques, technologies that can be used for bringing new therapies, new diagnostics into the market. In one moment or the other of the development process, you need to basically integrate everything into a medical device that then needs to go through a regulatory process and bring it to the market. So here is where we can help. Consonance is a team of experts in the area of medical devices, engineering, hardware, software, mechanical constructions, regulatory specialists, R&D engineers, as well as project and product management in this area. We are helping teams to build and to design their medical devices and systems. And we do this for various types of clients, from small scientific university groups, through startups from Poland, from Europe, to even big corporations who want to design and launch their innovative medical device and has some positive impact on the health system or general health. To explain a little bit more about what and how we do, I will show you a short story of one of the projects. I chose the project that is now on quite advanced stage. We help also, at least in 2 projects on the oncology area. They are still on some early stage. So I think this one will show you more what we do and how we can help, while this easily can be translated into any other diagnostic or therapeutical area. So basically in this process, we were working for one of the biggest Polish pharmaceutical companies that wanted to bring into the market their own device. So we helped them from a very early stage of the process where we analyze market business in the area of pain relief devices. We help them with initial choice of technology and concept of work. Then we were able to start the engineering, prototyping, testing, software development. So something that is the most important, especially for me, as I'm an engineer and scientist. Everything we do is according to the specific compliance for the medical area regulations. After we had the technology proof of concepts, some MVP that already worked, could be tested on people, we went into the final stages of project where we were able to help with design of the device, design of the whole manufacturing process, all the accessories of the device, manuals, and so on. So it can be placed as a real medical device and sold in pharmacies or in the market in Europe. So after almost 3 years of development in this particular project, you can buy the device. It's available in the internet from the web pages of our client, the USP Zdrowie. It's quite affordable. It's mostly designed for the elderly people to help with their chronic back pains. And this is basically one of the types of projects we do. We work for also small clients, small groups, where we help to establish some competences in the areas where the startup cannot have them or don't want to hire people like working inside their own engineering team. So Consonance right now is around 20 people. And as you can see, this project shows quite a big range of the activities, a quite big range of competences you need to do this. So how such small team as ours can do such extensive and multi-stages development project? So the secret is in our process that we in detail talk with our clients and are showing. So right now, only a short glimpse into what and how we do on some nice looking schematic. So every project we do, and this is our basic rule, we start with extensive understanding of what the project, what the product, medical product will do, how we'll do, and start with very extensive work, which we right now do in 8 to 10 weeks collaborative process with our clients when we establish every needed element for starting development. So regulatory analysis, requirements analysis, preparing strategy for introduction to the market, preparing or analyzing technical audit if clients have their own prototypes or some elements of the technology. And we prepare technical solution concepts. So what technologies, what elements, what parts of the solution should be used for the final device. These elements leads to preparation of detailed strategy and plan for the project development with estimated costs and schedules for everything from this moment up to entering the market. Then we can start with R&D phases, either with our clients or we can do it on our own. So building first prototypes, proof of technologies, proof of concepts, then maturing projects with every consecutive stage until we have MVP and can work with bringing it to the market. So with design, with manufacturing preparation, with every element that needs to go further until the project is ready and we can help with certification process with notified body, and then manufacturing and help after the device is already on the market, you can buy it or physicians can use it. All of these elements we do with compliance with necessary standards and norms. While we are our company, Consonance, is certified ISO 13485 designer and manufacturer of medical devices. So this was a quite short presentation just to give you some introduction of what we do and how we do it. There is not much time right now, but I invite you, if you like to hear more of what we do and how we do these projects, into contact. So here and on the webpage of this conference, you have my and our contact details. So I invite you to connect with me and to talk more about your projects. I would be very glad if I can help you either with some advice or working with amazing technologies that already do. Thank you.
Thank you very much. Thank you very much for this presentation and invitation for collaboration. And I think that we'll have more time to talk about this in this discussion time slot at the end of this part of the session. And now we have the last speaker of this session. It should be Ahmed Abdin Hamed from SANO, Center for Computational Medicine. It seems that we have a kind of...
Hello, everyone. Can you hear me?
Oh, yes.
Hi, this is Sama.
It is not Ahmed.
No, I'm
like
presenting on behalf of Dr. Ahmed.
Well, okay. So please, we can hear you, we can see you, and now we are waiting for your slides.
Sure.
If you are a replacement of Ahmed, yes. Yes, please.
Okay, I'm trying to share my screen. Okay, are you able to see?
Yes, we can see your slides. Yes, go on, please.
Okay, so as I say, today I'm here to present a project on behalf of Dr. Ahmed. The project focusing on text mining, tutor text mining for cancer expression. Using network of figures. So as all we are aware, the social media platform has become an undeniable part of our lives. So there is no question about the significance of the information and experiences that people share on these platforms. Also, the availability of various platforms and fresh data based on people's experiences has indeed excited researchers and has given them the much needed tools to work with. The aim of this project is to investigate on each type of expression by using hashtags, sentimental and vocabulary regarding cancer disease and chemotherapy treatment. To do this project, researcher collected data by using the Twitter streaming API. They have collected 5.25 gigabyte of English tweets for 8 weeks in the period between September 15 and November 16 in 2019. Consequently, to do the pre-processing step, a list of filtering keywords was used. So these keywords include cancer, chemotherapy, coping, surviving, and survival. And as a result, they have found 59,567 tweets. And in fact, they selected those tweets. Besides that, tweets from Twitter, a Facebook list of 120 sentiments that are part of feeling sentiments such as happy, excited, lucky, happy, excited, lucky, sad, and depressed are collected as well. Method which was chosen for this project was text analysis and network analysis method. So in fact, there was two ways and two methods to do this project. To perform the text and linguistic preliminary analysis, a pipeline was designed for this project. This pipeline was designed to process individual tweets by performing these following tasks. Firstly, there was a word tokenization for each individual tweet that make up the data set for this project. And the next step in the pipeline, the nodes and issues were managed. And also it follows with identifying parts of the speech of the relevant words in the tweets. Then in the next phase, the non-phrase of tweet word length were identified, and finally, the data structure that keep track of the noun words that co-occur in the same noun phrase were produced. The preliminary step of text processing produced pairs of numbers. And in the next step, to conduct the centrality analysis, those pairs make up the set of vertex in the networks. So the degree centrality also offers a quantitative result that enables rank based on significance. The top ranks vote could lend the top ranks vote could lend themselves to an alert the cancer drug and was remedy or a food interaction accident.
Well, it seems that we have technical problems with this talk. But anyhow, I would propose maybe we will try to reconnect somehow. If it will not be successful, we will simply move to discussion about collaboration on the basis of talks presented in this session.
I think this is a better idea.
Sure.
This is a better idea to move to discussion.
Okay. So, well, in this session we had.
I'm sorry. Disconnected. I'm really sorry. Can I continue?
Oh,
can you hear me? Sorry for the technical issue. I'm really sorry.
Well, we had a problem with your voice, and so maybe.
No, can you hear me now?
We can hear you now. Yes.
So I'm sorry for what happened. It was a technical issue with my internet. Do you mind if I continue?
Well, if you could present the, let's say, conclusion slide, it would be great. Can you share your screen and present your last slides, just to conclude your talk? Well, I'm afraid that we have lost the connection with you. So, okay, so let's, I would like to invite all participants of this session to discussion about possible collaboration. Well, from the point of view of collaboration, we had here really different topics presented, and well, it would be interesting to ask you what is your opinion about possible collaboration. So, well, let's start with Alex, if it would be possible to. If you could share your opinion about collaboration with other participants of this session.
This session, I don't know. As I mentioned, I was more into take a look of these organoids from the previous group.
Yes, I think that what you have presented gives opportunity for collaboration with the first group, with the first part of this session, yes?
Or if there is anyone here that has some ideas, want to try something related to medical imaging, from histology to magnetic resonance imaging, I will be happy to discuss.
Mm-hmm.
Excuse me, it's probably not my field of expertise, but I think we may be able to dig much more data from our animal experiments. So perhaps revisiting those imaging, the results that we already have, may bring further value to the assays that we do and the predictions based on them. So I would be happy to.
Yeah, sure. I take a note.
Yeah, to get back to you, Alex, and perhaps other participants, and get you or our researchers on imaging linked to your group, because it may be mutually beneficial.
Yeah, sure.
For
your
this,
email was.
My email is. I will type it here. For the life science open space in general, our wish is to jset.eu. This is my email. So our wish is to be kind of exposed or become recognized in the biotech and pharma industry. So while we are interested in what we do research-wise, we would welcome any collaborators that could validate our approach in their drug development efforts. So this is probably slightly beyond the scope of this particular session, but this is our partnering goal, so to say. Thank you.
I can have a question to Alex, because in the previous part we did have one pretty nice example of connecting or merging the technologies like 3D growing cells and computational methods to simulate the same phenomena in order to find out or speed up the developments. Do you see other types of collaborations opportunities with what you are doing in imaging? Examples of operations you think you may benefit from, or someone may benefit from your studies?
You were talking to me, or and which studies are you?
That was to you.
Which one of the studies? I presented like 4 or 3.
All of them. I mean, we are looking for this because the thesis at the beginning, the very beginning, was that the further development of methods of innovations for the health and quality of life, especially in the cancer, will require connecting or merging the technologies. So imaging technology is one of the possibilities. And my question is, how do you see, where are you looking for other technologies to merge? What do you think it's valuable for you, or you think your methods, your studies may be may be of value for others?
But I mean, as I was saying, at the moment, most of the things we tried with glioblastoma never worked. So people are still doing a wild brain tumor resection. And now it seems the frontier is with immunotherapy. So if someone heavily working in immunotherapy and is interested to collaborate and merge with the medical imaging to see the impact at low level of immunotherapy, I don't know, LPD1 or other antibodies. So this might be something we will be actually already looking at this slightly with the group in Warsaw, Nensky, but I'm sure many other people are trying similar things. So it will be interesting to connect people working in antibody immunotherapy to what we can see and support from the medical imaging side. And this can be either histology or if someone has already MRI of immunotherapy will be also even more also interesting. Did I answer your?
I'm not sure that actually this is a question to the answer was broadcasted that if you did answer correctly, I would say that you will have some kind of inquiries about your studies. But my next question is, for example, the other example of possible using the imaging therapy is a real-time application, like in laparoscopy or something like that, something which will guide, for example, doctors during the
so no, then it's not the histopathology because that takes time. So the first things I presented, the prediction of how tumor will, the prediction how tumor will, how the brain will be after surgery, that might be something in real time. So the first thing I presented is prediction of after resection or prediction of neuroplasticity. This can be real time. I mean, real time given that you have an MRI, but that will be real time.
Okay.
It's something you can put. You can create a software tool and sell it if you. That was. We could make a product and give it in real time.
Well, thanks. Somebody is looking for, let's say, compute and storage resources, which just to use this offer which was presented by Piotr here. It seems that everybody is happy with computing stuff available at.
Marian, if I may say something,
Yes.
I'm glad for having access to the computing resources from Cifronet. This is great. I mean, it's great community. I kind of advertise it for everyone. I just have a question on the other hand, because my experience with people from medical community was that they were not so kind of proficient in doing the simulations or using the computing power themselves. I mean, I am doing a course on data analysis for a PhD school, and most of the participants, they analyze data in Excel. So a question to the community, like, how proficient are you with using computing power? Because maybe this is the case, how you should use it.
Well, no.
Because I suspect we have a broad variety of experts here. I mean, people really deep in modeling for past 50 years, and then let's say other part who is more into experiments, and there is a gap between it. I'm just curious if it is true or not.
Well, it is the area where you need a kind of bridge between these two group of people. So it's
it will be difficult to find the answer at this session because I think
Yes.
people will not voluntarily agree that they are doing the complex computing still on Excel, which is of course the case, and it is very useful. I understand that you promote the more advanced way of applying the computational power, computational methods to this computing.
Yes, but I think that with increasing number of data and also, well, a kind of understanding need of and usefulness of models, it's clear that it's necessary to have a kind of, let's say, different approach to computing power. And well, what is now coming back under the name of digital twin is also something which promote efficient usage of computing and storage resources. So it's I think that it will become more and more let's say popular in this field. I think that in this way we have reached the end of this session, which was scheduled until 12 o'clock. So now we have half an hour break, yes? And after this break, we will have a second part of a session. We'll start this with a keynote talk in the similar way, and it was in this session. So I would like to thank all participants of this first part of the session. And of course, you are also invited to the second part, and you are also invited to take part in discussion in the second part if you will decide to be there. So see you in half an hour. Thank you.
Thank you. Bye-bye.
In Krakow, a remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city center. Besides monuments entered on UNESCO Heritage List, Krakow has something else to offer. People. In Krakow every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Krakow. Krakow has become the center for modern services in Europe. Krakow is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Krakow is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Krakow, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Krakow is increasingly associated with excellent cuisine. Its restaurants, offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków.
SANO – Centrum Zindywidualizowanej Medycyny Obliczeniowej. Projekt realizowany jest przez AGH Cyfronet, Klaster LifeScience Kraków oraz partnerów zagranicznych Uniwersytet w Sheffield z Anglii oraz Fraunhofer Gesellschaft i Juli z Niemiec.
Główne wartości, jakie przyświecają SANO, to pasja, to innowacja, to wielokulturowość i zrównoważony rozwój. SANO w języku esperanto oznacza zdrowie.
W ostatnich latach jesteśmy świadkiem olbrzymiego rozwoju metod pozyskania danych o pacjencie, jego chorobie w ujęciu indywidualnym, jak i w ujęciu populacyjnym. Jeśli nie wykorzystamy takich metod, to bogactwo danych, jakie gromadzimy na temat pacjentów i ich chorób, zostanie zaprzepaszczone.
SANO jest instytucją badawczą, która prowadzi badania z zakresu medycyny obliczeniowej, gdzie próbujemy wdrażać rozwiązania bazujące właśnie na metodach obliczeniowych oraz sztucznej inteligencji, które będą mogły znaleźć zastosowanie w praktyce.
Staramy się tworzyć coś takiego jak awatar pacjenta, na podstawie którego możemy właśnie symulować różne procesy i podejmować decyzje bez konieczności ingerencji w tego żywego bliźniaka.
Takie działania mogą skutkować tym, że lekarze będą mieć troszeczkę więcej czasu, w związku z czym będą w stanie zaopiekować się większą liczbą pacjentów niż aktualnie.
Przykłady takich obliczeń, które wykonujemy, są to chociażby trenowanie modeli sztucznej inteligencji, takich jak sieci neuronowe. Wymaga to często wielu godzin pracy takiego superkomputera. Często uruchamiane są zadania, które wymagają faktycznie kilkuset czy nawet tysięcy procesorów działających równocześnie, równolegle.
Kiedy zrodził się pomysł wśród członków naszego zespołu, uznaliśmy, że tym naturalnym kolejnym krokiem jest, że się tak wyrażę, instytucjonalizacja tej współpracy.
Teaming for Excellence pozwolił na powstanie Centrum Doskonałości, jakim jest SANO. Współpraca z NCBIR-em pozwoliła nam na złożenie projektu finansowanego ze środków unijnych w ramach Horyzont 2020 Teaming for Excellence. Dzięki NCBIR-owi możemy tworzyć Centrum Doskonałości wraz z innymi partnerami.
W przeciągu 7 lat realizacji projektu Teaming for Excellence planujemy zbudować centrum samowystarczalne, którego jakość wyników naukowych pozwoli zdobyć kolejne finansowania na trwanie i rozwój.
Mamy dostęp do najlepszych specjalistów, takich jak eksperci od symulacji z Sheffield, czy też eksperci od superkomputerów z Niemiec.
Jest to taki miks kulturowy, ale też miks różnych doświadczeń akademickich i badawczych, co napędza właśnie taką kulturę innowacyjności czy kreatywności w SANO.
SANO jest takim centrum, które staje się ważnym punktem do współpracy naukowców, którzy mogą wymyślać nowe tematy badawcze, także spotykać się. No, przykładem tego są chociażby seminaria organizowane, zbudować taką masę krytyczną, umożliwiającą prowadzenie badań na rzeczywiście światowym poziomie.
In Kraków, a remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city center. Besides monuments entered on UNESCO Heritage List, Kraków has something else to offer. People. In Kraków every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Kraków. Kraków has become the center for modern services in Europe. Kraków is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Kraków is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Kraków, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Kraków is increasingly associated with excellent cuisine. Its restaurants offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków.
SANO – Centrum Zindywidualizowanej Medycyny Obliczeniowej. Projekt realizowany jest przez AGH Cyfronet, Klaster LifeScience Kraków oraz partnerów zagranicznych Uniwersytet w Sheffield z Anglii oraz Fraunhofer Gesellschaft i Juli z Niemiec.
Główne wartości, jakie przyświecają SANO, to pasja, to innowacja, to wielokulturowość i zrównoważony rozwój. SANO w języku esperanto oznacza zdrowie.
W ostatnich latach jesteśmy świadkiem olbrzymiego rozwoju metod pozyskania danych o pacjencie, jego chorobie w ujęciu indywidualnym, jak i w ujęciu populacyjnym. Jeśli nie wykorzystamy takich metod, to bogactwo danych, jakie gromadzimy na temat pacjentów i ich chorób, zostanie zaprzepaszczone.
SANO jest instytucją badawczą, która prowadzi badania z zakresu medycyny obliczeniowej, gdzie próbujemy wdrażać rozwiązania bazujące właśnie na metodach obliczeniowych oraz sztucznej inteligencji, które będą mogły znaleźć zastosowanie w praktyce.
Staramy się tworzyć coś takiego jak awatar pacjenta, na podstawie którego możemy właśnie symulować różne procesy i podejmować decyzje bez
Well, so good afternoon. Welcome to the second part of health tech session of LifeScience Open Space. And exactly as it was in the first part, we start this session with our keynote lecture, keynote talk, and the keynote speakers of this part of the session are two persons from our Cancer Center II, which is a institution, a company which is dedicated to cancer detection with artificial intelligence and deep learning. And these two keynote speakers are Piotr Krajewski, who is the co-founder and chief executive officer of this of Cancer Center, and well, he is known for his passion for developing new solutions, and the second person is Jarosław Kwiecień, who is Chief Technical Officer. He's data scientist, developer, and who is also a fan of functional programming, which is not so, let's say, often encounter in nowadays. Anyhow, welcome both of you. And floor is yours.
Thank you. Hi. Hello. As President said about us, so I'm Piotr Krajewski, and with me is Jarosław, and we would like to talk and present some more details about cancer diagnosis process and using how we use AI in this process. So please, just a second, we share the screen. Okay. Yes, so as we mentioned, we are founders of Cancer Center, and we support first step of cancer diagnosis process, which focus on images. And this story started because of my godson Jacob had a cancer, brain cancer, and I saw how the process looks like, how the process is so long, how long we have to wait for further diagnosis, mainly in pathology step, and based on this history. We start project which try to help the pathologists, radiologists, and oncologists to speed up this process. And today, the process looks like on the slide. First, we have a blood test and some markers test and radiology test. So it's the first step. And based on this, it could be CT scans, MRI scans, USG. So it could be any radiology images. And based on this, there is a decision about next step, about biopsy or surgery. And from this step, there is a tissue to analyze. And this step is, the owner of the step is our pathologists, and they focus on see how the tissue looks like on the microscope, and based on his decision, there is a next step about treatment. His decision is connected with staging, risk of if it's cancer or not, and how risky is. So this is crucial step in cancer diagnosis process. And that's why we focus on this first two steps. Why? Because as I mentioned before, this process is so long. The main point why is so long because there is not enough people in this area. For example, in Germany, we have almost one pathologist per almost 48,000 people. In Poland is similar. And so there is not so many people, but the second point is that the pathologists, for example, focus on some areas. The brain, human brain, it's not possible to remember any cancer. So pathologists focus on some areas. For example, one focus on breast cancer, second on brain cancer, etc. And so from this perspective, there is less pathologists that we have. For example, in Poland right now we have active around 400 people in this stat. Second point is that they work on their old school equipment. For example, it's a microscope, and they don't have a digital version of data. They use microscope and the traditional way of sending the tissue by post, by couriers, not digital version. So that's why, because of this three points, this process is long. For example, in Jakub, we have to wait for the first diagnosis 2 weeks, and the same was for the second diagnosis, second opinion. And that's why we have a solution for this. We focus on 2 steps in this in pathology area. First is digitalization steps, and for this we have a dedicated software which help digitalize data from microscope. And second is a web platform where we can analyze this kind of data, and there we can use AI to support this process. And I give the voice to Jarosław to mention about how we use AI in this process.
Okay, hello. Yes, I would like to tell you something more about artificial intelligence. And actually, I don't want to focus today so much about how currently artificial intelligence works in pathology, but I will tell you a little bit more about how it can work in the near future using the discoveries the tools that we have nowadays. So first, let's notice that artificial intelligence during the last years has been developing really fast, and currently there are many impressive applications of AI in real world scenarios. And I would like to explain how AI works, because this conference, LifeScience Open Space, is meant to connect scientists, IT scientists, and medical scientists, and business, and so on. And so cooperate well, we must understand the basics, how it really works. So I will explain this with the example of a goat detector. Let's imagine that we want to have an algorithm which decides whether we have a picture of a goat or something else. So to do this, we need to provide to the computer a huge collection of samples, which are pairs of input data and output data. So input data is what we, in the final product, what we want to give to the computer, and the output data is what we would like to get by the algorithm for this input data. So, for example, we want to give a lot of images presenting a goat or something else, and this will be input data, and the output data will be the label that it is really a goat or it is not a goat. And we give this to the computer, and then the computer thinks for a lot of time, and finally he finds a mathematical function which transforms the input data to the desired output data on the given samples. And that's it. There's no magic inside. But if we, for example, give it, for example, 10,000 pictures as the training data, and we see that there's a function which works for this 10,000 of pictures, then we may hope that if we go with another picture, which was not in the training data, but it's like we go with the picture number 10,001, then this algorithm will work too. But it's only a hope, and sometimes it works, sometimes it doesn't. It depends how good training data we have, and it also depends on the training process. But I will not talk about this more today. Yes, and this function, maybe it sounds unbelievable that we have a mathematical function which does such complicated things, but we need to understand that this might be really a complex function. So, for example, it can involve billions of computations. So now we know that artificial intelligence is amazing and we know how it works. So now let's understand why there are so many successful applications of AI in digital morphology. So I prepared like a pictorial explanation of this, comparing again to this goat detector problem. So we would like to comparing detection goat to what we do in digital photomorphology, and then we should not use images like this, but it would rather be pictures like this. And if you look very precisely, then maybe you will find the only one goat in the picture, but well, it's not easy. So first of all, in digital pathology, we have enormous images, which are way too big for classical neural networks, which are the core of artificial intelligence. And also only a small part of the image may be significant in terms of diagnosis. And there are some ways to deal with the problem, and the easiest and the most common one is just to split the input image into hundreds of or thousands of smaller pieces. But it means that instead of one image, one input data per medical sample, we have hundreds of input images. So we need to generate also hundreds of output data, which are, for example, the diagnosis made by the pathologist. But it means that we need to involve pathologists to annotate a lot of very small images per sample, and it requires a lot of time. And generally, as we work with pathologists in Poland, they do not have time for this. And there are also some other problems. For example, if we split the input data only for smaller patches, then we lose the context of the entire image. And another big problem is that even if we go through the costly process of data annotation, just precise data annotation, for example, data from one laboratory or hospital, then we have an algorithm and we want to use it in another place, then it may turn out that it doesn't work at all. And that's because there are different scanners, there are different methods of processing the sample before it gets scanned, and it all makes a difference. And to work really well, we need data from many different sources. And if we need data from different sources, then again we have a lot of work with this detailed annotation. I would like to tell about 2 examples of technologies which may help overcome those issues and work with so-called weakly annotated data. So we have we don't have to spend a lot of work giving the data annotation. So one of them is something that I will call here whole slide CNN, and it's very clever technology. Actually, I can't explain you the details because it's too technical, but it enables us to train neural networks on those very big images. We could say that it's general technique. It's not only related to digital morphology, but it was created especially for this because digital pathology is the case, is one of the most significant cases probably where we have so big images and it is so difficult to give a detailed annotation. Yeah, so why is it so cool? Because in this case, the only thing that we need for a scan is one classification. So, for example, this might be the diagnosis given by the pathologist. So this is the kind of data which is produced actually by the pathologist during his daily workflow, and he doesn't need to do anything more than he does every day without thinking about some training AI algorithms. And also it looks like a black box maybe, but it is not, because it is possible to point out the regions that make the algorithm think that the diagnosis is what he gives to us. We can then look at the regions precisely and verify if it is correct. Yes, and another technology is the image registration. It's also quite new, and there are algorithms which enables us to do a precise mapping, one-to-one mapping between scans of the same specimen under different stains. And it's very useful for a pathologist itself, but it provides us also it is also useful for a data scientist, because those aligned images are very good source of data, and again, it doesn't require any additional annotations made by a specialist. So let's come to some conclusion why it is so important, because now the only thing that we need to do to make this training process more efficient is to just adjust our daily workflow. I mean daily workflow of a pathologist to use the tools which were designed with training AI algorithms in mind. So there are the tools which collect the data in a standardized way and then enable us to export the data for the training process. And we have prepared a few solutions for this. We have we use standardized reports and have a few solutions related to digitalization. So maybe Piotr, could you tell us something more about them?
Okay, thank you. Yes, we have a solution which, as we mentioned, helping digitalize a process from microscope. It's a PathoCam solution manual whole slide imaging software. Then if we have a digitalized data, we can use from scanners or microscope, we can open it in Patho platform and annotate, analyze with AI, share in web browser. We have a dedicated AI modules for analyzing pathologic slides, and medical second opinion platform for what was in my case, for example, my family case, where we looking for second opinion to confirm first opinion. So this is the platform where we can upload data, radiology data, pathology data, and other descriptions, reports, and take a second opinion with experts. So I just want to show you how the PathoCam works. Just a moment. Okay, so this is solution where we digital. Many pathologists use microscope. So this is the view from camera, from microscope. On the top left corner, you can see how the images is stitching and build whole slice. And then after this process, we can analyze this. Without digitalization, we can't do anything with AI supporting and sharing data. Now the data is going to Patho platform and to be open, annotate. So this is what we do by PathoCam and Patho platform. And on the Patho platform, I want to show you our platform, how it looks like. So this is, for example, the images on the one slide from biopsy from prostate, and I open Gleason score Gleason score algorithm, which show which region is which score on the slides. And because today pathologists have to do it manually, they have to analyze by eyes through microscope average percent of which score is, and this Gleason score is connected with staging of cancer, so it's very important diagnosis. So we want to, we support this process to show exactly how many scores is and where. We have the same on Patho platform reports. Let me change the language to English. Yes, so we have to use standardization of reports, because it's important to use the same sentence, the same dictionary for the data. So we use ICCR reports for this. It's a global community of pathologists, and we use a WHO dictionary to choose right tumor type and or other points in reports. So it's something very important, because the same in radiology is important to have the same understanding of data. And it's possible to share this data to another group, another second opinion. So it's not taking 2 weeks, but it could be done in seconds or minutes. Back to our presentation. Just a moment. Okay, so sorry, I just finished. I just want to mention about radiology, because we don't touch this point, but at the end we do also AI for radiology steps, because it's before pathology, and because for example urologists mentioned us that they need to do precise biopsy, and for this they need AI to support this process. So that's why we also do AI in radiology. Yes, so thank you very much for your attention, and if you have any questions, feel free to ask.
Many thanks for your talk, and I would like. Still, we have something like 5 minutes. Yes. So, for me, center is a kind of institution which somehow, in a reasonable way, combine both scientific activity together with practical implementation. So maybe if you could comment about this, about how you connect this activity, which is related with being present at important conferences, publications, and implementing this into, let's say, practical form. Can you tell more about, let's say, who is working at your center?
Mm-hmm. So now we have a main team in our company, but also we cooperate with hospitals and scientists from R&D institution or university, because we see that we would like to speed up developing of AI algorithms. So we built our platform, and we want to share not only our company AI models, but also others, third-party models. So this is what I think one point what could be interesting, and based on this, of course, we do together publication or research in this area with this scientists or institutions. And the same, we can cooperate with hospitals. Two kind of cooperation. One is commercial cooperation, where we share our platform, and it's based on subscription model. But second could be, for example, work together on new AI model, for example, for cancer, which we not cover yet, and we can together work under this, and of course it could be in the future some fabrication or commercialization in this field also. I'm not sure if I understand.
Yes, I think that it was very important to add this to your presentation, because it looks that you are very timid in what you have presented, and I think that it's very important in this. And I think that as I understand, you have been also partner in some European research projects. Yes. Am I right?
Yes, we cooperate with hospitals and centers in Poland, but also in Switzerland. We have one hospital there in prostate cancer area, but also we try to open new markets, for example, in US and in Spanish language countries. And last week we were in Medica, where we meet other companies and science institutions from Italy, for example, or Germany. So we want to expand our for international cooperation also.
And I have a question about because we all know that for Comarch is also involved in health area for a long time, and they have own products, mostly related with wearables. However, it would be interesting for me if you consider them as a competitor or a possible collaborator.
I think cooperator, because companies not cover everything now. Yeah. So, for example, if we talk about Comarch or other, for example, Asseco or other software provider, they cover some parts of hospital systems, but not everything. We see that there is laboratory systems, for example, but there is no system which work with images and computer vision. So we feel this area, and it could be synergy if we can have cooperation.
Well, many thanks for your talk. Many thanks for discussion. I hope that this session will bring you more collaborators, and it will be opportunity to somehow to for both sides, for you and for others, to, let's say, to contribute into this fight with cancer in a more efficient way. Thank you very much.
Thank you very much. Thank you. And yeah, we are open for any connection and cooperation. Feel free to write to us. We are on the platform and we can connect directly.
Well, so I think that LifeScience open space platform will help for finding new, let's say, interesting partners for both for scientific and let's say commercial activity. Now we are going to this part of this session, which is called collaboration offers, and it is split in two parts. In each of them, we have 4 10-minute talks. So I kindly ask presenter to keep this 10 minutes. We will make a kind of sound a minute before, and after this 4 talks, we will have a kind of discussion, and it will be discussion about collaboration, possible collaboration, which you will see just after this session. So this is what we are going to have now, and well, the first speaker of this collaboration offers session will be Anna Gawrońska from Poznań Technology Institute. As I understand, it is a part of Łukasiewicz network. Anna, the floor is...
To jest film.
Yours.
To jest film.
Will be a movie?
Yeah, it's a recorded speech.
Good afternoon, everyone. My name is Anna Gawrońska, and I have a great pleasure to represent the Łukasiewicz Research Network, Poznań Institute of Technology today. I'm gonna give a short presentation about enhancing patient health and well-being by streamlining processes in oncology. Oncology is a very important field in medicine, but still we can observe many challenges in this particular field. First of all, there are some challenges regarding organization of services. There are also some bottlenecks with respect to procurement. We can still notice some problems regarding authentication of medicinal products that are administered and dispensed to patients. And we also have a lack of knowledge about the available resources used to diagnose and treat cancer patients. We have also some problems with making appointments, and this is all very crucial with respect to the treatment of these patients. How to support process management in oncology? We can use many methods and techniques that have already been used in other industries and that have been becoming more and more popular in the field of the healthcare industry. First of all, we can use digital tools to manage the flow of patients and goods. And by digital tools, I mean electronic documents and also barcode scanning. We can also design effective mechanisms that prevent us from the influx of counterfeit drugs or medicines from unknown sources into the legal distribution chain. We can also build solutions that can confirm drug administration namely by scanning the barcode and assigning this particular drug, medicinal product to particular individual patient. We can also use digital tools to manage the process of using diagnostic devices, because this is also a problem when you have a look at the process of planning medical services to oncology patients. There are a lot of benefits of streamlining processes by means of bedside scanning, by means of digital documents, by means of implementing digital documents into this particular area of medicine. First of all, we can notice greater transparency of processes, and this is very beneficial from the point of view of ordering, planning, and service provision. And then we can also notice reduction of order processing costs, procurement processing costs in hospitals, and it's like 95% in the context of one document that is used in the procurement process. And this is the result that we obtained or achieved in our institute when we delivered one of the projects in a Polish hospital. Then we can also the reduction of the workload of especially nursing staff. So these people who are responsible for dispensing medicinal products to patients, by using digital solutions, we can decrease or reduce this workload by nearly 80% in the context of one process. What is also important is that we can limit the number of expired doses, but on the other hand, we can also reduce the number of missing doses. So in summary, we can say that if we reduce the number of bureaucratic activities, elimination of paper documents and shortening elimination of paper documents and introducing digital services, digital solutions, we can shorten patient service time in this particular field. And now I would like to tell you a few words about the essence of actions, about how we are doing projects in Poznań Institute of Technology. First of all, our projects are based on the following components, which is improving the organization's business processes. We perform business process analysis in organizations. Then we give access to the process repository, where all maps developed are included. And what is also very important, that we engage the staff that is supposed to deliver the changes in their organizations into the process of building new maps. So this is also very important, because we are not doing it on our own. We are doing it together with the people that are going to implement the changes in their organizations. So this is also something that is worth mentioning in my view. And yes, we also give some kind of support when a hospital, when a company makes a decision to implement particular changes. We also cooperate with the IT company to implement the changes into their IT system. I mean the IT system that is used in this organization or a hospital. The method that we are using has been developed in the institute by our team, and it is aimed especially at identifying the current state of the processes, the current state of the situation. So we do this process modeling that is called as-is process analysis, but then we have a greater look at what can be improved. So we identify all bottlenecks or limitations that are a problem in individual processes. And as I mentioned earlier, we encourage hospital staff, for example, to take active part in shaping and creating new processes. Then we are also able to perform something that is called process simulation, and we can see potential or forecasted results of our implementation before we in fact implement all the changes. And if the changes that we propose are not satisfactory for our client, then we do other scenarios that might be more beneficial and might be acceptable by our client. We also provide our clients with key performance indicators, such as average working time, average service time, or use of resources. So we show our client how some KPIs will change when we implement particular digital solutions or tools. And with respect to the presentation of the results, we leave at the customer's disposal, first of all, a very short and concise report where all KPIs are included, so one can compare as is and to be state. But we also give access to the process repository, where all models of processes are included. And clients can also include some comments in this repository. So this is also a good way of collaboration for us. And in summary, I would also like to mention our experience. We have almost 18-year experience in implementation projects for leading hospitals in Poland. We have been also cooperating with government agencies as well as with industry associations, which is also very important. And we have an experience in implementing different standards, interoperability standards, such as GS1 standards, for example, in the field of product identification and exchange of electronic documents, I mean business documents in an electronic form. So if you have any further questions, I encourage you to contact me, and I'm sure that we can improve processes in the field of oncology for the sake of patient health and well-being of the patients as well. Thank you so much.
Well, thank you very much. We had heard about improvement of all these procedures related. They may be probably related not only to oncology, but also to other diseases. Many thanks. And now we have the next speaker of this session. The next speaker is José Souza from Sano Center for Computational Medicine. So, José, welcome. Floor is yours.
Thank you, Marion. So I hope that you can hear me. So I'm José, so I'm presenting the work that we have been doing here at Sano from the personal health data science group perspective. So we are mostly focused on non-communicable diseases. So what I'm bringing today is just one example of one of the projects that we are developing in collaboration with a partner in Northern Ireland. So it's related with how you could reduce the window of the diagnosis, or trying to move from the diagnosis perspective on cancer to a prevention perspective. So this is the team that I've been putting together for the last year. So it's very diverse, as you can see. So we address so we have a medical student, theoretical physics, computational people, and also cognition and biophysics perspective. So we have this vision that we would like to do prevention before being patient. In this scenario, so what we are mostly focusing is on, we have this diagnosis. We are applying a lot of different methodologies into diagnose, but can we move that window to an early stage where we understand the diseases, we are able to stratify possible paths or develop different approaches on the way that would allow us to understand the disease from one side, how it progresses, and also to implement some prevention policies. So as you can see here, today, this digital journey, that we can call it a digital pathway, it's covered from different dimensions. So you have individual data that is stored in your electronic health records that are in a particular hospital. You have genetic data that you collect when you are diagnosed with something. You have all these interdependence data, but in reality, each piece of this data only serves a certain stage on this digital pathway. So it can be for validation, but then doesn't integrate with monitoring or with progressing or understanding how you can have a better outcome from the treatment that you are applying to a certain patient. So we are addressing that fundamental nature of the data. That is, if you want to create this digital pathway, you need to have this broad vision about how you would integrate this data. So we started to look into, okay, we have these pseudo-connected realities, okay, where we think that we are connecting everything, but in reality, because of a lot of constraints, we are not really doing it. So we are just taking snapshots of the data, and then from those snapshots, trying to create the global vision of the reality that we are modeling. So we are coming to understand that for doing this, and from our perspective, there is an integrated way that needs to happen. So we are focused on these digital therapeutics where AI or machine learning technologies would come along to enhance our human capabilities of taking decisions. So we have been addressing that, how we can do that from one side, and where are the stages where that AI can be really helpful. So as you can see here, from the traditional diagnose pathway that you have from the analogical world, we started to ingest some AI approaches that would help and create the evidence that we can have a better outcome or have a better idea about prevention, stratification, and the prospects of developing a pathway much earlier in this digital pathway. So for doing that, we are tackling the approach of the machine learning engine. Okay, the actual machine learning hammer, deep learning, is mostly focused on raw access to the data, using raw data, and that comes with a constraint. So accessing raw data becomes very difficult because of a variety of reasons, but also fundamentally because also you cannot integrate different data sources. So we are focused on the possibility of using these two stages of what we call the reality sensing, where we expect to have machine learning models that allows us to create the perspective and also an expectation of what can happen, and then compare that what can happen with actionable knowledge. Okay, we know that this can happen, but how does the actual knowledge fits into what we know? So we are working very strongly on what we call data abstractions. Instead of using the raw data, we aim to use data abstractions produced by a variety of mathematical functions. And then we use those mathematical functions to start the machine learning process. So we don't apply machine learning on the raw data, but we apply machine learning on those abstractions and how they relate between them. So here what I'm presenting is what we have done on this classification of brain cancer from a data set from the Rembrandt repository. And we used, we tried to come up with models, or as you see further, with knowledge graphs that can stratify grade 2 and grade 3 patients. So that those are the models that I'm presenting here. So we stratify these grade 2 and grade 3 patient structure, and you can see they are different as expected. And on top of that, what we are doing is developing machine learning approaches to start to prospect how certain characteristics that an individual can have can take you into the development of a brain cancer, or can take you to developing a certain type of diseases. So we are using these what we call the node significance communities, and also the link between the associations to provide these expectations to the machine, where the machine will be able then to start providing realistic representations of what can happen. So in order to support the decision making. So what we found out by applying our methodology and what we are presenting here is that there is an element that came visible, that is this MIBL1, that came visible in the models of that we developed. And we went to validate that, and we found that there are lots of things that have been done around that particular element. So we think that what we have here is a very straightforward way to analyze data and provide evidence from the data, from the real data that we have, and from there extrapolate and start and allow us to develop new models that could help the developing new methodologies from machine learning. So this is just a brief presentation. So the group is also working on other diseases like cardiovascular diseases, cognitive impairment, also in other different types of cancer. So, but always with this approach. So what we are developing are new methodologies to allow the integration of different data sources by using this data abstraction composition of knowledge. So it was just a brief presentation. I think that I'm really on time. So so if you want to reach out to have further discussions or talk about some problems that you are facing with data, or that you'd like to ingest in data sources, so we are more than keen to help, and I hope that this presentation is helpful to demonstrate what Sanu is doing. Thank you.
Thank you very much, Jose. Well, you said that your methodology is applicable to any other diseases, but at this session we are concentrated on the cancer, and I think that in the discussion, participants of this session will be looking for possible collaboration in this area. But anyhow, many thanks for your concise and full of details talk. Thank you very much. And
thank you, Barry.
I invite you to stay for discussion.
Thank you.
Thank you. And now we have our third speaker of this collaboration offered session. It's Paweł Kunstman from Evidence Prime. Paweł, floor is yours, and 10 minutes are also yours.
Thank you very much for hosting me. So today we'll be speaking about Laser AI, which is a living literature review tool accelerated by AI. But we'll also talk about how to drink from a fire hose. So, before we actually do that, first a few words of background. So, for those of you who are not familiar with literature reviews, what they are. So, literature reviews are a required step to transform the published medical information. So, for example, the results of clinical trials or observational studies into actionable knowledge, which usually means clinical practice guidelines or reimbursement policies for drug or procedures or medical devices. And there are many types of literature reviews, and the ones that we are most interested in are the systematic reviews, because they are the basis for the guidelines. But as well, there are the HTA reports, the rapid reviews, scoping reviews, evidence maps, so lots of them. And the most advanced and most beneficial are nowadays the reviews which are called the living reviews. So, for example, living systematic reviews. These are the reviews which are being updated regularly, so they do not do not fall out of being up to date. And while the real-world data, for instance, based on electronic medical records, rightly gets the more and more prominent role in the industry, the literature reviews remain the most fundamental pillar of the evidence-based healthcare, because they allow to access the data in the publications, and almost all important information is published. And the process of literature reviews starts from defining of the problem, which usually is in a PICO question format. And there is usually a screening protocol which defines the methodological rules of a certain study. And then there is the search. And the search usually in the medical domain produces tens of, sometimes in the larger studies, hundreds of thousands of documents, which need to be nowadays manually searched or screened to check which of them actually apply to the topic and which do not. It is especially important in the systematic reviews, which need to address everything, all the documents in scope of the study. Nothing can be just omitted. So this part is called the screening, and its goal is to find the relevant, all of the relevant documents, all of the relevant evidence. So out of that, there is usually about 1%, sometimes less, of the relevant documents that have to be pushed through the data extraction process that extracts the data, which can then be used in some statistical software to do the meta-analysis on the data. So, for example, things like strains or doses or different types of numerical and non-numerical data are being extracted from the documents. And out of that, people do the evidence synthesis. So they calculate statistically what comes out of the documents and interpret that. And the result of that is a report, different types of reports, so HTA reports, systematic review publications, guidelines, and that's basically it. But if we go back to the search and do it regularly, so find out if there are any new documents that apply to the topic, and if they are new ones that would change the result of the synthesis appear, and if we apply these documents and to this evidence synthesis, then we are talking really about living reviews. So living reviews are just reviews that are repeated frequently for duration of many years. So that's our domain of expertise. And the problem is that there is a huge amount of published information, and this amount is completely overwhelming. So overwhelming that the 7% of the reviews are out of date on the date when they are being published. So, and this is according to the study, I think, from last year. So it is really, really new. And 23% are out of date within 2 years from the date of publications. And the reviews are typically out of date in 5.5 years. That's a median of that. And you can see on the right how it applies to the cancer studies. So, for example, over the last 100 years, there were almost 5 million documents reported in PubMed database on cancer. And 70% of these publications are from the last 20 years and 40 from the last 10 years. So we can see this. That's basically exponential growth of the information. And if we just look at the clinical trial results, this fortunately is not exponential, but it's still growing. Over the last 10 years, we had more than 30,000 RCTs published. So it is about 4,000 per year. And the systematic reviews on cancer are growing exponentially, actually. And over the last 10 years, we had 36,000, and last year we had 7,000 of them, and this year we'll have even more. So this is a huge amount, and they are really costly. So especially systematic reviews, which, as I said, they are the most important ones because they produce the most comprehensive information, and they are basis for the guidelines. They cost about $141,000 each of them in average, and average academic institution pays about $18 million per year for the systematic reviews that they do, mostly to their employees. And pharma companies pay about $16 million per year to their employees and to the consultants. So it's really a problem. And now with this cancer studies, we have one more problem, that these cancer studies are of really low methodological quality, unfortunately. And that means that they may contain critical errors because of the sponsor bias, which is very high here, unclear study selection, exclusion, statistical errors, and so on. And last year, there was an analysis of the cancer systematic reviews done with good methodology, and they found that it's really a very critical situation here, because 88% of cancer systematic reviews, literature reviews, are of this critically low quality. So why is all that? The main problem is that there is too much data and too few resources, and that's basically a simple problem, right? So we base the treatment and funding refunds of the drugs and procedures on outdated, incomplete, and potentially wrong data. And that's because we are drinking from the fire hose. There's too much data, we cannot drink it. So the problem is how to do it, how to drink from the fire hose. So, well, basically we use the automation, right? We use computers, we use machines. So let artificial intelligence help us. And computers are designed to efficiently handle repetitive tasks. They do not tire, they do not lose focus. And AI can be very good at spotting connections and analyze large amounts of text, for example, like here. And when we team humans with AI, the humans can perform their work much faster and better, reducing the risk of this information overload. So our tool, Laser AI, is a tool that helps with that, and it's based on the award-winning NLP, so natural language processing model, which we created in 2018. And we won the US NIST award for it. And over the next 3 years, we developed the tool based on research money from the European Union grant. And what we did is a tool that allows automation of question formulation and creation of study protocols, but most importantly, does the automated screening of the texts, both in title and abstract and full text modes, and that allows for semi-automated data extraction. And it allows also to monitoring of the new evidence, which in turn allows for doing the live reviews. And we already have some pilot projects done by, we have, for example, two biggest German HTA agencies working with us, EQUIC and EGBA. We have US government for their National Toxicology Program agency. And we have also Cochrane Canada working with us. And the workflow of the Laser AI is basically, as I told you before, but just automated, most of that. And the benefits for today, because we are, of course, just beginning our really journey in that, but we already have twice as fast data extraction in double screening, and it was proven in an independent study by NTP last year. We have 5 to 20 times reduction of screening workload in living systematic reviews, so monitoring of the new evidence. And that was, we achieved 20% speed up for that, achieved in the guidelines for American Society of Hematology last year. And we have an enterprise-ready web app, which is designed for large teams, organizations with management of concurrent workflows, with group privileges, things like that. And we have really first-class security. And last year we got the FedRAMP certification. So it's an American governmental security certification, which I believe we are the only company in Poland that has it, and probably one of the few in Europe. So why we are here? We are here to invite you to cooperate. So we are first of all looking for partners to conduct studies and research projects, so scientifically proper research of effectiveness of literature review automation and or reading reviews in healthcare. So if you have to do the reviews of literature in your organization, your company, your institution, and you would like to do the study, how much that you can spare the time, resources, money using automation, please tell us, because we would be very interested in doing proper studies on that. We have some, but we need more. And we can provide free tools for the duration of such study, and we can do something together. Please tell us. But we are also looking for partners for pilot projects. So application of this automation of literature reviews in your business. So, and we think that the most important fast benefits can be achieved in the pharma consultancies companies, HTA agencies, and medical device companies. So if you are one of them, or you have other idea to how to use the automation for literature reviews, please tell us. We would be very willing to do the pilot study with you. And that's it for today. So please contact us. Please write us on Twitter, on LinkedIn, and we are there listening and looking for partners. Thank you very much.
Thank you very much. Thank you very much. Please stay with us for discussion. And now I would like to invite Roman Major from the Institute of Metallurgy and Material Engineering of Polish Academy of Sciences in Kraków. Well, I should say not floor, but screen is maybe not the whole, but a large amount of screen is yours.
Thank you very much for the introduction. My offer of the future and possible cooperation, I would like to present in the field of how we fight with how we specify the post-treatment after the jawbone resection. In our consortium, together with our collaborators, we have invented so-called IPS. It is called individual patient-specific implants, which was developed in the frame of one of the European projects, especially mRNA project. So first of all, I would like to present you who we are concerning the whole consortium group, because as an institute, I cannot tell that we have developed the whole prototype of the implant. It's the work of the whole consortium. Of course, what was the idea? The idea was to invent the individual patient-specific implants, which was dedicated for the specific case of in the case medical case. What's the state of the art? State of the art, as you could see, is the huge implant made of metal. Of course, one of the golden standard which normally is considered till now is to use the own patient's bones, like femoral bone. Anyway, in our project we have proposed the metallic based material individual patients implants, which would be dedicated for the specific case. Here, I would like to present you the whole group of the collaborators, which I would like to also propose you for the future cooperation, because what is the most important in our case is the fruitful cooperation, which allows us to do something real. First of all, what was step by step how the work was executed. First of all, the planning competence. The planning competence the planning was based on the CT scan. So first of all, the patient had to be scanned, and based on mirroring effect, the individual patient-specific implants was designed as presented on the slides. Of course, not only jaw implant could be analyzed. Also, the temporomandibular joint area, which is also quite specific and very difficult for the design, because first of all, the material for 3D printing had to be predicted, and after elaboration, after preparing the final surface, should predict how much material, how many materials which we can remove from the surface to achieve the appropriate shape. But coming back to the real product which I would like to present today, jaw part. As mentioned before, the golden standard was to use the fibula bone, but what would happen in the case when the cancer would be spread too much for the another bones? There's no solution for the patients. Our answer for this problem was to use metallic 3D printed implant, which would be not so heavy and allow to introduce also the teeth to ensure also aesthetic effect for the patient. As mentioned before, we were working based on the mirror effect, and based on mirror effect, the implant was planned. And the procedure, how the operation looks like. So first of all, there's a prediction how it would be removed, and then how it would be introduced. There's the final design of the implant based on specific case. The next competence which we would like to offer you is the material development competence. Here in this case, in the area of fighting with cancer, we have developed mesh-like structures which are light and strongly adhesive to the surrounding bones. And as you could see, with a higher magnification, how the structure looks like, it is especially adjusted for the appropriate and rapidly cell growth on the area of the implant. What we do is analysis adjustment on the even nanoscale and atomic scale using highly sophisticated transmission microscopy, which we can offer you right in the institute. We can offer you brand new transmission microscopy purchased from Thermis, purchased from Thermo Fisher. You could see the implant was adjusted even on the nanoscale. The next competence which we would like to offer you is microbiological competence, because in this case we had to also predict the hospital complications which could occur in the case of implant introduction into the human, based on our collaboration of one of the competence from our consortium partner. We would like to offer you also such a competence which allows you to predict what could happen in the case of hospital problems. Next competence, molecular biology competence. In this case, in this project, we have developed genotoxicity and cytotoxicity based on lactate dehydrogenase analysis and also Luminex assay, which stated the basis for the genotoxicity analysis. And you could see the list of several the most important proteins which were analyzed, and the most important one, P53, which allows us to adjust and to judge which materials is the most appropriate for our purpose. And finally, what we did, we have tried in vitro how the cells would grow, would overgrow the implant, the structure which was developed before. And the most important is the transfer from laboratory to living organism based on in vivo test. In our one of our partners from our consortium, which we would like to offer you for the future cooperation, from Austria, from AKH Vienna, perform the in vivo test based on ships. In this case, it is the proof that the implants which was designed and adjusted passed the exam in the appropriate way. So there's an appropriate overgrowth of the bone in the implant, and such materials are appropriate materials for the bone reconstruction, jaw reconstruction, and higher magnification. So, and finally, what I would like to finally present you, all what we do should have a real application with the appropriate potential. And here you could see finally the demonstrator which was prepared in the end of the project. For the future development, I would like to ask whether you would be interested in to develop together with us and to transfer what we have from the level of TRL to a higher TRL, and to follow up together with us the transfer from laboratory to real clinics. Thank you very much for your attention.
Oh, well, many thanks for your talk, for this presentation. And well, implants are very important in healthcare. So now I would like to invite speakers of this part of a session to discuss possibilities for collaboration. Well, it seems for me that probably what is offered by Paweł Kunzman in his talk about literature review probably may be interesting for many teams working in this area. And I think that it is something what can be probably of interest to many of you. What do you think about this part which was about implants?
Who is the target of the question?
Well, to all participants of this session, and to everybody who can who would like to speak at this moment. How it can be related to oncology. So it's a question.
If I can answer, so it's maybe the question to my lecture. It's a fight with oncology, but it's a fight with a real problem which considers many of the patients. It's enough to go through all the statistics which are dramatic, because lots of patients are suffering. We cannot see it, but lots of patients are suffering because of the jawbone resection. And can you imagine to live with, for example, the hole in the jaw? It's impossible to live. Our intended target is to support such a patient. We've got a close cooperation with the oncology department of from Gliwice. We've got also consultations from AKH from Vienna, from the oncology department, and following the advices which we are obtaining from the medical doctors, we are trying to develop solutions which would be helpful for patients who are suffering with such a disease. In this case, also the psyche is also extremely important, because patients who are suffering with oncology disease, who are patients who are subjected with the jawbone resection, cannot properly, for example, eat, speak, or even are afraid to go somewhere just like a normal human being, because they are ashamed because of their appearance. Our intended target is to do everything the best, also to support their psyche. So I mean to develop such an implant which would also allow to, for example, introduce the teeth, also aesthetic, from the aesthetic point of view, is also very important in this case.
Well, I think that it is it's something which is a very valuable explanation. And I have a question to Jose. Well, do you think that there is an area for collaboration with what was presented by Anna at the very beginning?
Yeah, so business processes are really fundamental in any area that you are looking to. So if you are looking to improve, the delivery of a treatment, understanding how business processes can be enhanced or can be integrated are fundamental. And I think that they take care of a very strong part of of providing the right care to the patient. And what I see is that from the digital therapeutics pathway that I showed is normally that process is not part of when you look into when you look into the prevention. So if you are looking to prevention, okay, I have these very nice models that they can provide that can increase the level of prevention of a certain population. But what are the best business processes to do it? How can I give that or provide that information to the public in general? I think so. I think that the business processes and the automation that the hospitals need to achieve, or that any organization needs to achieve, is fundamental for the things that they are aiming to deliver. So I think that there needs to be a combination between those two things. The things that we do to implement the digital therapeutics and how effective we are, while at the same time you have this approach, okay, what are the best processes to make those things happen in real life? Yeah, I think I strongly agree with that.
Well, thank you very much. And I have a question to Paweł. To which extent, let's say, your methods, artificial intelligence methods, which are you using in this, are looking through medical papers, can be used in other area of digital health?
Mm-hmm. Well, we have actually quite a large spectrum of users already, because we have actually two lines of products, and then laser AI that I presented today. So the system for the automation of literature reviews is something that we believe can address the problem of which really grows larger and larger, of the costs and the time required to do the reviews, especially the systematic reviews. It is a huge problem, but it applies really to all of the aspects of especially of the medicine, but also for the reimbursement of the therapies. So there is a huge wide range of uses for that, because our technology really doesn't depend on so much on the area of the medicine. We build our NLP models, our language models, on the medical data. We started from the toxicology because that was our first partner 3 years ago, and then we extended that to basically the whole medicine. So now we have studies for medical devices, for surgical robots, for example. We have studies for hematology. We have studies in toxicology. We have actually quite a lot of them, and so therefore I think that in what we would like actually to give the world, I'd say, is a way to address the problem of the overwhelming amount of evidence. It's pretty obvious it must be automated, because we are just so far behind the time required to do the review and keep it alive. that there is no other way of doing that. The problem is, of course, with the regulations, because still the trust for the automation, for the AI, is not so high, especially in the formal environments, in the government, in the regulatory agencies. But even they start to understand the problem that AI is being needed. And the German agencies, HTA agencies, actually they are governmental HTA agencies, are probably on the forefront of that. But I think that it applies to wider range of domains in the healthcare.
Well, thanks. I think that there is also well, probably it would be necessary to use, let's call this less artificial intelligence, if the way of publishing let's say, writing papers would be, let's say, more have more, let's say, standard form. And what I find very inconvenient, it is the way in which people write abstracts, which are to some extent the same portion of information which is in introduction, instead of giving a real summary what is inside the paper. So this is probably something what.
You're absolutely right. We even had to write a patent application for normalization of the abstracts, because they are so different. So it's kind of crazy thing, but you are right. I mean, but I don't see actually that coming soon, because it's pretty obvious that the publication should have actually the metadata published in a kind of source form, right? Why to parse the text if you can extract the data directly? But the problem is that it's not so easy. First of all, there is a way of doing things which that's the way it was done for last 100 years, as we could see on one of my slides. That's one thing. And the second thing is that there is a lot of things that can be expressed in text that we don't have a easy way to express in the metadata, because there is context, there are nuances. We cannot even as humans agree to have a common dictionary of the medical terms, because they are also contextual. So this contextuality is something that probably we're not yet as humans ready to face. And so therefore, I think that these types of technologies that we do will probably have to be used for next, I don't know, 20 years or something. Maybe eventually there will be a way, but I don't see it coming soon.
Well, it is a kind of a compromise between writing in standard way and, on the other hand, don't produce something which will be completely boring. So it's
absolutely.
Well, many thanks for participation in this discussion session. Thank you very much. You are still invited to take part in the next discussion session. And now we move to the second part of this part of the health tech session of LifeScience Open Space. And as a first speaker, we have Andrzej Siwiec from Kancelaria DBS. So Andrzej, you are invited, and screen is yours. Your slides.
Good afternoon. Thank you for the introduction and for invitation to LifeScience Open Space. My name is Andrzej Siwiec, and I am attorney at law from DBS law firm from Kraków. I specialize in pharmaceutical law, and I would like to present topic related strictly to pharmaceutical market and medicinal products. Subject of my presentation is orphan drug designation for cancer medicines, how to make drugs for rare cancers more valuable at the early stage of development. We can divide medicinal product life cycle into some specific separate stages. And if we treat this life cycle in a linear way, we would probably consider commercial aspect of our product at the stage of product commercialization or product launch. However, from my experience of work in some product launch preparations, it is really beneficial to assess commercial potential of the product at the stage of product research and launch preparation. And I would like to present you how you can use legal regulations to increase value of your medicinal product. And I would like to present a case of orphan drugs. Orphan drugs are drugs indicated for treatment of rare diseases. I will present European Union legal landscape, but there are similar regulations in the US and in Japan. So potentially your products can also benefit from non-European legal regulations. And there are specific requirements to obtain orphan designation in Europe. A product must be intended for the treatment, prevention, or diagnosis of a disease that is life-threatening or chronically debilitating. And the prevalence of the condition in the EU must not be more than 5 in 10,000, or it must be unlikely that marketing of the medicine would generate sufficient returns to justify the investment needed for its development. And no satisfactory method of diagnosis, prevention, or treatment of the condition concerned can be authorized in the European Union. Or if such a method exists, the medicine must be of significant benefit to those affected by the condition. If you want to obtain orphan designation for your product, you have to submit an application to European Medicines Agency, and the application is examined by Committee for Orphan Medicinal Products of EMA. And according to the opinion of the committee, European Commission grants or refuses to grant orphan designation. What is important, the application may be submitted at any stage of product development, but before marketing authorization application. So you are allowed to submit the application even at the early stage of development of your product, as long as you have some clinical data supporting your application. And at the moment of marketing authorization grant, there is a re-examination to check whether the conditions for orphan designation are still met. And what is probably most interesting are benefits from orphan designation. The first benefit is automatic access to centralized procedure, which means that you are allowed to obtain one marketing authorization for your product in all European Union countries within one registration procedure. The second one is scientific advice of EMA during product development and preparation of registration dossier. Another benefit is market exclusivity for the product. Orphan products benefit also from reduced fees for regulatory activities before EMA. There are also some specific incentives for micro, small, and medium entrepreneurs. European Commission and also other organizations have some specific grants for development of orphan medicinal products. And what is also important, in some countries, including Germany and Italy, there are special regulations for pricing and reimbursement of orphan medicinal products. which means that you may be able to obtain better pricing for your product. My experience is that from perspective of a potential investor or licensee, market exclusivity for the product and potential better pricing are big advantages of the product during the stage of its development and launch preparation. And a few more words about market exclusivity. It is specific regulation for pharmaceutical market. It is a non-patent protection of pharmaceutical innovation, and orphan exclusivity is granted for 10 years since marketing authorization grant. And it means that no marketing authorization will be granted and no application for marketing authorization will be accepted for similar medicinal product in the same indication. Exclusivity may be reduced to 6 years if at the end of the 5th year it is established that the criteria for orphan designation are no longer met. And in some cases it may be extended to 12 years in case application includes the results of studies conducted in compliance with pediatric investigation plan. There is a specific regulation for pediatric medicines. There are also some exceptions to the exclusivity. The first one is a consent of marketing authorization holder for second application. A second one is lack of sufficient supplies of the orphan drug. And the third one is clinical superiority of the second medicinal product. Thank you for your attention. If you have any questions, my contact details are on the last slide. And thank you.
Thank you very much for this talk. You are kindly invited to discussion at the end of this part of the session. And now I would like to invite Krzysztof Łukaszuk from Ioni Krzysztof, screen is yours and your slides. We can hear you. We can see slides.
Yes, you can. Can you hear me?
Yes.
And you can see my slides, yes?
Yes.
Okay, so thank you for possibility to show our results. We are from totally different worlds. We are mostly from science, and one of part of our interest is also oncofertility, and this is our connection between reproductive medicine and oncology. So in one of our research, we tried to answer the question: does hormone therapy affect breast cancer risk? So the breast cancer is the most common cancer in women. 1 in 8 women will develop cancer during their life. Most of them will be found in women after the menopause, but about 20% will be treated in menstruating women. The problem which is known that the exposition for estradiol is one of the factor which influence on the increasing risk of cancer. And that's why early first menstruation, but also late menopause, increase the risk of cancer. On the other hand, when there is a lack of progesterone in the life, it will also increase the likelihood of development of breast cancer, and it happens when there is lack of offsprings or there is late birth of the first child, or in women with PCO syndrome, which means polycystic ovary syndrome. We also know that lifestyle influence our risk of cancer. So if we have improper diet, and also lack of physical activity or irregular physical activity, we increase our risk of cancer. And also obesity is one of these factors. All of them we are able to influence on them if we like. But we know that there are many myths and controversies regarding the use of hormones during infertility treatment, but also during the contraception, taking hormonal contraception, and also using hormonal replacement therapy in menopause women. So that's why we made a collaboration between academics, NGO, and business, if we can call us business. We are a team of Medical University of Gdańsk doctors, and also the Polish League Against Cancer, and IONI-App, which is, in our knowledge, the first medical application for reproductive health and infertility. Why we created IONI-App? We did it because we want to make a difference and be a game changer in reproductive health. We also want to challenge current trends because most of cycle trackers which are on market are made by people who are not totally connected to medicine. They are amateurs and they are doing it just for business, which is not our aim. And also to build awareness by giving support in decision-making based on diagnosis and personalized treatment options. So what we have in our IONI, we have reproductive health experts on board, but also we want to support women on every stage of their reproductive life, but also after the reproductive life. We have specialists on AI, and we are doing in-app research, and we translated our app on 15 different languages, and now we are trying to translate them to other. One of the part of our app is also part connected to sex life and intimacy. Is made because people who are trying to conceive, they have lots of problems in relationships between couples. So what we can get from this? We can get health and fertility assessment. We also produce personalized reports without without doctors, because it's already included in this app, the knowledge of doctors. And we produce advice and treatment options. And if someone has problem in understanding this or needs something more, or is more complicated case than on average, it can be also possible to contact with top-class doctors from US, Poland, Belgium, or Denmark. How you can participate in our work? You can help us to increase the amount of surveys of oncofertility. So how can you do it? You just have to create account with IONI, and then put in the special code like onco, and then complete the oncofertility survey. Till now we have a summary of the first 1900 participants. So we can say that 1/3 of the responders already have children, 2/5 of them were using or had used hormonal contraception in the past, and more than half tried or were trying to have offspring. And what is interesting, even in this group, we found that quite huge group of women had some problems and treated the infertility, means they were contacted doctors and make some procedures. Also in this group, we found 56 people diagnosed with breast cancer, and the average age of diagnosed cancer was 35. And from this group, 105 were genetically diagnosed, and 12 of them, so about more than 10% were carriers of the BRCA mutation, which is quite obvious in young cancers. So how can you may engage in our project if there are some people who know women over 40? Please ask them to take part in our survey. If you are doctors, you can monitor your female patients using IONI app to track symptoms, test results, and progress during therapy. And if you are a researcher, you can run your research with us. So I have to mention that some of this part of our application, like this IONI Med, but also this IONI for couples, supporting relationships in a relationship, and also internalization were co-financed by the Norwegian grants. So the IONI app, as I mentioned, is the first medical app for reproductive health, and it is a proven tool for effective data collection and patient monitoring, but now also treatment. Thank you, and if someone wants to contact us, here is our email.
Well, thank you very much. Thank you very much, and please stay with us for discussion. And at this moment, I would like to invite Eva Walicek from Customy. Well,
hello.
Good afternoon. Well, you are welcome. Screen is yours, and also for your slides.
Thank you very much. I hope you can see my screen right now.
Yes, it's okay. We can hear, we can see you and your slides. So go on.
Yes, so we can start. Thank you very much. It's a pleasure to be here, and thank you for the invitation. A few words about Customy. Customy is a medtech company which operates in the field of software as a medical device. But we originated in craniomaxillofacial reconstructions and implant creations. We have been designing and manufacturing custom implants, surgical guides, and anatomical models for oncological patients. And since the beginning, our mission was to offer the highest quality personalized treatment for a patient, and also to support the surgeons. As we know, the standard surgical treatment techniques are cost ineffective, and what's more, in nearly 1/3 of patients are dissatisfied with the results of such treatment, which I guess this was the topic of a previous presentation as well. So, but if we use, for example, anatomical models or surgical guides for each operation, we can save up to $3,700 per each case. And what is more, in 92% reconstructions, we can improve the accuracy of it. In parallel to implant designing, we also were developing the software for easy conversion of CT MRI scan to personalized implant models and surgical guides. Anatomical models are the tactile models, which are 3D printed and can be used during the communication with patient, during the surgery planning, and also for the education reasons. Surgical guides are the one-time use navigation tools which can move the previous preoperative planning to the surgical operating room, and they navigate the surgical tools. And of course, personalized implants are designed for the one patients, and they are patient-matched anatomies. And let me share one case which we have. A male patient was diagnosed with a really extensive hip tumor, and the surgeon decided to remove the tumor and replace it with the custom implants. So we were working on designing the implants in a structure which had also integration with the bones surrounding it, and also we designed the surgical guides for removing the tumor, for placing the implant and the anatomical models to better preparation for the surgery. And so what's really interesting, this is a very extensive and massive surgery, which was completed in less than 4 hours. And after that, the patient could go back to his normal life. So having that in mind, it's really important to know how the whole workflow starts. So basically, we start with the diagnosis, having got the CT or MRI scan. Then we work on the DICOM images. We do some image filtering. We do the segmentation process, which is the translation from the slices of DICOM images to the creation of 3D virtual anatomical models of the patients. And having got that model, we can start to 3D printing the anatomical models, or we can start to designing the patient-specific implant or surgical guides. And what we wanted to achieve while developing the custom vision, we wanted to achieve the tool that will be easy to navigate, easy to learn, and which will simplify the segmentation process to minimum and give the right tool to the specialist. So we have a bunch of modules, starting with the import, which can import the different types of medical scans. We have the segmentation, which translates those medical scans to 3D model. We also we have the registration model, which means that we can put different modalities of, for example, MRI with CT scan in one coordinate systems, and that helps surgeons to see the patient from different perspectives. I mean, on CT, their bones are very well visible. On the other hand, on MRI, the soft tissue are very well visible. So matching them two in one can give the surgeon the whole picture. We do also the virtual surgery planning in the software. We do the anonymization, and we are finishing also the CE certification for the medical device class 2A. And software works for both operating system, I mean the Windows and macOS system. And a few words about the segmentation, because I think this part might be the most time-consuming part of the pre-surgical planning. The translation from the CT slices to 3D virtual model, and we simplify it. We give the user two different kinds of algorithms, the base algorithm also with the smart algorithm, which help to navigate and to translate these slices to 3D bones, which are without the staircase artifact. And this also reduces the post-processing connected with this process. And our cooperation offer, we are looking for the medical units, for radiologists, for orthopedics, for surgeons, physicians, in fields of craniomaxillofacial, orthopedics, reconstruction, but not only. Also, we're looking for implant manufacturers to cooperate with us, to test our software, to give us the feedback. And we are open to collaboration. Cooperation. Thank you.
Many thanks for your presentation. Please stay with us for discussion. And now we have the last speaker of this session. It is Przemysław Korzeniowski from Sano Center for Computational Medicine. Przemku, floor screen is for you and for your slides.
Thank you, Marian. So, hi, my name is Przemysław Korzeniowski. I'm with Sano Center for Computational Medicine, and I would like to give you an overview of our work in Sano. Specifically about VR simulation for surgical training and preoperative planning in neuro-oncology. So before I start, just a few words about my group at Sano. My research group, so long story short, we basically try to improve patient care and prevention by using state-of-the-art technology. We apply so-called techniques of artificial intelligence. So we have very successful project in fetal imaging measurements, ultrasound presented 2 months ago at MICAI. We got project around pulmonary hypertension, which is a huge problem now after COVID pandemic. Project to help clinicians do their surgeons do their surgery. Like here, we can augment the fetoscopic feed for doing twin-to-twin transfusion syndrome surgery, TTTS. And we deal even with orthodontics, and within our group there is also a virtual reality laboratory, VR lab, which is equipped with collaborative robots, all sorts of virtual and augmented reality headsets, haptic devices, haptic gloves, 3D cameras, and things like this. So we are in total 12 people, mainly PhD students, 2 postdocs, and 1 psychologist. Okay, so one of way how we can improve like a patient care is basically to have better trained doctors, in particular surgeons, because the clinical complications are a huge problem worldwide. So they impact millions of patients, they result in 100,000 of deaths and cost healthcare system billions of dollars. So in short, you don't want to hear any oops during surgery, especially if it's on you. And the question is, how can we improve basically surgical acquisition of surgical skills? And currently the current training model, so-called apprenticeship model, is from 19th century, developed by Hallstedt. And it's a very simple model where a junior doctor assists more senior colleagues until he or she feels competent enough to operate on their own. However, this kind of practice is more and more questioned because of cost and ethical reasons. So there is more and more pressure put on learning to operate outside operating room. And here the trainee can choose between animal or cadaver models, so dead bodies. However, these are problematic, these are expensive, someone needs to prepare it, someone needs to store the animals or bodies, you need to utilize them, and they also bring ethical questions to the table. Alternatives are like a simple trainers, box trainers, where you can put a piece of plastic imitating some tissue, or even like a piece of chicken, for example, to learn to suture. So they are good for training like single manual skill, but not for surgery. So alternative are obviously the computer-based systems, and I developed a number of systems, especially at my nearly 10 years at the Department of Surgery and Cancer at Imperial College London. So I got simulators, validated simulators, published papers confirming the realities for cardiovascular interventions, prostate examinations, laparoscopic surgery, as well as flexible endoscopy. Some of my simulators, my software was licensed commercially because it's always nice to see it actually used to train clinicians, not only to gain points from publishing papers. So I got, for example, the ophthalmology simulator was licensed by Alcon US, and it's, as far as I know, they got already more than 150 simulation systems used by their clinicians. Okay, so going back to Sano, at Sano we developed the first simulator for spina bifida repair surgery. So spina bifida is a very nasty birth defect developed during early stage of pregnancy, in which there is an incomplete closing of the spinal cord, spine around the spinal cord. So basically the spinal cord is literally outside of the body of the baby, and we need to fix it quickly. And to do this, the surgery, it's done, it's a fetoscopic surgery. So it's done on a fetus in a pregnant woman. And this is very difficult. As far as I know, only 2 people in Poland can do it. And that's why we developed the simulator. We collaborated with Robert Brawura-Biskupski-Samaha from Pierwsza Klinika Położnictwa Ginekologii from Warsaw Medical University. And here you can see the real footage of the surgery, and here is our simulated footage. In the middle, there are simulation setup, and here on the right, there is photo from basically validation study. The results were published at International Conference on Intelligent Robots and Systems, so a top-tier conference in basically intelligent robots and robotics. last month in Kyoto. Why there? I'll tell later. Okay, so we don't have, at the moment in our group, we don't have any particular project regarding oncology. However, we collaborated with Brain and More Lab, so Alex Creamy group that we presented in the previous session, that deals with brain and neuroimaging, and we made a quick project that we overlaid the connectome, so as abstract representation of brain functionality, basically on a mold of a physical brain on a patient. So the idea is to take it further, and so the clinicians can use it for a preoperative planning. So basically, by making a cut in a physical brain, you will see how he affects the virtual connections of the brain, and see how basically which will be removed, but potentially where it's another route that the brain can like recreate its functionality. So it's a huge simplification. I developed ad hoc simulation for neurosurgery. So the idea is that we can load the brain data, the scan, MRI scan of the brain with a tumor, and with means of segmentation, we can have semi or automatic segmentation, which will lead us in a second to a simulation case. So here is like ad hoc simulation. It's really, it's very ad hoc, just a proof of concept. So yes, we can manipulate the tissue. On the left, you can see big devices, so the brain feels and the resistance of the brain, and we can make a coarse cut, so working to improve it. And that will also help in not only this loading directly from the data could have like many interesting cases for training, but also we can use it for preoperative planning because it's quick, so the surgeons can go through the case just before the surgery or the day before the surgery, and even they can move what would be the best cryotopic studies at minimal of the brain. And the ultimate goal would be to have a system which works intraoperatively, so image-guided surgery. And here is the case. I haven't found anything for neurology surgery. Here's the case for the liver surgery, where from French Institute of Informatics, INRIA, and Mathematics, where they overlaid the scan of the liver with the segmented liver with vasculature during real robotic surgery. So the surgeon sees where the crucial vasculature is going and where is the tumor located, even under like a big elastic deformations. So this video, although it's a few years old, I think it's now like 6 or 7 years old, it keeps impressing me each time I see it. So our project is a step towards such a system, and that would be all. I had two more slides on robotics, which didn't copy to another computer, but I think I'm good. So basically, we are open for, as always, we are looking for clinicians who are keen to collaborate with us on such projects, whether it's for training purposes or for developing some more advanced system. So I find particularly interesting combination of simulation and techniques of artificial intelligence. For example, for synthetic data generation, as you know, it's very we need loads of data for deep learning algorithms, and especially in surgery, they are very difficult to acquire and to label. Like no one really wants to do it. So with such simulators, we can generate pretty much infinite numbers of automatically labeled data. As well as we have postdocs and PhD students working on using VR simulation as a training environment for surgical robots. All right, thank you very much.
Thank you very much, Przemek. And well, now we are in this part for discussion. First of all, let's try to look for possibilities of collaboration between institutions which were present in this part of the session. I think that at least we had 2 presentations which probably can lead to a kind of collaboration, namely what Eva and Przemek were presenting. It was aiming at the same time, at the same objective, so maybe.
Yes, definitely. I think Eva has much more experience with actually like on the market using such systems. What I presented here is mainly done for research purposes at the moment.
Mm-hmm. Eva, what is your...
Yes, yes, we were working on the software which was designed rather for surgeon physicians who do this pre-operating surgery planning. So it's and this it might be the same area but different kind of end user, I guess, and different kind of data also.
Mm-hmm.
Yes, so my experience is in surgery simulations, especially soft tissues. So I know that there's a lot of pre-operative planning going for rigid, for bones and so on. And I also know that there is like not many people, not many institutions have such well-developed simulations. They can say I have like a complete surgery simulated. Even well-established like surgical robotics research groups like come to me from time to time that, hey, like your work is great and we don't have such a thing. So that's why I basically I'm here at StartUp decided to go this way. That if we have the software which is valuable for well-established top groups in this field, maybe we could do it ourselves here in Krakow.
And I think it's very important for surgeons to practice. So before the surgery, and it's really hard for them to find such simulations. So it's really important what you have.
Yeah, so we can stay in touch, exchange free emails because between what we got and how we could potentially cooperate. Thank you.
Thank you.
Thank you. And I think that the talk about orphan drug, which was something which was probably the only one about drugs from this perspective in these sessions. But I think that it is very important issue in fighting with cancer. So it's I hope that. There will be opportunities for a kind of collaboration with this.
Yes, cancer seems to be a common disease, while there are so many different types of cancer that among rare diseases is the second largest group of disorders. The first are genetic disorders, and cancer is the second biggest group of rare diseases. So I think it may be also valuable for cancer medicinal products developers to assess whether their product can meet the criteria of orphan designation, as it may be helpful for the development and then commercialization of the product.
Yes, thank you. And what Krzysztof has presented here, I think that it also is in the field of interest of Jose, because Jose is interested in a kind of social aspects of health, and his talk was in the previous part of this session. I think that it's something what can be, let's say, a way of finding a common interest. Okay, so in the whole two parts of this health tech sessions devoted to different aspects of cancer as a disease and looking for a way to, let's say, to fight with this disease. We had first of all an approach to modeling, to understanding what is the cancer, how it develops, different stages of this disease. We had also a number of talks about usage of data science and artificial intelligence methods in understanding this disease, in finding symptoms of this disease. And all this, I think that we have addressed in this all these aspects of analyzing of images, analyzing of data. We have also something like talks and talk on what is very important in research about literature reviews. So I think that we have tried to, in this session, we have tried to have a kind of as holistic as possible picture of tumor and fighting with tumor. And I hope that it will enable a collaboration between institutions which were presented here. So, well, Kazimierz, would you like to add something to this session? Or no? Well, well, it's so I think that we hope that also what was arranged at LifeScience Open Space this year, this collaboration platform, will also enable many people to look once again at talks and find a solution for further collaboration, because it was not just for presentation, it was the main objective was to, let's say, to somehow to find a synergy by collaboration.
Oh, okay, now I have a microphone. I can add something. That was very inspiring, and I remind that in previous years, especially when we met, when you used to meet live, we've been giving the award for the best presentations. So I think there are few candidates here for the presentation. I mean, the best presentation in terms of how well can we convince others for collaboration. To collaborate. And in my opinion, we don't have this award this year because it's very difficult to arrange voting online. It would be not equal and technically complex, so we skip that. But if I was to vote, I think Paweł Kunstman presentation was one of the best in terms of the way to present the process and the way to invite for collaboration. So congratulations, Paweł. That was something great. Great job for this conference.
Well, so with this congratulations, we are. I think that we are going to close this session.
Okay. So we'll meet, we close the health tech session at the moment, and we'll meet in half an hour, more or less, at 3 o'clock in the LifeScience startup scene, on the LifeScience startup scene. So stay tuned, take a break, and get back in 20 minutes. Thank you.
In Kraków, a remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city centre. Besides monuments entered on UNESCO Heritage List, Kraków has something else to offer. People. In Kraków every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Kraków. Kraków has become the center for modern services in Europe. Kraków is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Kraków is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Kraków, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Kraków is increasingly associated with excellent cuisine. Its restaurants, offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków. In Kraków, a remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city center. Besides monuments entered on UNESCO Heritage List, Kraków has something else to offer. People. In Kraków every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Kraków. Kraków has become the center for modern services in Europe. Kraków is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Kraków is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Kraków, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Kraków is increasingly associated with excellent cuisine. Its restaurants offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków.
Hello afternoon. This is the afternoon session devoted to brave ones, as I named it today morning, the startup scene. Today in the studio we have guest Karolina Nowak from Agency for Medical Research, but the leader of the session, Combine Angels, the organizations, startup organizations, and the leader of speaker in the name of the Combine Angels, Robert Łukowski, will be with us online. Hello, Robert.
Hello.
Hello.
Good afternoon, everybody.
So without any delay, I will give floor to you because this is your session.
Thank you very much, and congratulations. I have seen some panels before, So very high quality. I hope that we will deliver also something interesting for the auditorium. So right now, as Kazimierz said, we are moving into innovators, and we'll discuss a bit about how innovation can support solving this many problems, many challenges that we have in medicine, in healthcare. So we'll start with a keynote speech from the industry perspective, from AstraZeneca, to understand a bit better the big game. Then we will have a panel discussion with distinguished panelists. I will introduce them later on. And after the panel discussion, we will hear pitches from startups. We'll try to give them a feedback, and the session summary somewhere around 6 p.m. So be prepared for very intensive 2.5 hours of high quality content. Thank you for having me here, and I hope that will be valuable time spent.
Thank you, Robert, and I think we may start. I mean, you can start a presentation of your guests.
Yes, so first of all, we'll start with the presentation by Ms. Karolina Tkaczuk from AstraZeneca, and I think we will use some slides. So Karolina, floor is yours.
Thank you very much, Robert. It's my pleasure to be here today and participate in this session. And my apologies for the language of the slides, but we had a small misunderstanding. Nonetheless, I'll try to speak English so everybody can understand me. So today I would like to present, as Robert said, industry perspective on innovation and collaboration with startups, and how the big pharma sees that, and how the big pharma would like to be involved in this process. So obviously, when you want to talk to the industry, it's good to know the industry, a specific company that you want to talk to, and know what the branch that you're talking to is working with. As you can see, AstraZeneca is a big company, and we have a number of so-called sites. The one in Polo, Warsaw site, is composed of 2 branches, the Warsaw branch and the Kraków branch, as you can see. And we employ a lot of different people, a lot of different specialties. Apart from being a clinical center, so we do a lot of clinical trials, we also do R&D. And as you can see, the other sides, they deal with very different things as well. So it's good to understand that the 3,000 employees that we have in Poland, they're half-half when it comes to employees doing research and development, and also doing other things like finance, IT, sales, and many other things. So there's a room for many improvements and many other innovations that we can actually employ in the company. And the way we engage with a number of other companies or academia or startups is multifold. So first of all, of course, we employ people from different backgrounds, as I mentioned, but we also do clinical trials, and this way we generate a lot of data. So we are one of the data sharing centers as well. Of course, these are the data that are anonymized and come from our research. So these are the data that are destined to be only used for the research purposes. So if you work on a certain problem that requires specific types of data, you can apply to AstraZeneca and many other big pharmas and request the data for a specific project. And we also conduct a lot of open innovation activities, namely a Catalyst and Co-Solve that I will describe in a few words in just a second. And we like to share knowledge. There's a lot of knowledge generated by us internally, and we like to share that, but we also like to exchange knowledge with other partners. So one of those projects I mentioned is Exchange Mentoring Program. And this is a program that's not only focused on R&D, but also on business. And we
join together the startups, the industry, and experts from within AstraZeneca and help young inventors and young entrepreneurs to learn from us, from our experts. So you can actually submit the question. We'll try to connect you with the proper person within the company, and you can ask questions and be mentored in this way. So you can learn a lot about what a big company requires, how to approach the company, and how to do specific things that you might be interested in. And in particular, in AstraZeneca, we have a couple of hubs listed here on the bottom of the slides that can help you. So this could be Warsaw site, this could be Gothenburg, Cambridge, or any of the sites in the US. So this is one of the examples of how Warsaw site supported other pharma company. That was not a startup, but the pharma company that came to us with the question how to create a green fleet. Because AstraZeneca Poland was awarded 3 times in a row with the prize for the most eco-friendly fleet. So one of our competitors came to us and asked us how to do it, how to create the fleet that will be very environmentally friendly. But you can also come to us with other questions and ask us a number of other questions as well. Another activity that we introduced in the company is globally is a co-solve program. This is sort of a crowdsourcing program that helps us collaborate with innovators and other scientists from both industry and academia and solve important questions. So we publish this challenges twice a year, but the sprints are open all year long and are being added every month or every couple months. And these are usually very small challenges just in nature, but the key is to create the solution that will be scalable. And of course, you can find a lot of information about the program down below when you click the link. And we have 2 challenges that are currently open. So if there's anyone interested in one of them, feel free to submit the solution by the end of the year. So one of them is to recycle or create the filter tips that will not require the little filter, because when you use the plastic filter, plastic tip with a filter, you cannot really recycle them or wash them. So they're just one-time used. And that generates a lot of rubbish all over the research units. So we would like to create the solution that would be reusable. So that's one of the challenges. And the other one is devoted to recycling of organic solvents. So we would like to get, and we have particle solvents listed on the website as well. And this is the challenge that's extremely important for any lab activities, because we use a lot of solvents in the laboratories, but then most of them cannot be reused or used for other processes without compromising the experiment. So as you can see, these are very strictly scientific or technological, in a sense, challenges. We also have a so-called a Catalyst network. This is a network of more than 20 innovation centers and are devoted to create solutions for pending problems that are tackling the healthcare system. And we engage also, apart from the experts from all over the world, also patient organization and patients themselves. So this is one of the ways we would like to solve health-related problems. Apart from the challenges, we also have a number of tools that startups or young researchers or innovators can use. These are a lot of the solutions that were worked out using crowdsourcing or our own resources, and that we decided to open up to the world so you can use them and try to verify your solutions without actually putting a lot of money into it. So you have a ready-to-use solutions. So if you're interested, please feel free to check that out when you Google Open Innovation AstraZeneca. And that's about it. But I don't know, I cannot. Oh, yes. Thank you very much for your attention. And if there are any questions, I hope I have 1 or 2 minutes to take them right now. Thank you.
Robert?
Yes, thank you very much for the presentation. The question is if we can have the audience asking questions, maybe in chat.
No, it's not possible in this way. You may ask questions, or I may.
Okay, I think it's a great to understand this industry perspective, and for many startups, it's a huge opportunity working with big organization. But on the other hand, I was also working for these big giants. It's very important to know the best pathway to do it. So I think it's great that AstraZeneca has all these global units in Poland, but also that has Karolina, who could be the best person to guide you through these big, complicated organizations with so many opportunities. And good to have you here in Poland, Karolina.
Thank you very much. And I would like to encourage everyone to actually ask questions for the mentoring program, because this is, I think, the best way to get to the global organization and learn how it works, what sort of problems the organization might have, or how you should approach your own problems when it comes to the connections between the industry and your own company or invention, so to speak.
Yes. Thank you very much. Kazimierz, would you like to ask something, or we move to the next point?
No, personally for me, no, because I know the offer Karolina was presenting. We know each other from previous job of Karolina, so I'm okay. We may move.
Okay, so I think the good connector between the industry and the government and the healthcare system could be Agency for Medical Research, and in particular Warsaw Healthcare Innovation Hub. So let me welcome Karolina Nowak, the head of Innovation Department and also the leader of Warsaw Healthcare Innovation Hub. And as far as I know, AstraZeneca is also one of the founding members of the hub. So Karolina, maybe you will introduce yourself and say a few words about what you do and what's in it interesting for startups and innovators.
Hello, thank you for the invitation. I'm really glad to be here with you. And yes, I'm responsible for Warsaw Health Innovation Hub, a project organized by Medical Research Agency, and we create an ecosystem for joining the business partners, pharma companies, biotech companies, tech companies, to create together the ecosystem. The pharmaceutical companies do the joint project with us, and for better we share the knowledge, we share the experience, and we have already 29 business partners, and we have some KPIs for next year, and for next year we are focused for startups. So new startups will be warm welcome in the hub. But we want to use the experience of big companies, of our partners, to, as I mentioned at the beginning, to create the whole ecosystem and to connect the business and the public side. So how can business also participate in project which will be used by the public institution, as Ministry of Health, as and we have in Hub we have seven main public institution, and we just want to create the whole ecosystem for our patients. And for the whole health sector in Poland.
Thank you very much. The next person I would like to introduce is Rafał Szmuc. Rafał is experienced in healthcare management, also in banking finance, but today is leading the startup that is doing very important, I would say, fundamental thing in healthcare data. So, Rafał, if you could tell a few words about yourself and about your startup.
Thank you. Thanks, Robert. Thank you for inviting me and a startup at early stage as a partner in this important and interesting discussion. I've been fell in love with medicine and healthcare a couple of years ago, joining the hospital business, managing the chain of hospitals. But then before, I spent a couple of long years in finance industry, in banking, which learned me that not only finance is about numbers and data that we can use day to day. Also in healthcare, especially I think nowadays when we tackle the digital healthcare and digital revolution, the data and the information flow is extremely important. And that's the clean note is about. What we are doing is maybe for the other audience, but now we are trying to exploit our experience from different parts of the businesses. Mike from banking and management, the other colleagues from healthcare, bioinformatics, and of course from medicine, to bring the dark data into the light. So that's our current stage. Thank you, Robert.
Thank you very much. Then I think it's very important to have doctor, medical professionals perspective, and let me welcome Artur Drobiak from Naczelna Izba Lekarska. It's how is it in English? Artur, could you take from this?
It's National Chamber for Physicians and Dentists.
Okay, thank you very much. So the floor is yours. If you could say a bit about yourself and your institution, and I know you have some also very interesting programs for healthcare innovators from doctor perspective, of course.
So the Polish National Chamber for Physicians and Dentists is the organization which is, according to the law, all physicians and all dentists that have their jobs in Poland need to be part of them. So there are 200,000 doctors who are included in our chamber. However, Robert Ługowski asked me to be here today because this year we start a new program that the name of it is NIL-IN, so NIL Innovation Network. We'd like to show doctors the innovation in medicine, in healthcare systems, about data space, about the new solutions, new devices, and we need to check that all new stuff, if it's safe for patients and for doctors. We are starting a program. We'd like to make the educational program after that. After 1 year, we'd like to educate, I don't know, maybe even 1,000 doctors who are involved in innovation in medicine.
That's great. I also know the program and strongly support because, of course, at the end of the day, the adoption of the innovation is the key, and we are going to talk about this during the panel, I hope. We are still waiting for Katarzyna Kolasa. I think she's not with us yet. But okay, let's move to the discussion. Today we have the whole day about how technology can support solving the problems in medicine, in cancer. There were many discussions about that. So I would like to start with the first question for each of you to elaborate what is your perspective? Where do you think we have the biggest problems in medicine, and especially the ones that can be solved by innovation, by new technology? And what's your vision of that? What's your experience? Please just share your thoughts. Who would like to start? Maybe ladies first.
Maybe I will start. I wouldn't call it problems, but I would call it challenges. So, in my opinion, one of the main challenge is to build a good, transparent collaboration between different stakeholders. It's we are thinking that it's easy, but it's very complex because all of the stakeholders has different aims, and we have to learn how to speak the same language, how to do things together, and to implement the win-win situation. And so I think this is one of the challenge. And it's not only the national on the national level, but it's also in the regional level, in the Central Eastern Europe challenge. The second challenge is to building the ecosystem with strong competences, with specialists, and so we have to stop brain drain strategy. So we have to build the ecosystem to keep the best in Poland, and to create the whole collaboration, and to build also the innovation and new in the field of diagnostic, so in the field of medical devices, in the field of new medical products. So it's also the challenge, and also one of the challenge is to engage the public sector. How to do it? How to create the transparency, so everyone want to be involved, and everyone want to be engaged in the whole process, because we from the concept to the market authorization there is a long way, and we have to learn how to do it, to join all the elements to create whole process. And in this also we need the quality of R&D, the quality of the project, the quality of legislation. So it's important to join all the elements and create the transparent ecosystem within the healthcare in Poland. Yes.
Okay, thank you very much. It's a very broad view.
May I ask questions, Robert?
Yes, I have one remark, which is probably one of the most difficult decisions that the government has to make. It's the balance between the safety, protecting the patients, the whole system, and on the other hand, some freedom to make the experiments, to make innovation, to do something extraordinary, sometimes crazy startup ideas. So maybe we can also elaborate about this a bit later.
Robert, can I ask questions as well?
Of course.
Yeah, because we are talking a lot about collaboration, but the Poles are actually known as very hard in that matter. How can you manage this? Do you have an idea how to foster collaboration?
Yes.
If your hub is maybe about that?
We are already conducted 5 project with our business partners for 3.5 million of Polish zlotych, and we already started. So I think the Warsaw Health Innovation Hub will grow in strength. So I'm really happy, and I see, because worldwide public-private partnership is one of the key elements to building the strong healthcare system, and I am sure that we can build also a strong partnership in Poland.
Yeah, but is it possible to trigger collaboration before the money is put on the table?
Yes. Yes,
okay.
Yes, because Warsaw Health Innovation Hub is an example that medical research agency do not participate financially in the project. So the 100% of the money comes from a business side. Mm-hmm. So we do not participate financially in the projects.
Thank you.
Yes.
So if I can comment on that, what you just said, both Karolina and Robert, as one of the financial partners that sponsor the Warsaw Health Innovation Hub projects, I think that's extremely important to test crazy ideas, as you said, because sometimes this is where the actual disruptive innovation comes from. And I think it's worth mentioning that there is a number of projects already been conducted by Warsaw Health Innovation Hub that could be treated as a test bed for new technologies that could have potential translation into clinics in the future. But what's extremely important is also the dialogue, as we mentioned before, between all the parties involved, not excluding the doctors, first of all, and obviously the legislators and people who create technologies, create solutions. And I mean by that all the scientists and the owners or co-founders of startups as well. So this is like one of the very, very important factors. We cannot create innovations that could be translated into hospitals if we do not include doctors who will use that technology.
Yes, fully agree. Thank you very much for these remarks. And there's one more important thing I believe about Warsaw Healthcare Innovation Hub. The most rare disease, the most rare resource that we have, but sometimes we don't think about it, we don't count it in Excel, but from startup perspective, the time is very important metrics. Mm-hmm. So the faster we can go to the market and work with different stakeholders, also educate them and come with the innovation to the hospital, the faster the better. So I think it's also the big role of initiatives like Warsaw Healthcare Innovation Hub, that if we do it together, then the innovation can happen just faster and more efficient way. But if we are right now discussing about the adoption and education, let me introduce Katarzyna Kolasa. Kasiu, if you could say a few words about you and what you're doing, and in the same row also tell a bit more about where do you think is the biggest challenge that can be solved by innovation and startups.
Okay. Thank you very much. Thank you very much for inviting me. It's a great pleasure to join, at least for a short while. In my busy schedule today, I won't be able to stay for the full time of the panel. But nevertheless, Katarzyna Kolasa, I'm representing Kosmiński University here. At Kosmiński, I'm leading Digital Health Start Me Up program, which is designed for the startups working in the field of the healthcare, and dedicated their efforts towards digital solutions mainly. And to your question, Robert, I think that I have more than 25 years of experience of pharma and medtech, and working mainly in terms of the value generation, so price and reimbursement, market access, Apart from Kozminski, I'm heading health economics outcome research team at Paraxel, which is the consulting company responsible for both clinical research and regulatory/reimbursement. And what I see is where the source of innovation comes from is always on the bridge of different science. So especially when the digital transformation has taught us how data is important as a fuel for any new solution. So I think that to embrace these opportunities, we need to develop the skills for us to be able to join different disciplines together. So it's everything from machine learning and more future thinking, feature engineering, I would say, slash neonatology, slash health economics, and more importantly, value generation. Because I think we sometimes miss discussing about the new innovative thoughts from the standpoint of the value for end user. And first of all, we need to understand who is the end user. In the healthcare sector, the end user is obviously a patient, but before we are able to present it to the patient, we need to meet multiple hurdles from regulatory and for the pricing reimbursement standpoint. So this is like a safeguards before any innovation can enter the ecosystem of the patient for the good and bad. For the good meaning from the standpoint of safety, for the bad meaning the time elapsed that is required. So that's our mission, and I'm happy that Robert and others joined Mina's mission to develop this value generation mindset for digital health startups. So we are welcoming you all on digital health short course we are starting in January. But overall, the short answer to your question is interdisciplinary mindset that helps join different scientific fields together and bring the value determinants for each innovation. The innovation is not worth, or it's not valued enough if it does not present it in the right way to the right people at the right time.
Thank you very much for that. Any comments from the colleagues?
Yes, because if I may, many times here have been called the startups as the matter of the discussion. In fact, are the digital revolution drivers. My perspective, say, is very pragmatic and practical. That's what we need from the whole environment to support the digital transformation in healthcare. It's really simple in our understanding, in the startup understanding. This adoption, which been discussed here, which is related actually to the access to the doctors, institutions, hospitals, or clinics, where the tools developed by startups are used. So any solution, any institution helping in this access is more than welcome, where the Warsaw Healthcare Innovation Hub is one of them, and AstraZeneca probably too. The other stuff is, of course, the pace, because the innovations are driven by the quick check, and the quick development, and the adoption or no. And then we have to, let's say, go to the next innovation. So that's very practical perspective, which means that the simple procedures, the simple pathways to engage the startup with the big institutions or big corporations, which are like Astra or other big pharma, or Warsaw Healthcare Innovation Hub, or medical research agency. They are big institutions. They have to be agile to, let's say, attract more startups and to quickly check them whether the innovation is implementable. That's very simple, and a lot of good stuff been done here, but still, I would say that the real life is still challenging. Yeah, Katarzyna?
If I may quickly jump on it, I will, because my time is limited here, so I will, and then I will stop. So sorry guys for that. But one thing I want to say, because I had opportunity to visit some startups in Austin, Texas, like 2 weeks ago, I believe. And I was absolutely astonished by the ecosystem that drives the startups initiative. I mean, I don't know if you are aware of the fact that Texas became a new spot after Silicon Valley. This is called Silicon Hills.
Yeah.
And that's really the reason for this a new environment is driven not by the startups themselves, because they are moving there, right? So it's driven by the tax system, it's driven by the atmosphere in the city. But I'm sorry, but Warsaw is very far away to even think about it, although it's growing in positive direction. But I mean, what I try to say is that this I feel that being very nationalistic when I'm outside of Poland, because I see how the environment being prepared for those startups actually brings them to this place. So we should not think, in my personal opinion, as our Warsaw hub and Warsaw as a startup for Polish entrepreneurs. We should think about our Central Eastern European focus mainly, and more importantly, to think how we can, with those different nice mindset around this panel or overall, develop the ecosystem that will attract those entrepreneurs and attract creative thinking as well. So something of the scale of what Estonia does very nicely, with a lot of accelerators being brought around startups to help them to test their ideas. So it's still a little bit missing. This is potentially one of the driver for my short course. Again, welcome in January. But I think that that's something that I would try to see as a new endeavor for Warsaw.
Thank you very much for that international perspective, and for sure we have something that can be learned from the others, but also I think it's very important to be connected in this startup world, because it's very difficult to do some standalone innovation or research, whatever it's these days. It's in most of the cases, the success comes from the collaboration, not just a single great idea and one person doing it. Okay, but once we are at the international level, maybe I will ask Karolina, because in AstraZeneca, for sure you act on a global level, so you see a lot. So where are the things that you believe are hotspots in healthcare? What also we can learn from the other geographies and implement in Poland? Maybe some experience, something that you think is valuable.
So I like to think about solutions rather than problems, to be perfectly honest. So one of the things we've seen in many countries is simplification. So what's happening right now, we're on this peak of having a lot of fantastic tools on the market created for healthcare and for medical research that are available, and we try to use a lot of them at the same time, which puts a lot of, this probably could be commented on by Arthur later on, a huge burden on doctors because they have to use more and more tools every day. So instead of helping simplify their work, we sort of put some more stress on it. And this is what we hear from our colleagues from other countries, that we have to be smart about how we implement new tools, because putting more and more will not help us, because we'll be putting our time in other areas, learning how to use new tools instead of using the time to actually help our patients. So on one hand, we created tools to gain more time, but on the other hand, we put a lot of effort and time to learn how to operate them. Artur, do you have any thoughts about that?
Yeah, I can comment on that because it's very
thank
difficult
you
to
for the question.
avoid.
Sorry.
Sorry, I just wanted to comment that this is very difficult to avoid the kind of exponential growth of the offers of the solutions on the market. So I think the way to overcome this problem is actually to find a way to harness this growth, because we have to foster. From the other point of view, we push the growth, and we are heavily investing into to have new solutions. And from the other point, there is that's the true. There is a problem on the other side of the acquisition of this. So we have to create new types of innovations which will allow us do both. Have a new solutions because they are very quickly. They are growing very quickly, and they are aging very quickly, and also they harness how to in which way most efficiently make them put them into the use in a permanent basis, a kind of sustainable way. That's the challenge.
Yes, definitely. Arthur, if you could please comment from your side. You've been asked.
Yes, sure. As a clinician, I can only agree with Karolina Tkachuk, who said about it that we have really limited time for our patients in Polish system, and checking and trying to use so many devices and so many new tools in our practice is almost impossible. That's why some people, I guess it should be a Ministry of Health, who organize the projects, including doctors, who will check the innovation that are sent by the Ministry of Health. And Ministry is thinking about it. I'm not the representative of Ministry of Health, of course, from Polish Chamber of Doctors and Physicians. And the Ministry of Health asked us, I mean, the Chamber, to create such group of people who are very keen on innovations, who are keen on devices, on checking, on testing. We have already 100 doctors who like to check the devices, to like to check the new innovation tools. And Ministry of Health asked us to that they will give us the solutions, and our group of doctors will check it. It's impossible for singular physician to check it during his job in Polish hospital healthcare, hospital or ambulatory services, it doesn't matter. Maybe, I guess, we should create new facilities in the medical university systems that include doctors, that include nurses, that include other medical assistants. That should be the place where the startups or other innovation hubs gives their ideas and gives their products to be tested. Finding it just on the market in Poland, it would be very difficult, in my opinion.
Yes, in financial.
Can I comment, Robert? Can I comment?
Yes, sorry, I will just finish. So in financial institution is more or less similar problem that on one hand the regulators have to give some protection. On the other hand, innovations are very welcomed. So they created a kind of sandbox, and with this sandbox, some innovations, some startup solutions can be tested. So I assume that Arthur, you are talking about the concept of having sandbox in healthcare, kind of. Yeah. Okay, Kazimierz, of course.
Yeah, I was thinking a different way, maybe not much different, but similar. I mean, today doctors are not very much involved in the testing drugs. There is a system of clinical trials which provide to the market the drugs, and then doctor just chooses from the list the drugs which operate the best in the given position. So they have to know only how drug works, what is the active side of the drug, and they do prescriptions for patients. I think the same thing will have to be applied to any types of applications, and maybe maybe other devices. I mean, doctors do not have to know everything about device. They just have to know how the device works to prescribe the device or prescribe the application. That's enough to have the smart system. So in that case, this may solve some of the problems of engagement in testing, etc. The system similar to clinical trials in drugs, of course.
Yes. So maybe a question to Rafał. Could you comment about this proposal?
Yeah, that's what actually what I heard just before. It's something about what we are dreaming in startups. So the sandbox in each of the country or the big institutions, letting us let's say test our solutions in the environment close to real world will be more than good. Of course, the background is very simple. The adoption, the real life where the thousands of doctors are starting to use the tool, the application is more complex. Sometimes it goes to the reimbursement schemes. Sometimes it goes to the simplicity of the implementation or simplicity of the application itself, despite the big problems they are solving. So I would get back shortly to what Katarzyna Kolasa said, that this is about really kind of mindset. So if we're gonna feel that by creating this sandboxes by Ministry of Health or big corporations like and the people cooperating with startups will approach the cooperation with a different mindset, that the quick check, the agility, the let's say awareness of the risk that it may fail, the idea may fail, that we have to check it because it's disruptive. They will be there, this different mindset. It will boost the startup environment, really. This is what we are waiting for. And actually, this is what Katarzyna has been describing regarding the new Silicon Hills in Texas. That's the kind of mindset we have to look for among the people we are cooperating with. Yeah.
Thank you very much. Once you mentioned Katarzyna Kolasa, maybe let's move to the next topic that we plan to discuss. It's, we know where the future is. We know where we would like to be. We would like to have more innovations, have more efficient healthcare, but how to get there? What are the main challenges, barriers, or what would you advise to startups in order to make it faster and better? Maybe something from your perspective, Katarzyna.
The short answer is join our course, then you will be omnicorn in 1 year from now. No, just don't quote me on that, but hopefully we can help you. And the reason I'm saying so, because it's all the tool are in the toolbox. What really is missing is the connectivity of all those different opportunities that exist. And I'm talking about specifically about the opportunities for reimbursement of digital solution outside of Poland. And so it's already happening. I know it's a slow pace when it comes to Germany, but there are multiple countries from South America and the UK. We are going to have in our course the representative from Finland even. So there are multiple sources for financing of implementation of digital solutions. So I like to talk about the venture capital, which being the driver of the preparation of the digital solution to fruitful state. Let me put this way. But what really matters is to being able to implement it in the clinical practice. That's the only way for the success. And I think to answer your question, so what my advice would be is really to think long term, not the short term. And then I can come back to what has been said earlier about the clinical trials. I'm a little bit scared myself that we will go into the pathway of the pharmaceuticals and even medical devices for the digital solution, which potentially is not the right way from two standpoints. One being the rigorousness. I've been working with the pharma for so many years, so I have seen so many compounds failing because of the regulatory barriers. So I think that we should not push for too much of rigorousness as on the scale of pharmaceuticals of this reason of being too prudent potentially, but in the terms of the evidence generation, but on the same time increase the barriers for understanding of the value of different solutions from the efficiency standpoint, what Robert said. I mean, for me, digital revolution is not only about the clinical gain, it's sometimes about the gain for the healthcare professionals, time gain, efficiency gain for the healthcare system. We don't have any tools yet how to assess that. So that's why I think that there are more opportunities when we start think about the healthcare from holistic standpoint and from the patient journey standpoint. There are a lot of pharma that works on a digital solution, not for the primary indication for the products, but for secondary indication, like cognitive dysfunction across multiple sclerosis. There are some companies that develop apps for their patient that they treat for the indication A, helping them with cope with the indication B. It's holistic journey for the patient. That's another important element. But to bring all those puzzles together, we need to define those skill sets. And I said, in my opinion, we have all the tools in the toolbox. Now it's just to make sure that we understand how to use them.
So the question is: the toolbox called Digital Health Start Me Up course for innovators, or is also open for doctors, for industry? Who are you looking for?
Yes, thank you. So if I may ask Artur and Carolina to spread the news, because this is what we're missing. Now we have the startups there, but my aspiration, and I cannot still get to the level of satisfaction there, is just to invite the healthcare professionals as well, invite my colleagues from pharmaceutical companies, because digital solution comes its success when we meet different professions. That's why what I said about the interdisciplinariness. So I hope that we will be able to develop the ecosystem of digital health enthusiasts and leaders to drive the change. So I'm talking with the Ministry of Health, I'm talking with the Polish Parliament now about the legislators. I hope we will come there. Thank you.
The legislators, that would be great. Maybe some colleagues would like to comment on what was said, okay, because I understand that you, Katarzyna, are leading us in a few minutes.
Okay, so related to what Katarzyna said, I would say that the education is a key role to implement the innovation within the digital health. How important is to educate future doctors, to educate also pharmacists, because they need to have the basic and profound knowledge about the new solution, about the and also not only the solution but also the regulation which are behind of the of this. And I said it's important to educate people and all professionalists, not only the doctors, but also the people from the public institution. How important is to create the innovation within the digital sector.
Robert, may I comment one thing?
Yes, of course. Yes, of course.
I think we missed one thing, very important one. Medicine is conservative. Doctors who are studying has pharmacology. Pharmacology is one of the most difficult subjects during the medical studies. It usually takes 1.5 years, and we are teaching and students are learning about drugs and about methods for almost whole studies. Then they have clinics, and in clinics we used how to treat this, how to treat that. It's impossible if you think that doctors would know the innovation tools and innovation devices just like that, like the new drugs. That's why, because new drugs are limited by the clinical trials, are limited by the regulations. Now we have innovations, I don't know, 100, 1,000 more every year than drugs, yes? So, and doctors still are not teaching, doctors are not educated about the new solutions. That is the biggest problem. And I think that even good ideas, even good devices, even good tools, really good, that they are game changers in some things. They do not survive the gap between the implementation and adaptation to the market and to the doctors and then to the patients. That's the most difficult thing, because usually money go to the startups at the beginning when they are developing the product, then they are implementing the product. However, from the implementation to the really usefulness on the market, it's really a long gap. Sometimes it's half a year, sometimes it's 2 years, and many companies would not survive that time.
That's for sure. Rafał, would you like to comment on what was said? But maybe also if we talk about digital health, it's probably also about the data. Is it accessible? Is it easy to get one, to make some, I don't know, AI algorithm learning? Could you elaborate a bit more about that?
Yes, of course, because the education and the data, the real world data, are very close one to another. What Carolina and Artur said is very close to my heart, because I spent some years at the university long years ago. So I feel the importance of the education. On the other hand, focusing on in the keynote on the real world data and the capture and the whole process, how to get there, the real world data, we learned that there is kind of paradox among the physicians. They really understand very well the importance of the real world data. They know that getting the data, they will build new therapies, new drugs. They will make the therapy for one particular patient better, etc., etc. On the other hand, at the education stage, when they are learning the medicine, the time spent on, let's say, educating them, how important is the information flow between the different parties of the medical market, in fact, is equal to zero. Because it's not about, learning the keynote or Flatiron or other tools, the concrete tools. It's about learning them how to exploit the potential in data, which is stored in zettabytes in the world. So I think the education is one of the most critical stage for everybody willing to boost the digital transformation, because the data are the new blood of the medicine, I think. And we have to force the education of the doctors to understand them, to let them understand better how to use this data in day-to-day practice, not the tool itself, because they will probably face different situations, they will use different tools. But the key is how to exploit the data when they are available. So that's the point, I think. That's the kind of challenge of the current education. And I think it may change really and shift the whole medicine towards the really digital era. So this simple focus on education.
Okay, how about making data available for innovators to create some, new products like this machine learning or artificial intelligence algorithms? Do you think it's a barrier for the development of new products, new innovations?
Well, it's at least challenging, because you know the standard the view on the real world data. We are producing zettabytes of data, but only 10 or 15 or 20, depends on the source, percent of this is available in a structured format. So it means that the smartness of our new AIs, new machine learning algorithms, are in 20% smart. The rest is remains really unknown. It's like, that we are teaching the 3 years old kid instead of 25 years student, super smart student, because we have no data in structured format. So that's one of the most challenging technically. That's one of the most challenging part of the market. But of course, it's going better and better. It takes too long, probably. But on the other hand, we still need the people understanding that they may, let's say, build a new therapy analyzing more data. So really, it's going to better with the accessibility of the structured data, but there is still huge work to do.
Thank you very much for that. I'm also thinking about the legal and mental barrier. We have this GDPR. We don't have a clear rules how the data can be used. I mean, the secondary use of data, and of course, being at the position of a director of hospital, it's really difficult to take decision what data can and what data shouldn't be given, especially to the young agile organizations like startups. So maybe Karolina Nowak, I know that you plan to have some workshops about this and also about this new European Data Health Space regulations. So maybe you could comment. There were many sessions, many discussions about these great developments in AI, but where are we with giving access to data to startups in Poland today, and what is the future?
Okay, thank you, Robert, for the question. Yes, we are planning. Actually, we organized the workshop on the 24th of this month for our partners, but we also invited public institutions as Centrum Zdrowie, as National Health Funds, and representatives of Ministry of Health, and representative of Office for Registration of the Medical Products, also the Agency for Tarification. So we invited all the public partners and all the private partners. The first meeting will be about the sharing the knowledge. So what we have on the table, we have to, and then after that, we will be exchanging the ideas how to do it, because yes, the managing data is a hot topic. But we have to be aware of also of the responsibility, because it's new, and we need some institution to be responsible for the whole process. So the organization should be responsible for the management, for the implementation, and so within the Warsaw Health Innovation Hub, we are starting the dialogue, and we are almost sure that this dialogue, this conversation will bring the new solutions, because like you mentioned, the legislation should be implemented till the end of 2026, so we do not have much time. And because we were talking about the education, so related to our previous topic, I had a chance to talk with specialists responsible for implementation of DIGA, and they shared that the weakest point in the whole process was the education of medical doctors. So I would say that one of the most important, crucial elements is the education of medical professionals related to our previous topic.
Thank you very much for that. And then it comes to Artur, because it has been said a number of times that the adoption and the final user, which is usually a doctor or a nurse or some medical professionals, is the key. What's your perception? What could help to facilitate, to make this cooperation between startups and doctors more efficient?
It's a very difficult process. I cannot tell you now the gold standard how to make it. That's why we start our program in Polish National Chamber, because we'd like to find doctors who are really interested in innovation, and because mostly doctors do not have time for anything. They do not have time for their families. They don't have time for education themselves, even in their own specializations. That's why we are looking for, let's say, I don't know, 500 doctors who are really interested in innovations, who can spend their time with talking to the new startups, with new projects, new devices, new tools, new application. I guess creation of such group of people, of medical specialists in every country, it's the key to get to the doctors, and it should be the process. That's the beginning. The next one, the next phase is that people from that project go to the, for example, national societies of cardiologists or gynecologists of etc. any specialization, go with the innovation that they tested. And gives the lecture about innovations in cardiology, innovations in gynecology, innovations in anesthesiology, etc., etc. That's how we can educate them, because during the medical studies, changing the whole program of medical studies, it would take years. You don't have that time. So the best solution to get to the doctors and other medical professionals is through the societies they are already in, like as I told you, like scientific societies or chambers. It's not only doctors, nurses and midwives has also its own chamber. Yeah, physiotherapists also have its own chamber. That's how we should create the line between the startup, between the manufacturers or data analyzing systems that comes to the medical professionals. That way. Other way, it would be still a really strong gap, and we do not have time to be spent, to filling that gap just with the education on studies, because it won't work.
Yes, it sounds like really very good and attractive program. So the only question I can ask is when startups could raise your hand and come to you and work with this group of 500 early adopters.
I guess it would be the first semester of next year. I guess first quarter of next year. As I told you, we had to manage with Ministry of Health about our project altogether, and after that we can ask startups to be involved in that process.
It sounds very good. Thank you very much. I think that Karina Tkachuk could bring some more light on the subject. So what do you think could be some practical hints or things that could be done in order to make the best out of the innovation in Poland?
So I'm also pro-educational, as we already said, and I think this is one of the niches that clusters and hubs could actually facilitate, the connection between the startups and the medical early adopters. And if I could give like 3 basic advices for the startups would be, if you create something new, please do involve the target audience, whoever that is, if it's pharma or doctors or whoever your target is, your recipient of your technology is. Involve them as early as possible. Test the solution as early as possible. So do not wait until you have a ready product, because it might be a huge miss when it comes to the market. So go and ask questions if this is the technology that a company or big pharma or company, other sort of company or doctor would use. And if not, ask for feedback. And definitely, if you go to big companies, be prepared, learn the company, create a case study that the company could actually relate to, because this is the easiest. People on all ends of the who receive the technology are usually very, very busy, as Arda said, as Rafa and everybody else said before. So be prepared, prepare the use case that would be relevant for your audience, and then pitch the solution.
Okay, that's for sure. But how sometimes for startups it's very difficult to work with big organizations because they are big, because a lot of resources from startups should be involved. And sometimes I call it hunting for mammoth, for elephant, for something big, and of course, if it takes a number of months, sometimes years, maybe sometimes is better to hunt for rabbits. And how would you advise here? How to make this cooperation between startups and big companies the most efficient, or how to balance, in order not to be in a position that, you know, after 2 years, if the project is not successful, we don't have nothing. Yeah, maybe.
I agree. Hunt for rabbits, not the mammoth. That's for sure. And as I mentioned, we have, like any other company, we have number of programs that could help you. So ask questions, try to get to the person who's responsible for managing innovation. AstraZeneca has a lot of those, as I mentioned during my presentation. You can submit your questions or try to connect to someone who has a network of experts. So in our case, that could be a mentoring program, that could be a BioVenture hub that is in Sweden, that also listens. They talk to you. They may not be interested in the solution per se, but they actually give you advice. So try to get to the right person. Look for it. It's a hard job. I know. I was on a startup and for many years as well, and I was the one hunting for those people. But if you find them, your chances for actually getting the useful advice, useful feedback are bigger and bigger before you invest a lot of money in a solution and get super frustrated.
Okay, thank you. From investor point of view, sometimes we advise startups to use Pareto rule. So 80% rabbits, 20% elephants, and you know, you have to somehow allocate resources and also consider the time frame. Yeah, so this is quite common approach. Okay, I think that we are just about to finish. Are there any questions, any final remarks, and summary maybe, Kazimierz, that we would like to close the session with? No questions, no
just
remarks.
a moment, I was waiting for a mic. If I wanted to comment, actually, I would say we didn't finish. We opened the floor for the further discussion. And thanks for bringing these guests to our meeting, because this is LifeScience Open Space to open this type of collaboration opportunities. And I think we will follow after that session. I'll try to summarize this in writing after our session, because I have several thoughts about what we have discussed, what I heard here from you. So thank you very much, Robert, and I think you may continue with the next part of the program.
Thank you very much. I have one very practical takeaway. If you're going to summarize, maybe we should consider writing some letter to politicians, decision makers about this healthcare sandbox, because it was mentioned and looks like a lot of challenges or problems, how startups call it, could be solved, in particular in this adoption and barriers area. So why not to start this kind of dialogue, I mean, publicly, to say that the outcome of our full day discussion today with different stakeholders could be postulate to think about this kind of sandbox that was done in KNF for financial institutions, financial startups.
Yes, I agree, but I understood that this idea has already started. The discussion about has already started in the Ministry of Health, and we may only support this idea, not to propose.
I haven't participated in any meeting in that regard. There was, from time to time, this topic is being discussed, but I'm not sure. Maybe Karolina knows if there is some project behind this.
That's for your take.
I don't have this kind of information.
Okay, so we'll try to explore. Thank you for pointing out this idea. This is something we can directly say. Definitely, I agree, and we'll follow that.
Thank you very much. Thank you also very much for all the persons who participated in a discussion, for your valuable time, knowledge, and all the hints. Right now, we move to startup presentations, and of course, your participation is also important here to give them the feedback and maybe some practical advice. So the first startup that already you know a bit about is the Keynote, will be presented by Rafał. So we have this framework that we have 10 minutes presentation from the startup, then 5 minutes questions, remarks from the panelists, and then we move to the next one. At the end, we can also have some summary, like 10-15 minutes after all the presentations. So Rafał, the floor is yours. If you could share the presentation, check if you can do it, and 10 minutes for the Keynote right now.
Yes, just sharing the screen. Can you see it?
Not yet?
Yeah.
Yes, we can see it right now.
Perfect. Thank you. Again, I'm really glad to be here and present to you the Keynote startup. Keynote is about data. We are tackling one of the most probably hottest topic in our digital world. That's what I already mentioned during our discussion. That's of course just a few numbers showing us where we are in terms of the data production. ZB is a zettabyte. One zettabyte is 1 billion of 1 terabyte disks. So just imagine the amount of the data which been stored in the digital universe, and 30% of this is related to healthcare, but 90%, according to the different sources, 90% of this out of healthcare remains dark, so-called dark data, so unstructured, unavailable for machine learning and other activities. So that's the hierarchy of the data science, which is the foundation for digital healthcare. And once we discuss the already touched the topic, the problem, is just imagine the smartness of the AI developed based on just a small part of the data available. That's what we are talking about in the cleaning node. Here comes the reality also of the data available in hospitals or available for physicians. What we are currently collecting in most of our processes, the data are related to the reimbursement schemes, how to reimburse properly the services provided by the healthcare provider, by hospital, for example. And on the opposite side, we have all the information stored in unstructured format, which are essential to build, for example, the new AIs helping us in decision making, like Watson, the other big tools, and we still need this data. There is no such source at scale. For normal situations where we are facing day to day, the standard process how to get these clinical data is about additional burden of medical professionals. So manual work, copy paste from the different documents, different sources, reading them, putting them into Excel in the different places, etc., etc. So that's the reality. To get more real world data, to build the new sources of knowledge, we have to consume more time of the physicians, which is so unavailable. And here comes the cleaning node, which is shortly I may present which is born in clinic. That's the team of the founders, and of course, the highest focus on the we have in a team is now the cancer and the data science. So the combination of the mathematicians and the processes found in the clinic, how to dig the data available already in the day-to-day practice, but without additional time spent by the physicians. How we are doing this, that's very simple. The doctor or nurse or medical assistant is working has been working for before. We are giving to the medical professional life suggestions. So still we are creating the note, the medical note, which been normally unstructured, but at the same time, the cleaning node is creating the database of the information collected by the physician. That's the solution is very simple, seamless. That we don't need any type of the deep integration of the hospital information systems. And it's collection of the 4 main tools, which is Cleaning Node Assistant and a Cleaning Node Annotator. Cleaning Node Assistant works in day-to-day basis with the doctor. That's the only tool which doctor needs. but in fact, it's just a web extension of the browser. So there is no installation in fact behind this. Of course, we are also providing the CleanNote analytics and very important stuff, which is about CleanNote dictionaries and templates. And how does it work? Normally, this is there are 3 steps to do in order to start working with the CleanNote and get real-world data. First is simply go to our website, install the web extension, and you are able to start the work, in fact. The second, just to open your HIS system, any HIS, web-based HIS system, hospital information system, and start writing your note. When you start, as it is showed on the right-hand side, if you start writing the note, we'll suggest you the exact meaning of the phrase, and you may use it as a doctor. Then we'll store it immediately in the database and still keeping the form of note necessary to build the AHR. And finally, once the information is stored in the database, immediately after closing the medical note and closing the HIS, you may analyze the information. No, there is no need to additionally create the extra database or extra Excel sheet. The data are already there, so you may analyze it. Where we are now, with our startup been founded in 2020, which is then we've made a quick step to develop the MVP. We are backed by the business angels and some grants, public grants. Of course, very important in 2020 was the starting of the first POCs in National Institute of Oncology, and this year in the other big hospitals. This year we are now at the phase of seed round, so we are seeking for the new funds to develop the new functionalities. But also this year we joined very interesting project where with the CleanNote we are delivering the solution for the rare cancers European reference network, where the 12 countries, the units for hospital units from 12 countries with 8 languages will exchange the information on particular cancers, which gonna, let's say, test and exploit fully the possibilities delivered by CleanNote. Our business model is very simple. We are SaaS solution. So main approach to the customers is to sell the subscription, of course, but we are ready, and in fact we are now at the stage of enterprise solutions where we are cooperating with the big institutions. We also have in mind the premium model, where we want to share our tool with some limited functionalities, but we want to share for free with the physicians to let them simply use the CleanNote without special limitations, but to boost the adoption, which been discussed before. And of course, there are 3 main channels. So we are selling this directly by value-added resellers or OEM, which we may discuss later. I think the competitors, the co-competitors, that's the big discussions. Who are they? There are big companies, small startups. There are many players are working around real-world data, but no one, as we know, no one is tackling the topic as we are. So prospectively collecting the real-world data. And I think I'm done. Thank you.
Perfect timing. Thank you very much, Rafał, for the presentation. As you have seen, also the part of it, I was convinced I'm supporting CleanNote, so I will not give my remarks. I would rather listen to yours. So who would like to ask the questions or comments or some feedback to Keynote? Who would like to start? Yes, Kazimierz?
No, actually, this wasn't the question. This was the comment that we were not very carefully listening, and the stuff is very interesting and difficult. I know about this company from you before because we discussed this, and it's still the question is how to convince doctor to make use of this. How to make it popular, I would say, or widely used.
I may treat this as a question. So that's the question about the adoption, how to boost the adoption. That's, of course, one of the biggest challenge. What we learned is there are several factors, let's say, bringing doctors to the idea. First of all, we are not changing the way they daily routine. So we are not forcing them to learn the new tool itself or click the new window or something like this. They are simply collecting the node as they've been collecting before. On the other hand, they are giving we are giving to them the data they need, in fact, without additional work. So this is, of course, the simplest way. So just to discuss and show them the real advantage of using the clean node. The second, of course, is the efficiency of the special works. Like we are very much focused on one of our use cases, which is the clinical trials, where the doctor working with the clinical trials needs to collect certain set of data, which is called ECRF, you know it probably. And ECRF is sometimes the long list of different fields and information, which should be collected during the visit of the patient or just after. And it's really easy to forget about some of the information. So we are offering to the doctors to collect all the information during the visit of the patient, creating the medical note in the structured format, which is very easy. And then we are automatically filling the ECRF, which is saving their time, in fact, because they don't need to do the work 2 times. Yeah. So there are many other few others advantages using the clean node, but yes, that's general. That's one of the challenging area where we are still learning how to let's say make the doctors aware that the capture of the data is also very important.
Yes, correct. This clinical trials examples I think is very good because here you can have real how to say clinical data about efficiency of collecting clinical data. So and then spread it in the wider area. So do you have other applications in clinical trials field?
Yes, we started the project, which is still ongoing, where we are implementing exactly this solution. So building the ECRF in the clean node, which is very simple and it's really quick, and letting the doctors using the clean node instead of filling the forms in standard ECRF tools. We are currently in the project, and I will be glad to share the results just after finishing this.
And are you planning to have different protocols for different types of examinations?
Of course. So we are covering almost every single clinical trial may be designed differently in clean node. So there is no kind of limitations in that sense. Yeah.
Thank you.
But in particular, this application in clinical trials is on one hand probably good for fast adoption because most of the clinical trials are multi-sites, also different geographies and so on, but probably a difficult decision from CRO or the sponsor point of view, because this is a very important project and the risk of some errors or failure is high. So maybe I would like to ask Karolina Tkaczyk, what do you think about this solution? Is it something that could be interesting for AstraZeneca? And if so, how this kind of cooperation could be done based on this example?
So definitely having one tool that will be available for all pharma companies would be something amazing, because that would remove the step I mentioned before, but that would require definitely convincing all the pharma companies to use the same sort of tool. And another thing is that security is a prime factor for us. So we would need to know exactly what happens to the data, how the data is stored and collected, because that's a huge liability for all the pharma companies conducting clinical trials. So that there's quite a few factors that would have to be taken into account before testing or implementing solutions like that.
Yeah, may I answer quickly? The security, of course, we are fully aware and fully implementable. We are fully we stick to the expected rules. Why? Because actually the cleaner works with the data and in infrastructure of the hospital, of the institution, or in design solutions. So we are, of course, SAS based. That's the whole original idea. But the models of implementations are suited to the particular institution, and we are ready to, for example, be fully implemented within the infrastructure of the enterprise. But anyway, I fully agree. That's probably, we hadn't time to discuss this before. The security issues and the GDPR and data sharing is one of our topic also in cleaning out how to make it correctly and safely. Yeah.
Thank you very much. I think that the time is up, so we move to the next.
Thank you.
Startup. And the next is Loic Carmon and Biopharm IM. Yes, I can see the slides. Let's go to the presenter mode. Okay, thank you very much. So please start the presentation, 10 minutes, and then we go to the questions.
Let me just, okay. This one. Okay, can you see the slide? In a full,
we cannot see right now. We have seen them for a while.
Yes, then, because I was trying to let me. I was trying to put a laser pointer, which was not really working.
Yes, something. Okay, we can see it right now. If you, okay, great. We can see it in presentation mode. So
okay,
let's start.
So I will keep it like that. So thank you very much. My name is Dr. Loic Carmon. I'm a tumor immunologist from the Weizmann Institute. In the last 23 years or so, I was an entrepreneur in a number of companies, mainly around immunology and tumor immunology. And today I'm going to tell you about a new way in trying to transform cancer immunotherapy. So if we're taking the whole generation that started about a decade ago in immunotherapy, and at that time there was a breakthrough because the first time we were able to show that immunotherapy is actually working, okay? There was a new finding that led a few years later to Nobel Prize winner that actually taught us that the immune system have breaks, and if you can block this break, you are able to achieve immune response. So blocking this break led to a few drugs that become very, very successful, as you can see in this figure. And of course, the Nobel Prize, which is very nice. Many companies were established and many projects were trying to get into the market, but overall, the outcome to patients was very, very poor. So if we are looking at the number of patients that actually benefiting from immunotherapy, it's about 20%. So 80% of the patient will not benefit from immunotherapy, and at some point will develop resistance and have no treatment that will lead to their death. And this is a poor outcome. So why is the problem? What is the problem? Why this is happening? So there are a number of problems. The first one is that cancer cells are not foreign to the body, and the immune system are not able to effectively recognize cancer cells as a threat and destroy them, unlike many other situations, like in virus or pathogens. But in addition, cancer cells and other cells in the tumor microenvironment, stromal cells, myeloid cells, use immune suppression mechanism. So they're trying to stop the immunity or the immune cells to attack the cancer cells. And this is, again, a situation which is very difficult to deal with. And that's exactly what many companies are trying to achieve. And what we are trying to achieve. But what if I will tell you that each one of you, now the listener, actually everyone else, have already the ultimate therapy to eradicate tumor inside you right now? You will be amazed, correct? This is the case. You know, healthy and cancer patients have many types of immune cells that call T cells in them. They are circulating the bodies and they are ready to fight invader, like bacteria and viruses. These immune cells are very active and they are not suppressed. And where did we get these T cells? Either that we were infected with the bacteria or virus and we got protected, or we were immunized. And we all aware of the last epidemic, we all got immunized against coronavirus. So what we are trying to do in Kimbach Pharma, we're trying to solve this problem of immune suppression in a most natural way. We're injecting cancer patient here on the left cartoon with a Trojan horse. The Trojan horse enters specifically into tumor, okay? And inside this Trojan horse, we have decoy. These decoys are small fragments of bacterial and viruses that mimic viral or bacterial infection. As you can see in the left cartoon, the decoy attract the T cells that are already there, that recognize the virus or the bacteria. And these T cells then evade eradicate the T cells, the tumor cells that show the viral or bacterial decoy. So if it's that simple, how come it was not happened before? Because it's not simple, okay? It's very difficult to locate the right decoy. Finding the right decoy, this is actually one of the game changer for a successful therapy in this specific therapies, kind of therapy. So what are the challenges? First, you need the decoy to be applicable for every cancer patient. I'm not sure you are aware of that each one of us have slightly different immune system, and you want the decoy to be applicable to every immune system. This is quite a challenge. Again, you want the decoy to be able to deal with the immune suppression mechanism that cancer cell and stromal cells and the rest of the microenvironment are putting there. And that's, again, another challenge. And the last one, which is also very important, we want to direct the T cell immunity that were generated by immunization with a conventional virus or bacteria vaccine, directed against the elimination of the tumor. So these are three challenges. And why I believe we are able to do so? Because we already pioneered the use of specific decoys, which we call signal peptide domain, and they are superior decoy. We have 7 publications, including clinical studies in human patients that show that these specific sequences are able to do exactly these 3 different parameters. That's why we feel we're able to sort of crack this problem. Our decoy used the HER2 tumor marker as a Trojan horse. So HER2 is a marker which expressed on many different solid tumors. It's a marker which was used for other drugs. So it's known to be a safe target. If you're generating antibody against HER2, you're able to safely giving them to a human. And actually, there's already drugs on the market that target HER2. So this is a safe target, okay? And if we are using Trojan horse to enter our decoy into tumor cells, we are going into something which is much more safer and more promising. And that's a huge market for only HER2 positive tumors, because most of the solid tumors have HER2. So how do our lead product KMB1 looks? So it's made out of 3 components. Each one of them by itself was already been in patient. We're just combining them together, and that's the novelty within new generated IP. So the targeting modules, again, this is the Trojan horse that will enter the payload into the tumor. It is based on HER2 tumor marker. So it's an antibody that will internalize the Trojan horse into cancer cells. When the Trojan horse is in the tumor cells, there is another module as a linker that facilitates the release of the decoy. And then the most important component, that's the novelty, as I said, the decoy. It is based on small pieces of antigens coming from tuberculosis and CMV. And all of us were vaccinated against BCG as child, and we are all, most of us at least, vaccinated naturally against CMV. So we do have T cells against this pathogen in our body ready to fight whatever they think are cells that were infected with the bacteria and virus. So after some initial validation in vitro, we went into in vivo studies in which we tried to mimic the situation in human. This is quite a challenge, a model. And what we did here, we vaccinated the mice with the same vaccine that humans are getting against tuberculosis, and they were immunized. Then following this immunization, we inoculated the mice with the tumor. It's a mice tumor, and it will grow in the mice, but the tumor cells has the HER2 in human, so the decoy will be able, the Trojan cells will be able to enter the tumor, okay? And then we treat them either with no therapy or with the Trojan horse with the decoy, or the Trojan horse without any decoys. And as you can see in the group that got the decoy plus the specific Trojan horse, we see a significantly delay in the progression of the tumor and the size of the tumor comparing to any other group. So again, what happened here is that the immune cells against BCG migrate into the tumor site and start attacking the tumors. But actually, what is even more important is that we are changing the tumor microenvironment. What I tell you before, and that's where most of the companies and most of the technology are failing, is what's happening in the tumor microenvironment. Because in the tumor microenvironment, you have many suppressed mechanisms. If you are trying to attack the tumor with T cells that recognize self-antigen, they will not be very effective. But here, what you will see, that if we are talking about the T cells, generated against the Trojan horse, they are 10 times higher amount, and they are nearly non-suppressed comparing to mice treated with that did not get treated. And the activity is very specific to tuberculosis. As you can see here, we're combining the immune cells against the tuberculosis with the tumor cells, and you see a very specific and strong healing. We have a very strong team, work together on these technologies for over 15 years, took this idea from the lab into patient, which was a very successful treatment. And we have a strong team of consultants in all the aspects of that are relevant to the development, the biology of cancer, the biology of tuberculosis, clinical practice and development. So we are all set to conquer this goal.
Are we close to be finished?
Yes, this is the last slide, and actually I finished. So just in summary, We have about 60 years of combined tumor and anti-infective immunology. The technology is actually based on 3 components that each one of them was already validated in patient. It's a plug and play technology, which can go from many different products in different cancer, and it's very strong IP. And the product, as I showed you, shows some very nice potency in initial preclinical studies that validate the mechanism of action. Thank you.
Thank you very much for the presentation. Right now, the floor is open for questions, remarks, comments, advice. So who would like to start? Maybe I will start with the questions. Where right now in your development, and how do you finance? Because these kind of innovations are not an easy one to be financed.
Yes, absolutely. So at this stage, we got some grant funding, and we got some angel investors, but at the moment we are looking for a Series A, which will able to take us into the next milestone, which is getting into IND enabling studies. Then, of course, there is a lot of things you need to do until you get to patient.
Mm-hmm.
So basically, angel money and grants.
Okay. And after the Series A, what's your plan? Continue with VC or some other options you consider?
Yeah, so we are quite flexible. It's either that we are talking with VCs that will be able to sponsor the development until the clinical studies, because after the initial studies in patient, it doesn't need to be a very huge study. It can be for a small indication, local injection. There are many different scenarios in which immunotherapy is given locally, and that makes the whole strategy much simpler. Then the inflection point can be much higher. Another strategy is to go and to partner the project with medium-sized pharma that are looking for pipeline. So we are quite agnostic to the best solution, and we are happy to interact with whoever can have a synergic solution with us, of course.
One hint here, maybe Karolina Nowak will add a bit more, but I think Poland is a quite good place to run clinical trials, especially in this field, because we have on one hand very centralized system. So with oncology, we have these levels of reference. And on the other hand, there is this network under the Medical Research Agency, 23 centers, so we can work with all of them, with some of them, but have like one contract, one point of contact as well. And also the agency has calls for grants for clinical trials, so maybe worth to consider.
Okay.
Would you like to add something more here?
Yes, thank you for the great presentation, and I would like to ask about the milestones. What are the defined milestones for the next 3 years?
So there are a number of milestones. At the moment, we need to finalize that what we have now is the best product, because it's always a place for some improvement and more improvement. Of course, it will be better, but you need to decide at some point that this is the lead product that will go for clinical studies. Then after you do that, that's a milestone. And one of the challenges here is to mimic the situation in a model that will convince the investor that this is the right drug for them, okay? And for example, we worked on mice because we wanted the full immune system to be there. Another strategy is to work on human tumor in mice. That will answer a different question. So all this model is something which is very relevant for VCs. And once you are finishing all this, because we have done only few of them, then that's a huge milestone, which will bring in many more investors. Then, of course, the other milestone is to complete the IND enabling studies, okay, and reach an IND or equivalent in Europe. That's a regulatory path. When you have there and you have the green light to go into patient after you've done tox studies, then of course this is a huge milestone. All these milestones have a check pay. And to do toxicity in this kind of molecules are not cheap, of course, but it will, of course, raise the valuation of the company. So that's another milestone, and of course, to reach a clinical study, that's the milestone which you really have the biggest, I would say, inflection point.
Okay, thank you very much.
I have the questions as well. Which may become the tip. Did you consider, or maybe did you use some kind of programs like offered by, for example, EIT Health, for example, the Catapult?
No, I'm not aware of this specific project. Are you talking about EU program like the Horizon? It's the same.
No, it's the EIT Health. It's a kind of project. Yeah, it is a project financed from EU, but this is kind of organization. And so if you Google the EIT Health Catapult program, it will bring you to the kind of contest where you can apply. But and I'm mentioning this because your project is very well advanced. So I think it requires serious consideration, and also it's very difficult to actually access, as Robert has pointed out. And EIT Health, this program may be the right one of you if you are in your strategy consider using this type of programs to catapult you somewhere else.
Yes. Okay. Thank you very much. But I just want to mention again that one of the advantages that I see in this project that it's not completely new. We are using 3 components. Each one of them were already in human. We are just combining together. Of course, it's a new project and there are always risks, but comparing to bio project, we did a lot of validation by using this 3 components that were already been validated, each by himself, at least for safety in humans.
Okay, thank you very much.
Thank you.
I think we have to speed up a little bit. So the next presentation by Paweł Kucman, Evidence Prime. Paweł, can you check if you can show the slides? Okay.
Yes, I can hear you, and I just shared the slides. Hopefully you can see them.
We can see it.
Great.
Yes, you can start 10 minutes presentation, please, and then you go to questions.
Sure. Thank you very much. My name is Paweł Kucman. I'm the co-founder and the president of Evidence Prime. We are a Polish-Canadian AI company, and our mission statement is keeping the healthcare evidence-based. And actually, that's something that we treat very seriously. And the tools we are going to see soon are exactly about that. So first, about the problem that we are trying to solve. So evidence-based healthcare is facing a huge informational overload. If you have seen my today's morning presentation on drinking from the fire hose, so that's exactly what really happens in this domain. So the rate of scientific output grows exponentially, which I also shown on the diagrams in my previous presentation. And to keep up with this amount of new data and make use of other data sources, like for example the real-world evidence that one of my predecessors was showing, the humans need help from an AI. And our solution is that we help the healthcare community, which means a lot of things, because it starts from doctors and ends on corporations, regulators, academia, and so on, to reduce unknowns and to reduce outdated information using the AI tools, which help finding and synthesizing the best currently available evidence in a continuous way. So through that, we help people make good decisions about healthcare based on the most recent knowledge. That's really about what the evidence-based healthcare is about. So the core evidence-based healthcare process that we are kind of trying to solve consists of first, it starts with the problem and the evidence, which nowadays is mainly the results of the clinical trials, and going through a process which is called the literature review. Means that we are defining the problem, finding the evidence, which usually means tens of thousands, sometimes hundreds of thousands of publications, screening them to select only these that are really relevant to the topic, which usually is much less than 1% of the initial load, extracting the data in order to do some meta-analysis on them, and then evidence synthesis comes in, which ends with the report. It might be a HTA report, it might be systematic review publication, depending on the case. Then there is an additional process, which after meta-analysis, which includes many systematic reviews first, goes into the people that analyze all that information, again, doing the meta-analysis, doing statistical analysis on it. They define in textual form how to deal with a certain condition or how to apply certain procedure. And then it goes to the decisions to the doctors in the form of, for example, guidelines published by medical associations or ministries of finance, of healthcare or WHO, or it goes to the dissemination just as publishing on different publishing platforms. And one thing more, that if we apply this process many times throughout many years, frequently, then we have something which is called either living review or living guideline, which is really what should happen, because then the guideline really reflects the current medical knowledge for a given case. So that's what we do, and we have two core offerings. So the first one is something which is called the Laser AI. It is really end-to-end healthcare literature review tool. And it allows the users to access the evidence through AI assistance in a continuous way. And the second one, older project, and because of that, we are already a market leader in this small, narrow domain, is the development and publishing of healthcare guidelines. The tool for that is GreatPro, which lets the doctors make good decisions. And the GreatPro already has 100,000 users worldwide, and most of the important organizations like WHO, like most of the ministries of healthcare worldwide, in one or the other way, use the tool. Laser AI, on the other hand, is a new offering that was a product of our grant that for the last 3 years we were operating, and we just finished it. It is a tool for semi-automatic continuous literature reviews and data synthesis. We already have 4 pilot customers, 2 in Germany and 1 in the US government, and also the Cochrane Canada is one of them. And the thing is, from the business perspective, is that the market here is about 50 times or even more larger than the one in guideline development. Therefore, even if we are market leaders for the GreatPro market, we are really looking forward to scale in the Laser AI domain. So our customers up to date, there is quite a lot of them, ranging from WHO, for example, through many universities and organizations. And they are really in multiple segments of the healthcare. So we have governmental agencies, we have medical societies, including the largest one, the American College of Physicians. We have insurance companies, publishing companies, we have HTA agencies, and then hundreds of academic groups worldwide using us. But many of them, majority of these are in the domain of GreatPro, so guideline development. So, but we are looking for extending also into new areas which are more in the domain of systematic reviews and the literature reviews in general. So pharma consultancy agencies, pharma corporations, and medical device corporations are also natural customers for our systems, because they have multiple departments that can use, or do use actually, different techniques to speed up the literature reviews that they have to do, very often for compliance reasons. The market opportunity for laser AI is just limited to systematic reviews and HTAs. It is about $560 million per annum, and the direct potential of sales here is up to the 52 million. We could potentially target that. There is also the EHR data market, which is much larger, but and we do have a technology for that market. A bit competing with one of my predecessors, I would say, but we haven't yet started to explore the sales potential here. Just focusing on the first one. The competition, there is a lot of competition, fortunately, because we don't have to educate the market. But the problem is that actually the biggest competition is no tool at all. So, or rather using generic tools like Excel, Word, or EndNote, which can be used for any type of really office work. So most of this, especially smaller groups, but also the larger ones, do not use any real tool for that. Fortunately, there are also more serious competitors, so like Distiller SR, which is in case of systematic reviews, that's the market leader, and they have pretty good tool and even better sales team, but we managed to beat them twice already, so we're on the good track. Our sales strategy is to focus our enterprise sales, and what I will show in a moment, we also focus on safety, security. So this helps us and then guides us through the enterprise sales. Since we perceive laser AI as our main source of income in the coming years, we did that. So we focused on the large organizations, governments, and corporations. Generally, we're looking for annual recurring revenue of $50,000 or more. And we are in process of building the sales process and sales department because we need to free our founder resources to do a bit more, not in the sales as we do now. Financial wise, we are on the verge of the break even, almost there, and then we hope that, as in this diagram, we'll get to the traction point, and our sales should speed up very seriously over the next 3 years. As I said, we focus on security. It's a choice. It's our way to address, as Joanna said before, the enterprises. So we applied for FedRAMP certification. It's a US governmental security certificate, which we, about 1.5 years ago, we started the process. It finished in March this year. We are the only company in Poland which has this certificate, and I would say that we are one of the few, or even the first in Europe that achieved that. We are now in process of SOC 2 and ISO 27001 certifications, just to make clear that that's something that people can trust their data with using us. In the next 3 years compared to today. Today we are market leader in guideline development. We have early release of laser. We are a team of 25. We have this FedRAMP security certificate. We have 1 patent filed. We completed 1 grant, and we have the R&D center, the so-called CBR in Poland, so ministerial status. And we are almost at the verge of break even. During the next 3 years, we are going to integrate the tool for systematic reviews and decision-making together. And we want to target 5 million of recurring revenue in the next 3 years, yearly, of course. We want to be market leader in literature reviews for large organizations. So for smaller ones, probably not, but for large we want to do that. We want to grow, but not dramatically, probably up to 35, maybe 40 people. We want to have all the required certificates from the security perspective. We are in the process of preparing next patents. We want to have 5 of them in the next 3 years. And we also are going to get to fight for having at least 2 next large research grants. And we are also looking at the spin-off. I don't think we can make more than 1. That would probably make us not focused, but 1 is probably going to take place over the next 3 years.
Okay, Paweł.
And the founders, okay.
There was a gong like 3-4 minutes ago, so you're consuming the question time right now.
Sorry. So yeah, so that basically just the last thing, we are aiming at Series A within the next 2 to 3 years. So we are very interested in talking to the investors, and especially the ones that would like to fill gaps in their offer with our offering. And we are looking for the partners in EU grants. Sorry for speaking. That was rude. Sorry.
Thank you very much. I'm opening the stage for questions. I think just one, because we have one more startup to listen to. Are there any questions?
I have one.
I have one.
Okay, so 2 short ones or one long? Who has the shorter one?
Very quickly, I'm not sure if the answer will be short.
Yeah, go ahead, Kazimierz. Yeah.
My question was about the business model, because you presented a lot of competition, and I wonder how are you going to compete with the quality, or you have a kind of idea for the better business model?
So we have much better technology, that's for sure, and it's already I already talked about that in the previous presentation. So that's already proved by the third parties. And I think that our security model and the UI that is very much tied into artificial intelligence, that's a very hard thing to do. These are the differentiators from for example, Distiller, that lags very much in that respect.
Okay, thanks.
Rafał.
Yeah, it's going to be a comment or an end question and probably promise of the future talks. What you mentioned, Paweł, about the guidelines is something what let's say moves our hearts very well, because we understand the guidelines are very important. It comes from knowledge, from the literature and the education. And we've been one of our use cases about how to check whether these guidelines are properly implemented in day-to-day routine of the physicians, and Clean is ready to do it. In fact, to provide the information. So I think there is more. You just mentioned that we may be kind of competitors, but I don't think so. We are much closer to cooperate. Yeah. So talk to you soon. Thank you.
Great. Thank you very much.
It would be great to see this kind of outcome from our conference, our discussion. Maybe it's a good time to say that there is a very good platform that you can also connect and start this cooperation. I mean the LifeScience Open Space platform. Thank you very much, Paweł. We are moving to the next presentation. Kai Berner from Noah Therapies. Kai, can you test the infrastructure?
Of course.
We can see you, we can hear you, and some slides on the way. Not yet. We cannot see your slides.
I can't. It says is interrupted.
So maybe Anna, could you check if Kai has the rights to present? We see that you are starting sharing, and it looks like click twice to open full screen and then stops. Nothing happens.
Maybe I share your screen and give you remote control. Sorry? Or maybe I share your presentation and I give you remote control of it. Okay.
We see the Klaster logo right now. We don't see the presentation yet.
Sir, please give me a while.
Okay, we see the presentation. Oh,
that's me now. Now.
Almost there. Almost there.
Do you see it now?
Yes, we can see. Okay.
I got to go back. Sorry.
The floor is yours for 10 minutes.
Okay.
We have to finish the session at 6.
I'll be quick. Okay, thank you for the opportunity to speak today. So my name is Kai. I'm a medical doctor, cancer specialist by background, and I want to introduce you Noah Therapies. And as a medical doctor, I am happy to share with you that cancer has become curable, and there is proof to that, even if this might be a bold sentence, but the survival rates across different entities are the proof. For example, in breast cancer or blood cancer, almost 90% of patients survive today. And the reason for that is that today we do oncology very precisely. So oncology has become extremely precise, which means that we target tumors on a very cellular basis. So we do molecular targeting, have a lot of different medicaments in the field that can help us to target tumors and therefore get these survival rates that I've just shown you. But we have to keep in mind that the way we do oncology today also has consequences. And the consequence is that today there are over 20,000 highly individual patient journeys that someone has to manage. And this is not so easy. So everyone who is in that field, in the oncology field, and has to work with all those patient journeys, feels those consequences. Pharma companies or other R&D companies who have to develop the medicaments to even improve the survival rates for those who are not among the 90%, they face costly trials. They don't know where to recruit their patients. They don't know what happens in the journey of a patient. So this is why the trials become very costly and there are high fail rates, and it has become quite inefficient. For the doctors who have to manage it, they are completely overburdened. I think we heard a lot about that today, how to adopt a digital solution to the market, or how to make it attractive to doctors, and that it's very difficult because they are very overburdened. And this is one problem. This is one reason for it, because precision medicine is extremely complex. And in the end, it all sticks with the patient, because today the patient is in the driver's seat, especially in oncology, where diseases have become chronic and not acute anymore, and they most often feel a loss of control. So what we did with precision medicine is that we have built a very complex road system of different patient journeys. And Noah Therapies is a navigation system for those patient journeys. We help empower patients to go through that journey and to go through that disease, and herewith also accelerate drug development. And this is how we do it. In the end, it looks like an easy tool, an easy app that everyone knows, but that is highly adaptable to any cancer medicament that is on the market at the moment. And there are 400 plus medicaments on the market. This is possible because we have a modular medical algorithm that can generate for every patient a highly individual journey, so that they are the ones who can master and who can manage. This means that we offer them everything. This is in German now, sorry for that, but I'm gonna guide you through it a little. So they get to know everything that they need to know, meaning that we have automized calendar functions. So we are always a step ahead of the therapy, and they get everything they need in terms of complementary care, when to have an ECG or bloods drawn, when to have an echo, when to have controls. And how this works is actually that we incorporate simply standard protocols of all 400 medicaments. This is what such a protocol for triple negative breast cancer, for example, looks like, and we incorporate this into our modular backend and then individualize it from there. This is how this works then. So we take the guidelines and therapy standards and trial protocols. So because it's not only the medicaments that are already on the market, but also the medicaments that are still in trials are based on guidelines and protocols. And this is what the app can do, or what the navigation system can do. And from that basis on, we automate the whole journey so that the patient herself or himself can go through the therapy actually without asking everything a nurse or a doctor. And the interesting thing is, as we navigate and how the system is built, we know exactly at what point in time of the therapy a patient is. So when today a patient onboards, I can tell them, you are at day 112, for example, because of how the system works. And so this is why we can gather a lot of data and gain insights from it. And this gives us the opportunity to follow a twofold business model, what we do. So we are on the one hand a navigation app that hospitals are looking for to support their patients, but also the ones who do trials are looking for to support patients who are in trials, or to support the principal investigators who are running the trials in the clinics. But at the same time, with the data we gather, we are also a SaaS platform where we have a lot of very comprehensive and correlatable data that are very interesting for R&D companies. There are some solutions on the market that already do so, and now it gets quite interesting, keeping in mind the discussion earlier. What all these solutions do is they bet on site centricity. So what they do is they put a solution into hospitals. And as everyone has now maybe understood, and as a doctor, I can also say that having a new solution or a new digital solution is always more of an effort. And today there is no time for more of an effort. So what we do actually is we are just there, but the doctor doesn't have to do anything. The patient is guided through the therapy and is guided through the onboarding completely alone. And this is what also made us fast. We have started in April this year, so we are a very young startup. We have now onboarded the first clinics that use us with all their patients. And this is where we use a network effect. So we go into the clinics at the moment, the patients use us, and we can also deliver trial support for them because it's just a protocol. And with new trials, new clinics get to know us and onboard us. This is our roadmap. So we, as I just said, we started in April this year, have now 6 clinics on board, even more now. This is a little older, this slide. Yeah, we are planning to get also CE certified and several other things that are necessary to become more of a patient product. I want to show you now, as the first viewers, what we have found out in the feasibility trial. We have had 20 patients that consented for the usability trial, feasibility trial, and we navigated 13 different therapies. And the interesting thing was that the quality of life measures that we have taken have improved across all the patients, with highest improvement of almost 45%. This is what we have found out in terms of global health score. So there was an increase of a global health score of 72.4%. And interestingly, and this was something that we already thought would happen, we could lower nausea and vomiting for those patients using us during chemo, because this was our first approach now on the app. That we guide through this side effect of nausea and vomiting in a holistic way. So we offer them not only everything they need to know from a conventional medicine background, but also from a complementary background that is integrated in the conventional medicine. Because we, in our interviews, and me as a doctor, I have already seen that there is a huge gap. Everyone gets normal medicine, but when they are looking for something to do on their own, they are left alone, and this has big problems because they do something they shouldn't do. And what we do is we do integrative medicine, so we guide them through everything. And this is how it looks like in terms of nausea and vomiting. There are two things that have gotten worse, especially pain and social functioning. So we can also use the app to see a little what patients need more, how to improve ourselves. Yeah, and after only 7 months, this is all the outcome we have. I think that's quite quick. And this is all based on a great team that is behind it and that combines everything to build a medical product today. Me as a medical doctor, but also a tech lead and a marketing person who is very good in communicating to cancer patients what they should know, and a data scientist who aggregates and generates insights from our data. And especially we were fast because we are aligned on one mission, that the patient at our core accelerates the research for the medicine of tomorrow. We are not fundraising right now because we are onboarding clinics and are very busy operatively, but we are looking for everyone who wants to guide us a little, who wants to be part of shaping how precision medicine is delivered today. So I would be happy if 1 or 2 of you would get in touch to discuss 1 or 2 things. Thank you.
Thank you very much for the presentation, and especially for timing. And I'm opening the space for questions.
Okay, so I have a question. Thank you for the interesting presentation. And my question is, what was the biggest challenge you met on your way?
I think the biggest challenge is to align a team behind a vision, because the vision is not what we can monetize easily early on. Yeah, but we are now aligned. And I think the second thing is data security and data privacy. So starting with clinics, it is not only ticking all the boxes in terms of GDPR compliance and data security, data compliance in general, but it's also about the ethics behind it. Yeah, because I think that's still a big question that a lot of people are worried about.
Thank you.
Yeah, I have also a question, because it's a very nice idea to move the burden from the doctors to the patients, who may be also interested in and benefit from the solution. But you have to win the trust, which is much more difficult in this business to consumer, in this case, model. How do you do that?
Well, actually, we use the clinics to do so. So what we do is we onboard a clinic. So in this automation, we onboard the clinic and let them, give us their individual. They can upload individual videos and individual content. So the clinics are on board, and as we just are a solution that works within their standards already, but besides what they do, they save time. They are very happy to have us, and we individualize for each clinic. So this is where the trust comes from, and the patients then just use us because their doctors tell them to.
Okay, thanks.
And my question is about the business model, who is paying for that, and how do you want to build the traction? Because the hospitals usually are not the fastest one in terms of procurement.
Yeah, we are in a good, the question of why do it now is an interesting one, because in Germany there's a new regulatory shift coming up until 2025. And every hospital has to show their digital strategy or that they follow a digital strategy. So they have to have 1 or 2 solutions ready that are digital and that, for example, support patients when they are not in the hospital, and that's what we do. So we the time to move there is now. Hospitals have gotten money from Germany to spend on that, and this is what they are happy to do because they have to.
Okay, good. Thank you very much. Are there any questions? Kai? No? Kai, thank you very much for your presentation, and especially the speed of your development is really, really impressive. So keep going, fingers crossed, and let's go to the summary of the session. Who would like to start with the summary? I see that we don't have so many panelists still with us. So Kazimierz, would you like to say something at this moment?
I just wanted to be the last one to thank you to be with us, but okay, I may say that I'm again the same like it was 1 year ago, impressed with the quality of these presentations. So what I can say, because we changed the rules and we organized this on the platform, please make the use of the platform to reach those great people, those brave people, and make connections and try to benefit from that presentations. Thank you, Robert, for organizing this for today, and thank you, our panelists, to come here, especially to have you in a studio, our beautiful studio. That's from my part.
Yes, actually, I had the question to you. What is the place that you are sitting in? It looks like a cinema or a theater.
Yeah, this is a cinema. This is a cinema room in LifeScience Park. So we have here a special place for meetings, which requires big screen and allows for presentations. This is the second time we organize our studio here. But basically, we are in LifeScience Park in Kraków.
Okay, good to know. Thank you very much. Carolina, would you like to say something at the end?
Yes, I have great hope that Warsaw Health Innovation Hub will have impactful influence to bring and to implement this kind of solution not only on the Polish market, but only on the Central Eastern European market. Thank you.
Thank you very much. And maybe last word from StartUppers. Would you like to make some summary, Rafał?
Well, the short summary is that very good to have such an opportunity to join the LifeScience open space. These kind of activities are bringing more focus on startups in healthcare, which is not probably needed but so much, but it really raises the attention of all the players, especially the big players, the big pharma, big companies willing to really disrupt also the market. So thank you again. I think that's very good audience to talk to.
Okay. I think that we have had very comprehensive view, the discussion from different points of view, like government, academia, doctors, startuppers, investors. So very glad that LifeScience Klaster, and especially Kazimierz, that you are making this happening, because I think we need much more discussion in very diverse environment. We see also people from abroad joining us, exchanging some knowledge, some ideas. So thank you very much for making this happen, LifeScience Klaster, and eager to get more, to hear more tomorrow and the following days. Thank you very much.
Yes, I can only add to that. Thank you, Robert, for running this, leading this session. I was looking a few moments ago to the map because I have a continuous view how many people from where are present. There were more than 167 recently when I looked, and they were all over the world, including Japan, including Canada, USA, and somewhere in Africa even on the map. I will present this tomorrow morning, the short review of today's day.
Well, I think in Japan it's early morning right now, isn't it?
Yes, I think so. Yeah, exactly. So I was surprised actually.
So it seems that there are very motivated people. Thank you very much once again. Have a good evening.
It's
And
2 o'clock in Tokyo.
Yeah. Not an easy hour. Thank you very much.
Thank you. See you tomorrow.
See you tomorrow. Take care. Bye-bye.
In Kraków, a remarkable journey awaits you through time and culture, science and innovation. From the foundations of an ideal city, Nowa Huta, golden dream of socialism, to the medieval city center. Besides monuments entered on UNESCO Heritage List, Kraków has something else to offer. People. In Kraków every year, close to 200,000 people complete their higher education. This includes almost 6,000 foreigners. These are specialists in almost every field, from IT to biotechnology. No wonder that global players open their affiliates in Kraków. Kraków has become the center for modern services in Europe. Kraków is also a mecca for innovative business. From small catering units to internet startups, a few of them have become world-famous brand names. Our town is called the Polish Silicon Valley. By investing in infrastructure and transport systems, we draw closer to each other. Local public transport is considered to be the best in the country. The blue trams and buses carry 250,000 passengers each day. The map of the town shows that museums play a special role, especially those that have outstanding collections uncomparable with anything else in the world, as for instance the Museum of Aviation or the Wawel Royal Castle. Here you will find in this part of Europe the largest library with access to books that constitute not only Polish heritage but also that of all Europe. Old and modern architecture are the town's strong assets. In these interiors, not only are extraordinary concerts held, but also great sports and artistic events. One of these extraordinary places on the map of Kraków is the Malopolski Garden of Art, an area for the implementation of innovative art projects combining many fields of art. Kraków, due to its center of congress, has become one of the leading places in Europe where both cultural and trade events are organized. Kraków is increasingly associated with excellent cuisine. Its restaurants offering both traditional Polish food dishes as well as those representing other, often distant lands, gain recognition amongst residents, tourists and culinary experts. Hidden in the medieval cellars or located in sophisticated townhouses, vibrant centers of social life may be found. Kraków is a town which is unique, intriguing and surprising. A unique mix of history and modernity inspires action. Experience Kraków.